Hi everyone. Very good morning to everyone. So let me welcome you for the first ever ADL AI Summit organized by the Asiata Digital Labs, Analytics and AI Unit. So we have designed a summit to bring together some of the Asia's most innovative pioneers in the fields of AI to share their expertise and train the next generation of AI professionals. So to accomplish this task, we are here today to mark our first step in this glorious summit journey, the AI workshop. The purpose of this workshop is to assist you in grasping the fundamentals of AI. We will provide you with unrestricted access to the knowledge and resource you need to bring out in AI projects to life, whether you are implementing it or optimizing that. Today, it's going to be a day full of knowledge, excitement, experience, demonstrations, and success stories. So we have our main sponsor for ADL AI Summit, Amazon Web Services, AWS, to kick off the morning session. Then our silver sponsor, Dell Technologies, will conduct a session on AI in enterprise. Finally, the day will be concluded by a session of our gold sponsor, Snowflake. So to start the day, let me introduce our first distinguished speaker from AWS, Senthilvel Palraj. He is an enterprise solution architect at AWS. He has over a decade of experience in the industry. So I will not take much time in introducing him. Let him amuse the audience with his presentation. Over to you, Palraj.
All right, thank you so much, Harshini. Thanks for the introduction, and welcome you all to the Axiata Digital Labs AI Summit. I hope you are all excited. I know it is a Saturday morning,
Yes.
So thank you so much for joining on Saturday morning, and of course, ADL for arranging for this such a large event. My name is Vel Palraj. I'm from AWS. I'm going to conduct this AI workshop this morning along with my peer, who's AI ML solution architect lead from India. Praveen is here with us. Before we even get started, hey Praveen, maybe Praveen, you wanna go ahead and introduce yourself?
Hi, hi everyone. My name is Praveen Jayakumar. I'm a principal solutions architect here at AWS, and in this role, I also lead a set of machine learning solution architects and data scientists in my team. I'll be happy to be here, and I hope this is an exciting session for all of us. Back to you, Paul.
All right, thanks, Praveen. A little bit about this workshop. I will introduce you to the agenda for the day. The morning is going to be AI workshop, and in the afternoon you have another session. The morning is going to be well-packed session on AI ML on AWS. I'll promise you you're going to learn a lot of things. Before we get started, I just want to pull up my screen here. Just bear with me for a second. Hope you can see my screen. Ashni or Praveen, can you confirm?
Yes, we can see your screen.
Yes.
All right.
Yeah.
Great. Let me just minimize things here. All right. So before we get into the topics, I heard that there's going to be about more than 3,000 plus participants going to join this event. That's really exciting. A number of participants. I'm very glad to see the number of people are getting interested on AI ML. You might be already practicing, and you might be learning new stuff. For both of learners as well as the beginners and expertise, this session is going to be useful. We will introduce you different AI services and platforms from AWS for machine learning. We also heard that there are a lot of people joining from Sri Lanka, from where we are hosting this, Axiata Digital Lab is hosting this event. We also have people joining from Bangladesh, Malaysia, Singapore, and even few participants from US. So we are simultaneously casting this event on YouTube, LinkedIn. If you are watching there, hi everyone. So let's get started. Before we get into the session, a little bit more about myself. My name is Vail Palraj. I'm the Enterprise Solutions Architect. I currently work with the Dialog, which is a part of Axiata Group. I spent more than a decade in US building large-scale, distributed application, and also I helped a lot of customers with their ML journey, building ML ops to accelerate their machine learning journey. Currently, I'm based out of India, supporting customers in India as well as the Sri Lankan region. Let's look at the agenda for the day. So this workshop runs till 12:30. You do have a short break around 10:30 a.m. First, the session, I will be introducing you to AI ML on AWS. I'll walk you through different AI services in particular. Around 11 o'clock, Praveen will take you through Sagemaker, which is our machine learning platform. And 10:30, you're going to go on a break. And then when you come back at 10:45, Praveen will walk you through how to build, train, and deploy models using Sagemaker. Around 11:30, he's going to walk you and take you through a live demo of creating Sagemaker instances from where you can run training jobs, notebooks, and also you can he will show you how to train and deploy models and also optimizing hyperparameters. So that's a well-packed session topics for today. We have got a lot of contents to cover, so please stay with us. Hope you all had your morning coffee. If you have not, maybe take a coffee and stay with us. It's going to be really exciting learning today. So let's look at the agenda for the next hour or so. Now it's 9:15. In the next 45 minutes or so, I'll try to cover these topics. First, I will introduce you to the different AI ML offerings from AWS. And then particularly, I'm going to jump into AI services for different areas like vision, speech, language, recommendations, forecasting, and fraud detection. I will also give you some use cases for these services as I even explain these services. And then I will share a few customer stories, as some are personally that I worked with. Some I will reference a few customers, to make relevance of these AI services. Before we even get started, let's talk about data. You know that for the fact that data is fueling everything, including machine learning. It is the fuel for AI ML. But I think the world is currently running on data. You see data everywhere, and data is being used everywhere. But just with the plain data, it is of no use, right? So if you have a data, it's good. But if you can't make an insight out of it, it's no use of having the data. So that's where the analytics and machine learning comes in place to get the most out of data. And you either with that insight you can build a new business, or you can improve your business. At the end, you can add value to your customer. So in my experience, I have seen successful organizations are mostly driven by data. They do this by these three different areas. They first remove silos between departments. That is, silos that makes it hard to access data between departments. In the legacy system, you might see your data in an organization will be siloed and sitting in different departments. repository and not able to access it. So first, these organizations break these silos, and then they democratize the data that anyone within the organization with the right use case, they can access these data. They enable them to access these data, so they can make analytics out of it, or they can build machine learning models. The third layer, the third step is organizations using machine learning and AI, artificial intelligence, to get insight out of these data. So for any organization to be a data-driven organization, these are the three key phases that we see, that we recommend. The first step is to modernize your data infrastructure. You might be having a lot of data in your on-premise data center. The first thing you might want to do is you want to move all the data to a modern cloud data center like AWS. The second step is liberating the data by moving it to a data lake house architecture. On AWS, we call it as S3 data lake, which is primarily running on S3, which is our simple storage service. So you basically dump in all the data into our data lake, and from there you can access all these data with the proper access control. You can specify who can access and when can access, and then based on the use case, they can access these data and build analytics and machine learning out of it. And then you also have to enable machine learning to your developers and data scientists and ML practitioners with the right set of tools to access these data and build machine learning models. So with these three major steps, you are basically enabling your teams to build advanced machine learning models. With that, you can solve very complex problems. We are going to look at a lot of very complex problems that has been solved using AI ML in the next hour or so. Before this session, you saw the video where they used ML to identify and match whales, which is a pretty cool use case as well. You can think of many use cases like that to build to create those use cases using machine learning and artificial intelligence. Before we get into the AI services, let's clarify these terminologies or technologies. You have probably heard these technologies described in a number of ways. So let's take a step back to level set on what they are. So artificial intelligence, otherwise called as AI, is a way to describe any system that can replicate tasks that previously required human intelligence. Almost all AI systems today are created using machine learning. Machine learning uses large amounts of data to create and validate decision logic known as model. The AI system then feeds data, these input data into that model, and the model outputs human-like predictions or classification, for example. So machine learning is the underlying technology that is powering intelligence system. AI can be created with ML, but right now, ML is the primary method for creating AI system. Similarly, ML can be used for more than AI, but right now, the majority of ML is AI related. The last one is deep learning. Deep learning uses a technique known as a deep neural networks, which mimics how human brain functions. So this lets AI systems address more complex use cases than was previously possible. Deep learning becomes the subset of machine learning, and machine learning becomes the subset of artificial intelligence. With artificial intelligence, it becomes the superset of all of these, technologies. So we are from AWS, from Amazon. I hope you used Amazon.com or maybe watched a movie or your favorite, TV shows on Amazon Prime. You may not notice this, Amazon sells more than 4,000 products per minute, which is huge amount of products per minute. And it handles like 1.6 million packages every single day. Just imagine that's a million packages every single day. Think if you have to handle this amount of packages manually, which is going to be practically impossible. And if you used Amazon Alexa, which handles billions of interaction each week. All these were made possible because of the machine learning. So we use machine learning to a larger extent to power all these capabilities on the Amazon.com, Amazon Prime, as well as on Alexa. Amazon has been applying ML in areas such as personalization and supply chain for more than 20 years. That's 20 years a long back. And ML is an integral part of Amazon. If you look at the picture on the right side, this is a cool thing. We used a drone to automatically pick up a package and deliver to a delivery location, maybe a house. We used AI ML to power this drone. In terms of our mission is to take our rich experience and expertise with machine learning across Amazon and put it in the hands of all organizations, every developer, data scientist, and researcher, to make it easily accessible and usable for you all. And then the next 45 minutes or so, you're going to look at some of the AI services, and I will walk you through how easy it is to use. You can see a lot of company icons. You can find your favorite company in this deck. So we have more than like 100,000 customers. They are currently using AWS for machine learning, from large enterprises to hardest startups you can think of. I personally worked with the companies such as like Intuit, HPO Max, and few others on implementing ML models using MLOps framework. Currently, I'm working with the Dialog, which is part of Axiata Group, on building some new exciting ML use cases from the telecom side. So this is our ML stack. We got the broadest and most complete set of machine learning capabilities. I will walk you through this whole stack very briefly, but during this AI workshop, you're going to learn in detail the top two layers. So our ML stack consists of 3 layers. The bottom one is meant for the expert practitioners who would like to use the framework of their choice. And we offer infrastructure to run these frameworks. For example, you can pick some of our advanced CPU and GPU based instances. And also you can use our deep learning AMIs, which is Amazon machine images. So with the AMI, we package everything, all the software dependencies you need to quickly get started on these virtual machines, and you can build your machine learning models out of these instances. If you want to build everything from scratch, this is the way to go. But this is going to be the most complex layer in the stack. The middle one is meant for anyone, any developer or data scientist or machine learning engineers. It gives you the ability to easily build, train, and deploy machine learning models at scale. It removes the complexity from each step of the machine learning workflow, so you can more easily deploy your machine learning use cases. Anything from predictive maintenance to computer vision to predicting customer behaviors. So if you have a custom use case, and if you want to use a framework of your choice, or even Sagemaker offers built-in frameworks, algorithms that you can use to build models. With the Sagemaker, you can label data, you can collect, you can do data collection, you can store the features that you collected from your data sources, and of course you can train and deploy a scalable model on Sagemaker. Praveen is going to take you through this stack, this layer, later part of this morning. He's going to give you he's going to show you how to build models, and also he's going to show you a demo. The top layer is what I'm going to focus today on this session. The top layer is all our AI services, which allows you to easily add intelligence to any of your applications. This absolutely needs no machine learning experience. These services are, you can easily access with the API endpoints. You simply call it from your application code. You pass in either image, video, or text, or scanned documents, get insight out of it. And you can quickly achieve the machine learning out of the box. So you see there are services for vision, speech, language, chatbots, forecasting, and recommendation. This is not all. We have a lot more services, but on today's session, we are going to cover these. In addition, as a bonus, I'm going to also talk about forecasting if time permits, because sorry, the fraud detection if time permits, because it's such a cool feature. It's a super important feature for you all. If you are from the larger enterprises. So all these AI services are basically pre-trained AI services, which requires no ML experience or anything so far, anything as such. You can add intelligence to your existing applications. Simply you call these APIs as I said earlier. You pass in the required image or video, you get the insight out of it. And we continuously train these underlying ML models, which are running these AI services, and we make it more better services every single day. All these services are serverless and managed. What does that means is that you don't have to provision or manage any of the infrastructure to run these services. You simply call these APIs and you get insight out of it. And since you pay per use and you pay per just for the use or the time you spend to get prediction, for example, these services are very cost effective. All right, so let's start with the first service, which is called Amazon Recognition. It's a deep learning based image and video analysis service. With Amazon Recognition, you can easily identify objects such as bike, telephone, building in your image or video, or you can even identify scenes such as parking lots, beach, city, if you have any of these in your image or video. You can also identify people, and you can with people, you can identify their gender, their age range, if their eyes are open or closed, are they wearing glasses, maybe even their facial hair. You can also identify text in your, video or images. You can also identify activities in both images and videos. Activities like if you see a person, you can identify, are they smiling? Are they happy? Are they sad? So all these insights that you get out of your image and video, which is not possible before without ML, you may have to put people to watch your video or image to get this kind of insight. But with recognition, you get these out of the box with a simple API call. Think of a lot of use cases you can build around these, features. So one of the coolest feature, one of my favorite feature is you can detect inappropriate content from your image and video. For example, you can detect nudity, graphical violence, or even weapons in your image or video. This will help you to make sure your platform, excuse me, for example, if you are hosting a image hosting website and you allow users to host their pictures on your website, you can use this service to filter out any inappropriate content as per your terms and policy, and then filter out all those content and allow only the appropriate content to the website. One use case, if I would like to share, is the Amazon Recognition has been used to fight human trafficking. The way they use this service is that they search thousands of missing people images, and then they match it with their database of images which are subject to human trafficking, and that helped them to fight human trafficking, which is very humble to see this kind of use case with the AI ML. And since we are living in the COVID times, you can, with the images, you can also identify if a person is wearing personal protective equipments or not. Also, you can do facial comparison. For a video, you can in fact do a tracking. If the person is moving, you can track that person. So let me show you a quick demo. I'm going to show you a video. This video has been recorded at a nice neighborhood. You see few cars parked and one car is about to move. And you see on the right side, there is a dog, someone is walking the dog. We ran this video with Amazon recognition. Let's watch and see what the recognition is able to find in this video. You do see that recognition is able to identify the persons. There are about 5 people and they are walking. So it's able to track these people. And it is even able to identify the dog and also the car. So imagine the use cases that you can build with these insights. So you feed in the video, you get the insight, how many people are there? Are there any objects like car? Like if there is any dog, if it is your dog, you can allow the dog to get inside your house. You can use this use case with your security cameras. So you can build a numerous amount of use cases with this. So earlier I talked about a use case where you can use recognition to filter inappropriate content. So let's look at the architecture, and I will show you how easy it is to integrate and get this done. For example, so here your users uploading their pictures. In the backend, this is how your solution architecture looks like. You upload the pictures when the user uploads into your site to S3, which is a simple storage service from Amazon. And then you can use AWS Lambda function, which is a serverless function. You simply write your code and upload it to AWS Lambda, which will take care of provisioning infrastructure and run the code when needed. So the Lambda can get triggered when you upload an image to S3, and then it will call the Amazon Recognition API, and it will pass the image. The recognition service will return based on the image, whether if there is any inappropriate content, it will return a score. And based on the score, you can either decide to post the picture if it is safe to post to your website. If not, you can send it for another manual review, or you can right away reject it, right? Think of this use case, for a social media site where if you want to filter out inappropriate content, and if you think of putting people to watch, a lot of these disturbing contents in images and videos, it's going to be a very tough job to do. Nobody would like to do this kind of job. So here you can make use of AI ML to identify these inappropriate contents, and then make decisions around it. Next thing, I know most of you are developers. You might be wondering what is going inside this Lambda function. I've been telling you that it is very easy to call these API, these AWS AI services with the API. I'm going to show you how easy it is with a simple Lambda function. Hope you can see the code. It is a very simple Lambda function. It got only maybe 20 lines of code. With this code, what we are doing is we are importing a bunch of libraries, including Boto3, which is our Python SDK. This is a Lambda function. Excuse me. So here we are, creating a variable called client, and we are calling a recognition API. And particularly, we are calling detect custom labels function, and we are passing the image. And this function is going to return the custom labels, which is another feature. You can detect custom labels are nothing but if you have if you are running a marketing event like this Axiata Digital Labs, you can retrieve these images and identify custom labels like your company logo. And then this will tell if there is any custom logo your company logo present in this image, then this whole process is getting automated. Becomes very easy for you to analyze thousands of images in a second. So with this simple Lambda function, you can call all of these AI services and get insight out of it. Just remember this is how you call most of our AI services, which I'm going to show you in the next upcoming slides. The next service we are going to learn about is Textract. Amazon Textract extracts text, handwriting, and data from scanned documents. It's very easy to implement. If you have thousands of scanned documents, think of how you would be doing as of today. Historically, to extract information from scanned documents, we will hire thousands of people or maybe hundreds of people if it is less amount of documents, and they sit through and read through every single document, and they retrieve information. Sometimes you might have used OCR, which is optical character recognition, which is not very effective. To some extent, it identifies information in the document, but OCR will give you everything that extracts information from the scanned document as a plain text. Then it's very hard to relate the information in the document. So with Amazon Textract, which uses machine learning, and also it uses OCR to automatically detect printed text, handwriting, and even numbers in a scanned documents. It even able to identify key value pairs. For example, if there is a document and there is a first name and my name being Vale in the document, Textract will give you this as a key value pair. Then you can take this key value pair and load it to a database. Then think of all the use cases that you can do with this database and having key value pair in the database. It also can detect tables in your scanned document, and it will retrieve table as a table, and then you can load it to a database as well. And there is one of my favorite feature with the Textract is adjustable confidence threshold. With this, it gives you a confidence score based on what it extracts. So with that score, you can make an informed decision on how do you want to use this information. All AI ML services gets better over the time. It may not be perfect for all the use cases. There are some edge cases. If it is not really trained, you will get a low confidence score. Then you can maybe put additional review. But Textract works really perfect for scanned documents. We trained this AI service with the millions of documents. It practically works for many of the business verticals and many use cases. Let's look at some of the use cases for Textract. If you have millions of documents and if you want to index and search, Textract is the way to go. You simply run all these documents, and then you index and all these documents, and you should be able to search easily through your with your application. For example, in European countries, telecom operators use Textract or use similar AI ML services, to scan through millions of contracts to comply with the GDPR. In this case, you can use the Textract as well. If you have business process automation, for example, if you are handling tax filing, tax returns, and you can use Textract to identify or extract information from the W2, which is nothing but tax documents, and you can further build automation with this information. It makes it very easy to use those information that you extract from these documents, and then you can build the business use case around it. Let's look at the next two services, which is meant for text. Amazon Comprehend is a natural language processing. It's an NLP service that uses machine learning to uncover information in unstructured data. Excuse me. Um, Amazon Comprehend has pre-trained models that identify entities such as places, people, brands, or even events. It determines the language of the text. It automatically detects the language. It also extracts key phrases. With key phrases, if you extract social media feedback from about your product, it can extract key phrases like whether the customer is posting a positive review or a negative or a neutral review. So with that information, you can you can do a lot of things, right? If the customer is sentiment is negative, maybe you want to see what is going on with this product and improve that product. This is all made possible with the Comprehend. Comprehend can also uncover meaning and relationship in your document, as well as in your social media feeds. The next service is Amazon Translate, which is pretty simple, which translate your text from one language to another language. Currently, it supports about 70 plus languages. It includes I know in Sri Lanka, Sinhala and Tamil has been spoken. It supports both of these languages. It also supports like Thai, Malay, and many more languages from our Asia Pacific region. It can identify language automatically as well. One of the cool features that I like with Amazon Translate is custom terminology. So with custom terminology and active custom translation, it lets you to customize machine translated output. You can use custom terminologies to define how your brand names or model names or other unique terms gets translated. If you have if Axiata Digital Lab has to be translated into ADL, it can do that. We use the custom terminologies to do that. Here comes Amazon Poly and Amazon Transcribe. Amazon Poly turns text into speech. Amazon Transcribe turns speech into text. Poly is, if you wonder what Poly means, is a stereotypical name for parrot in North American regions, hence the name Poly. You know what parrot does, it repeats everything, right? So you can turn any text into speech using Poly. You can create application that can talk and build entirely new categories of speech-enabled products using Amazon Poly. One of the cool feature of Poly is that Poly brand voice. For example, for your organization, if you want to create a specific exclusive brand voice, you can do that using Amazon Poly. To do that, you would work with our Amazon Poly team. They will create a NTTS voice exclusively for your organization, and then you can use that voice throughout your application across your organization. Transcribe is speech to text service. See, if you look at audio files with computers, it's very hard to search and analyze audios, right? The first thing you want to do is turn audio into a text file so that you can do indexing and do analytics on top of those text files. Historically, to convert audio into text, you would hire lots of people. They listen to it, and then they transcribe those audio into a text file. But with Amazon Transcribe, Transcribe uses a deep learning process called automatic speech recognition, known as ASR, to convert speech to text quickly and accurately. It also generates timestamp. So for each word that it transcribes, you can go back and find the source or the time frame in your source audio. Think of use cases like subtitle creation. You can do that. I'm going to show you a cool feature, how to create a subtitle using these services at the end of this session. You can also use custom vocabulary. With custom vocabulary, you can add new words to the base vocabulary to generate more accurate transcription for your domain-specific words and phrases like product names, technical terminologies, and names of individuals. The next service we are going to look at is Amazon Lex. I'm pretty sure some of you might have used, Amazon Alexa. Alexa is powered by Amazon Lex. Amazon Lex is a service for building conversational interfaces into any application using voice and text. You can use Lex. Lex will enable you to quickly build sophisticated and natural language and conversational parts. So if you want to build a chatbot, you don't have to build all the speech as AI ML services to turn text into speech or even understand speech. You can simply use Amazon Lex. It's very easy to integrate with many of the application. It easily integrates with your mobile device or web application, chat services like Facebook Messenger, Slack, or even Twilio SMS. It is a very cost-effective service. You pay per use. Let's look at some of the use cases for Amazon Lex. You can be creative and build a lot of chatbots, but these are some of the use cases we ideally see or mostly see. So we've seen Amazon Lex used in contact center for both the customer services as well as general queries. If you have a application where you let users to do account inquiry or even get generic information, you can use Lex to power your application. And you can do enterprise grade or even IoT related applications to deliver these features. So personalization or recommendation is my favorite AI service, if you ask me. I hope you might have used Amazon.com. Some of you might have watched movies or TV shows on Amazon Prime, or even used Alexa devices. You might have seen a recommendation in Amazon.com or in any e-commerce site, right? All these recommendations are made possible with the help of AI ML. And also, if you watched Amazon Prime, you do see recommendations, based on your watch patterns. You do see recommendation on what you can watch next. Even if you're watching this video on YouTube, on the right side, you can see all the recommendations. These are all basically powered by AI ML. Based on your historical watch patterns, these recommendations are coming from AI ML models. Right. At Amazon, we have been using AI ML for these, recommendations and personalization for the past 20 years or so. I still remember, I first purchased my Nikon DSLR in 2012. After purchasing the DSLR, in the bottom, I saw there is a recommendation to purchase a lens as well as a backpack. I still use, today, those are very useful. Since people purchased a DSLR camera with these accessories, these came as a recommendation, and they are pretty useful to have with the camera. If you think of camera being very expensive, very easy to break, right? You want to have a backpack, and of course without lens you can't use the camera. Amazon is a pioneer in the field of personalization. We got more than 20 years of experience. So what we have done, we listen to the customers. And they want to do similar, recommendations in their, in the business domain they operate. So we bring in all the knowledge base, huge expertise, and then we created a service called Amazon Personalize. Again, it is a very simple to use. It offers a very high quality recommendation. All you do is you simply integrate with our, personalized service. You bring in your data, and then we build your custom model. In the next slide, I'll show you how that process works. But it is a very easy to use service. It can work for different custom scenarios. You can train a custom model based on the scenario or the use case that you bring in. Let's see how Amazon Personalize works. The thing you see in the middle, right, all these steps, we call it ML workflow, which are very hard thing to do. If you are a machine learning engineer or a data scientist, you will understand what it takes to do all these steps, right? But Amazon Personalize takes care of doing all this behind the scene. So you will be focusing only on getting all the data and feed these data into Personalize. And then we will take care of identifying the data. For example, in this case, to get a recommendation, you may want to bring in your user events, interactions, like views, signups, conversations, with the timestamp, and also item metadata like details of articles, products, and videos, as well as user metadata. So with all these data, Amazon Personalize in the behind, it inspects these data and it identifies the right features that is relevant to make recommendations, and it selects the right hyperparameter, and of course it picks the right algorithm in the backend as well. It will train and then host and create a real-time endpoint for you. All this is taken care by Personalize, so you don't have to worry and manage all these steps. So you will get a customized personalization API. That is the API you will be using to get recommendation out of it. This is a one-time thing. You feed in and you train and you create these customized API, and then you will in real time you can get prediction. Sorry, you can get recommendation for your products if you are selling products, or content if you are streaming media contents on OTT platforms. Let's look at some of the use cases, right? User personalization is basically recommendations. You might see it on any streaming platform, including Amazon Prime. Similar items, if you purchased a product on Amazon.com, you will see similar items. Here in this picture, I searched for a rug, so you see a lot of similar rugs being displayed. So I can make an informed decision, right, whether to buy the one I searched for or the ones that is displayed underneath. And also you can do personalized ranking as well. Now let's look at the forecast. So Amazon.com, the retail business, in the business of selling products, forecasting demand is the crucial or most important thing in the supply chain management, if you think of, right? So from 1995, we have been using these traditional statistical methods, which are basically business rules to predict the demand, which worked best for products like staple products. But if you think, it is not really scalable, right? That's when we started using machine learning from 2007, and then from 2015 we started using deep learning with the machine learning to forecast for demands. These deep learning, in fact, brought in like 15 times improvement in accuracy. So with this, machine learning, we were able to forecast demand for regional versus national demands, and we can identify or predict, slow-moving products and what is going to be a new product, and even you can forecast for, forecast demand for a seasonal products. So seasonal products is something you sells only during certain amount of days of the week or in a month. Then you can plan your inventory for the same. So with all the learnings with this, forecasting for demand, we brought in, we are offering a service called Amazon Forecast, which is again API-based service. You bring in your data and you build a custom model, and then we will host a custom endpoint for you. This offers you, this is again a fully managed service. You don't worry about the underlying infrastructure. We will take care of managing all those, and we'll make sure that it is highly available. And the forecast and the demand which you get out of it, we make sure that it is highly accurate, and of course it is very easy to use. When it comes to data, you might be wondering, you bring in your data, you were wondering how do we handle your data? So when you bring in your data to train these forecast model, we use KMS to handle your data. So all the data you bring in is not shared with any customer, including Amazon.com. And the model that we build out of your data is again not shared with anyone. So your data, your model stays with you. We do not share with anyone else. So for forecast, if you look at it, to build a forecast model, you would need a historical data and related data, which are basically time series data. For example, you may want to have a sales, call volumes, inventory, and also price, promotions, weather, and custom events, and then item-specific metadata like color, city, country, category, author, and author name. All these, information is going to help you to build the forecasting, models. What we do underneath, very similar to, Personalize, we do the ML workflow in the backend. We load the data, inspect, and identify right features. We use AutoML to pick the right ML algorithm, and then we host a model or a customized, forecasting API for you. All you do is from your application, you call this API, and then you get forecasting out of this, which is very easy to do, right? You don't have to manage any of these, ML infrastructure. So with the forecast, you can do even handle very tricky forecasting scenarios. Like you might have seen, if you're a data scientist, you might have seen a lot of missing values, right? So what we do is we replace missing values with 0 or not a number. We can also, forecast can also handle new product launch as well as product discontinuation. Based on the time series data, it can forecast those information as well. It can also handle irregular seasonality and also highly spiky data. So the forecast is tested for all these different tricky scenarios, and you can use forecast out of the box for these scenarios. The last service that I'm going to talk today is Amazon Fraud Detector. So if you think globally, right, organizations are losing has been losing tens of billions of dollars, for online fraud. Online fraud can range. There's a lot of online fraud. The major category that we see is on the payment side, account registration, and also different types of abuses. If you look at the payment side, you might have seen the pattern that we see is bad actors using stolen credit cards to make payments, and also prepaid cards being used for compromised or intentional non-payments. With prepaid, it is easy to buy things and not make payments, right? Those kind of scenarios you can detect well before and act upon. If you relate this use case with your telecom industry, this is one of the use case we are currently working with the Dialog team. Very cool use case to prevent international roaming fraud, which might be costing millions of dollars. We are trying to build a model which can identify when someone is internationally someone is in international country and they are using roaming packages, and see if they are really using it. If there is any fraud, we would be able to detect, like if they make a lot of calls, or if the pattern is not right, we should be able to predict those frauds. This will help you to save millions in international roaming fraud in the telecom domain. Account takeover, you can think of compromised username and passwords or API keys. In the field of AWS, we never recommend you to store the tokens in GitHub or anywhere that can get compromised, and if it lands on a bad actor, they can access your accounts. So, but you can use a fraud detector to detect these kind of activities and take actions on these activities. Abuse is another most common use case for fraud detection. In Amazon.com business, right? We've seen people return a lot of products by abusing it, right? We detect those kind of abusive returns, and then we take action on those. The AI ML has been helping us to control these kind of abuses around product returns. How a fraud detector works, it's pretty simple, similar to Personalize, as well as recommendations and forecast service. You would bring in your data, We will take care of the rest. We will load the data, inspect, and then we will create a custom model for you. And you will call this custom model with your data set. You can get fraud. Let me show you a simple API call. I've been talking, all these services are API driven and very easy to use, very easy to integrate, right? So this is showing you a simple example here. Guest checkout is one of the famous, or I should say, common use case for fraud. Fraud. You can detect this kind of fraud using our fraud detector. What you do is, send a few details like the IP, email ID, other payment information through your website to fraud detector. It will give you a score, whether it is a fraudulent or a non-fraudulent activity. Then if it is not fraudulent, you can approve the payment, or you can reject the payment. Think of like how easy it is to integrate. It's a simple API call. If you have to build this kind of fraud engine, it's going to take months and months of time, right? So this fraud detector makes it easy to implement the service in a very fast manner. I'm going to show you one of the solution that I built for one of my customer. The use case here is pretty simple. So this customer have a lot of videos, marketing videos, product information videos, primarily in English, but they do have market, good amount of market in Asian region. They would like to translate these videos with a subtitle to cater these market. So we built this solution which basically takes all these videos, automatically converts the video into audio using a service called Transcoder, which is again another AI service which converts video into audio. And then we used Transcript, which extracts text from the audio file. And then we used Translate, which translate from English to Mandarin. You can think of Sinhala, Malay, or Thai, or different languages. You can simultaneously translate to different languages. We used to translate, and then we generated these subtitles. Then we posted that subtitle on the video. So here we used a bunch of Lambda functions to call these API services, which I explained in the previous slide, right? You can create a simple Lambda function, you can call these API services, and then you can handle the output that you are getting from these AI services, and then you can handle the logic within the Lambda itself. The one that you see on the left side is the AWS Step Function, which is a very useful function if you think in the line of orchestrating multiple steps. Here, to create a subtitle, we need to orchestrate multiple steps. Step function makes it very easy to build these kind of workflow or business processes that will run video from translating, sorry, from creating audio file to creating a translated subtitles. So, and I know some of you might be working, will be participating in AI hackathon. Think of, if you have to build multiple steps, check out this, AWS Step Function, which can make it easy for you to automate that workflow. With that, I would like to share a customer story. C-SPAN is an American cable and satellite television network. It actually televises many proceedings of United States federal government, as well as other public affairs programmings. They used to translate, recognition, transcribe, and comprehend. They used a bunch of these services, and then what they did, they automated video indexing. So they use these services and they run it across millions of videos, and they created this video indexing platform. With that, what they were able to achieve is that, right, if a person from a particular constituency, they can search for a representative from their constituency, and then they can listen to all the videos that representative is talking, and then they can make an informed decision. Think of the power that brings in, right? So you can think of many use cases. with the combination of these services, you can build such use cases. So with that, we are coming to the end of this session. If you want to continue to learn, please check out our AI ML webpage. And also, please do check out this AWS blog post. If you are thinking of few use cases, right, probably we would have helped a few customers to solve those use cases. And once we solve those use cases, mostly we will write a blog post and we will package those solution, including the serverless subtitle. We package that as a solution, and then we put it in the GitHub repository. You can fork that GitHub repository and then reuse the code. It will make it easy for you to reuse the whole solution if you want to implement a similar solution. And also, we have this AWS training and certification program. Check out different trainings available. If you are interested in machine learning, we have a AWS machine learning certification. Please take a look at that as well. With that, we are coming to the end of this session. I know there's a lot of things I covered within 45 minutes or so. I hope you found this session useful. We covered only the AI services. Now we are going to get into Sagemaker, which is our ML platform. To do that, I'm going to welcome Praveen. But before that, thank you so much, everyone who's watching on Zoom as well as on the streaming platform, and wish you all the best with the hackathon if you are participating on the hackathon. With that, Praveen, do you want to take over?
Yeah, thanks, Well. I hope I'm audible, and I'm going to take over the screen as well.
All right, let me stop my screen. Cool.
Let me open up my screen. If you can just give me 1 minute. Well, can you confirm if you could see my screen?
Yes, I can see your deck as well as I can hear you properly.
Okay. Thanks, Well. Thanks for that session which you did. So now what we are going to do now over here is that it's about for the next 23 minutes we will talk about giving introduction to SageMaker, and then where and why SageMaker is used. We will be going for a 15 minutes break after that, and once we come back, we will speak about what are the different features that SageMaker kind of provides you for you to do your machine learning development, right? So right from the different features, we will talk about the various features that SageMaker has. And then what we will also do is that I'll showcase you a demo. I mean, we will go into SageMaker and then work out how do you do the training, how do you do a real-time deployment, right? So how do you do hyperparameter optimization? So we are going to go and talk about it as well. We will look into it as well. And then in the last 10 minutes or 15 minutes, what we will do is that we will try answering some of the questions that people have already started asking in the Q&A section. So we encourage you to ask more questions in that, so that we will answer those questions towards the end. So that's the plan which we have for now, right? So given that, we will just get into it. This is our AI/ML stack, which Vail kind of spoke about to you a few minutes back. So we have this AI set of services which he talked about. So as you would have seen from that, these are AI services are the ones where you really don't need your data scientist or a machine learning engineer to use it, right? So as a developer, you call few of the APIs and you start consuming these services basically, right? And but when it comes, but there are a lot of use cases in the industry, right, or in your domain you might have, where you might need to develop your own models using your own data, because that might be very domain specific basically, right? So that is where we have this second layer called Amazon SageMaker, which we are going to kind of deep dive into it today, right? So even before we go into SageMaker, you would see that doing machine learning development is kind of complex, right? It's not easy. It's not like a traditional application development. So let's see some of the challenges that is there in the machine learning projects, basically, right? First, you need to collect and label the data, which is a huge challenge. Most of the algorithms or models that we use are supervised algorithms, right? So you need to have a way to label the data. And a lot of these algorithms demand a large amount of data, basically, right? So let's say if you're using a computer vision kind of a project, kind of a model, then you need to label quite a lot of images, either put a bounding box around it based on the type of the problem you solve. And then you need to collect and prepare the data as well. So there are various techniques like EDA, exploratory data analysis, and other things you might want to do on the data to make sure that the data can be used for the training purpose, actually. Once you have done that, you need an ability to store the features of the data, basically, right? So the feature engineering part of it you need to kind of store it. And then you need to check the bias for the data. So lot of data can have bias built into it without even our knowledge. There could be data that might have bias into it. And then very recently, if you see, a lot of governments are coming out with a regulation specifically to look into bias in the data in the machine learning and the AI world, right? So you would see lot more regulations coming around the data that you have been using. So checking bias becomes a very critical part of your machine learning process, actually, right? So once that's done, a data scientist needs to have a way to build their model, actually, right? So you wanted to have some kind of a notebook environment where you could easily build your model. And then you need to pick up your algorithm based on, there are people who have preferences over a certain framework, let's say TensorFlow or a PyTorch, or if you're working in a statistical algorithm world, it could be scikit-learn, XGBoost. So you need to, based on the problem that you're working on, you need to pick up an algorithm. Then you will be training your models, basically, right? So but training the model involves a lot of things like hyperparameter optimization and other things that you would typically kind of do it. And then you take the model, let's say if your modeling is successful, you're happy with all your evaluation results, then you take your model and then kind of deploy it into the production, right? Unlike a traditional software, your job doesn't really end over there, right? Because there is this concept called model bias and data bias that could start happening. So sorry, not the bias, the model drift and the data drift that could start happening, so that your model is not producing any more good results, basically, right? The results from the model is not great. So you need to continuously keep monitoring and managing your models, so that once you have this kind of a bad results, or if it's an issue that is happening, you have to retrain the model and then again back into the same process and then deploy it back into production, basically, right? So there are a lot of steps that is involved in managing the machine learning project. So that is where SageMaker, the second layer we talk about, SageMaker kind of comes into picture. As you could see over here, a SageMaker is it's a complete it provides you an end-to-end solution to all the problems that we spoke about, right from labeling your data, helping you to collect and prepare the data, do the feature engineering part of it, ability to store the features, checking for bias. We provide a notebook environment for you to build your models, actually support various different types of frameworks and algorithms, and then train your model and then help you to do the hyperparameter optimization. And once the model is deployed in production, basically, then we also help you to monitor your model for any basically data drift or a model drift that is happening, right? And also provide you the ML ops capability, basically, right? At the end of the day, it is no fun in running your model just in your notebook environment. You have to automate it. You have to take it to a production environment using an automated process, basically. So that's what CI/CD or ML, we call it, the ML world, we call it as an ML ops, basically, right? So all of this you could achieve using Amazon SageMaker as a service. And that is what we are going to go into some of the details today, actually, right? So kind of as Vail was talking about, a lot of customers using our machine learning services, you would also see that there are tens and thousands of customers using Amazon SageMaker. You could find a lot of the customers which you might be customers as well, right? So you could see quite a lot of customers. This is just a subset of customer that I'm kind of showing it over here, right? Formula One, if you're interested in the sporting world and following races, Formula One is a very key customer. In fact, if you're following Formula One races over this last few years, you could actually see that you could see that there's a lot of stats that is coming out in the live race that is all powered by AWS machine learning services, right? One of the cool features. I mean, I follow Formula One extensively. One of the cool features that shows up is that what is the tire condition of the race during the race. It shows for each of the driver what is the tire condition, right? How much the tire has been deteriorated, whether they still have like about 20% remaining or a 30% remaining. All of this information, they use models that is developed using SageMaker, and that is what we kind of see over there, right? Pretty cool, a lot of cool use cases that you can look into it. So now let's get into SageMaker features. So as you could see over here, I've separated this into 4 different pillars actually, right? So the first phase is the prepare phase, where we will talk about how do you prepare your data for your training purpose. And then once you do that, you need an ability to do the build part of it, basically, right? So that is where you will be using your different frameworks and other things that you will be building it. And then what we have is the training and tuning part of it, where the actual training of your model that happens, right? And then the deploy and manage part of it, right? We will quickly try to cover some of the features that is listed out here, some of the key features that is listed out here, and will be useful for your hackathon purpose as well. What we will do is that once we come back from the break at 10:30, I mean, once we go at the break at 10:30 and come back at 10:45, we will spend a lot of our time around this build, train, and deploy part of it actually, right? So that being a very key thing we will spend. But for now, let's cover some of the key features that is provided by the SageMaker, right? Let's get into the prepare phase. So the prepare phase, as I said, this is where you're preparing your data for your machine learning models, basically, right? The first feature we have is called SageMaker Ground Truth. So what is a SageMaker Ground Truth? That is that it's a complete end-to-end labeling service, actually, right? So what do I mean by that is that, as I said, in supervised machine learning models, if you're developing, you need a labeled data that should be there, right? So let's take an example of a computer vision kind of a model that you want to, algorithm that you want to use. Either you might want to do a labeling of the data, or you might want to do object detection where you should have a data that is, you put the bounding boxes already, or it could be a video kind of a data, right? So you're getting a video stream in the frames, you divide the video stream into multiple frames, and you want to put a bounding box or identify the objects that is there. So for all of this stuff, you need a labeled data, right? So that is what SageMaker Ground Truth provides you to help you. It helps you to label your data. I mean, I gave computer vision images and video as an example, but it could be a text as well, right? So you're trying to do some NLP problem. There again, you need to have a labeled data, basically, right? So as I said, SageMaker provides you an end-to-end capability to do this labeling part of it. It provides you an UI. For example, let's say you have 50,000 images you want to do a labeling on, basically, right? Bring those images into our object storage S3, and then you could use the ground truth. So what ground truth provides you is an UI. For example, if it's object detection that you have to put a bounding box in the object, then what it does is that it provides a UI through which the human labelers, right? You might have, in your organization, you might have 5 or 10 people who you might have dedicated to do this labeling part of it, right? It provides them the UI, and it also provides them the tools that they can use it to do this labeling part of it, basically, right? And some of the very interesting tools that Ground Truth provides, which helps a lot of our customers, is that it has a process by which it can automatically help you to label the objects, actually, right? So there is an auto labeling features that you could select. So once you do that, what happens is that 20% of the images, you will be sending it to the human labelers, right? It gets the output of those images, and then it internally trains a model then it tries to label the remaining 80% of the images by itself, right? The ground truth tries to remain the remaining part of the images, it tries to label it by itself. And then in this process, it might find out that some of the images accuracy, the labeling is accuracy is less. So it will send it back to the human labeler, get it, again, the model gets trained, and then the whole process continues, right? So what I have seen is that if you have this large number of images, if you use the specific feature of ground truth, the auto labeling feature of ground truth, 25% of the images only needs to be done by the human labelers. 75% of it can be done by the ground truth itself, actually, right? Making it, it helps you a lot in saving cost and time as well in that process, actually, right? Very interesting feature. I request you to kind of look into it, right? So the next feature we will talk about, is a feature called Data Wrangler. As a data scientist, one of the things that we continuously keep doing, or we spend a lot of time, is that doing a feature engineering, right? Something happened. So the kind of doing the feature engineering part of it, that is where Data Wrangler can help you with it, right? So what does a Data Wrangler does? We provide you a visual way of creating your feature engineering, actually, right? So for example, let's take a couple of scenarios. What as a data scientist we do in the feature engineering. One thing, you wanted to fill the missing values, actually, right? So your data, you might have in the tabular data that you get, you might have a lot of missing values around it. So Sagemaker can, this Data Wrangler can help you to identify the missing values, and then it provides you various options of how to fill up those missing values, right? So you can average it out. There are multiple techniques that a data scientist will take, right? So all you have to do it is that you can go say that, hey, I wanted to, it will provide you different options of how to fill up the missing values. You just select, hey, for this particular column, I wanted to use this technique, and then say yes, done, basically, right? So that part of the feature engineering is created, actually, right? And then let's take a second example. One of the other things we look in a particular column is that look for outliers, basically, right? Outlier detection is very important, basically, right? How do you want to handle outliers, right? Let's say if I identify a particular column and then say that, hey, okay, I wanted to do I use a standard deviation and clip off a certain part of it. Again, we provide a UI way where you can provide you different ways you can do, different ways you can detect outliers. You select that, boom, that's it. Even that part of the feature engineering is made available to you, actually, right? Like that, you could do 300 different feature engineering. You could also bring in your own code as well, your own logic into the Data Wrangler. Let's say if it's very domain specific, very your use case specific, and it's not very common, you want to bring in a piece of code, again, Data Wrangler kinds of allows you to do that as well, right? So at the end of the day, what Data Wrangler does is that it provides you a code that you typically as a data scientist would have written for the feature engineering, right? With all the transformation and everything, it kinds of gives you a code which you can take it and start using it when you want to do a pre-processing of the data, that where you have a raw data, you want to process it, and the data that you want to give to the training, right? So that part of the code that you would write is what Data Wrangler provides you, but in a UI way, driven way, you could do it. And towards the end, if you have some time, I'll also show you some of the features of the Data Wrangler as well, right? So that brings into our next capability called Sagemaker Processing. So as you would know, one of the key things, even before training, as we talked about, is that from the raw data, you need to create a data that is feature engineered, basically, right? In fact, according to our estimates, what we have seen is that close to 70% of the time, people actually spend in making sure that the data, the feature engineering is where you would be spending a lot of the time, right? So it's a very critical aspect of it. What Sagemaker Processing provides you is that, before even going into processing, right, I'll talk about how people used to do this processing, actually, right? Either you could have a Spark kind of an environment, Hadoop-based Spark environment, where you might do this pre-processing of your data, or you might have written some Python code. So even in your notebook environment, you might have written some transformation. So your data size is huge. So you provision a big instance, and there you would be running your pre-processing job over there, right? That is the problem which SageMaker processing tries to address. So what we provide you is a set of APIs. So what you can do is that you can call the API. In that API, there are a couple of things you need to say, right? If you have written a Spark code, you have to say what is the transformation Spark code, right? Or if you have written a Python code that for the transformation you have written, you can very well mention that, or you can take the Python code that you generated out of Data Wrangler, and then you could use it in this API, right? So in this API, what you will do is that you will tell where your data is present, right? The raw data is present. What is the transformation code that needs to be run? And where, once the transformation is done, where you want to copy the data back into it, right? Because you need the data for training and other things. And then finally, you will tell what type of a machine that you want to run this transformation on, how many CPU and how many memory, right? That once you give that information, SageMaker will spin up that instance for you, the bigger instance that you wanted to do the processing. Copy all the, let's say if it's a Spark code, it will put a Spark container, copy your Spark code, or if it's just a Python code, it will create all the libraries that is necessary to run this particular code, and then copy the data, do the transformation for you, writes the output back to another, the output folder, and that big instance that you've gotten, right, it gets destroyed after the transformation is done, basically, right? Let's say to do this processing, it took about 1 hour to do the processing. You will be charged only for the big machine, only for that one particular hour, basically, right? So that is what SageMaker processing kind of helps you to do that, actually, right? So let's talk about our next service, Feature Store. In the last about 1.5 to 2 years, if you're closely following the machine learning world, Feature Store has become a very, very critical component of a lot of customers, actually, right? So what is the, if somebody who's not aware of it, what is the use case for Feature Store? So typically in a large organization, or even in a medium organization, you see that there are different data scientist team that is there, basically, right? So one team might be solving a particular problem, other team might be solving another problem. But let's say they are all trying to solve a problem for an enterprise, right? So there are a lot of common features that will be used across these data scientist team, right? There is a good chance that there is a lot of features that can be used, and that is where Feature Store comes into picture. What Feature Store does is that it allows you to store your features in a common repository, and then anybody can search for features, and any other team can search for those features and start using those features, actually, right? So there is a concept called online and offline Feature Store. Online Feature Store are typically used during the inference time. So during the inference time, you need a particular feature, just make an API call to it, get it, and the latency is super fast over there. And then you could start serving your customer, basically, right? And then there is something called an offline Feature Store, which is typically used if you want to do a batch kind of a prediction, or during a training you wanted to use certain features, then offline Feature Stores are provided. So SageMaker both supports online and offline Feature Store, and another good part is that you can create a Feature Store which is both online and offline as well, actually, right? So that's the capability that SageMaker Feature Store kind of provides, right? Now let's talk about SageMaker Clarify. Clarify is a solution which does two things. The first thing it does is that it helps you to identify bias in your data. And the second thing it does is that helps you to doing explainability aspect, right? As I told earlier, a lot of your regulatory bodies are coming out with regulation which talks about on the data bias itself. So Clarify can help you to identify bias in your training data. So that is what it does. And then we also, what we have done is that we help you to do explainability of your model. So underneath we use this Shapley. Probably most of you might know about this. Shapley is based on a game theory. It's an open source framework. So we have taken the Shapley and modified it in such a way that we provide you which particular feature has more as like more importance in your particular model, right? All of this in a graphical manner to represent. We have provided the Shapley capability also in SageMaker Clarify, actually, right? So now what we will do is that we will get into this the second part of the session, build, train, and deploy. But I think we are right at the time now where we will be taking a break. So it's at 10:30. So we'll be back at 10:45 to go through how do we do a build. We will get into a lot of details about, you will see a lot of code and everything around how to do a build, how to do a training, and then how do you finally deploy using SageMaker, right? So let's take a break and then we will be back at 10:45.
Yes. Thanks, Praveen. Thanks, Red. So yeah, as Praveen said, we'll go for a short morning break and we'll be back and Praveen will continue his session. Yes.
It's gonna be. There she goes, there she goes. Woo! 1019! That whale was first seen in 1988. We've been watching her for half her life. My job is the best job in the world. My name is Lisa Steiner. I'm a marine biologist. I've been studying the sperm whales in the Azores for the last 33 years. The Azores are pretty much on a line between New York and Lisbon, pretty much in the middle of the Atlantic. I live in Fayal, which is one of the islands of the Central Group. I'm probably one of the original sperm whale geeks, basically. The level of my techiness is probably a 1. The tail of sperm whale is kind of like a fingerprint. They have a distinct shape to each tail, and you can match them over time. I've been watching a few of the whales now for almost 35 years. We started with black and white film, and you just go along trying to find that match, and then you match them. So that's the same, we get the same marks. It's all very repetitive, which is one of the reasons why it's important to have a program that's doing it automatically. I think the whole idea of this project is to catch the public's imagination and get them submitting photos online. The link up between myself and Capgemini was pretty much luck. One of their employees came out here on an expedition and suggested that maybe they might try machine learning for sperm whale flukes. We have a meeting once a week, and I basically try and break it during the week, and then the guys go away and fix them.
Let's take a look at what the developers have produced over the last 7 days.
I tried to increase the usability by showing what we're doing in a video. Goes to match whales. Now the AI is computing the similarity of the new uploaded picture to all the pictures that we have in the database.
Yeah, I think that makes sense.
I can try it.
Machine learning for me is they've trained it to know what a tail is, what a tail looks like, to recognize the contour of the edge. It finds matches that, looking by eye, I would never find. All the information is in a database, so we can see where they've been, who they've been hanging out with, kind of what the social structure of the groups are, so you won't have to be a techie to use it. I told you it looked a bit like a tree trunk, and there it is, just floating at the surface. Okay, there goes the arch, so next time it's gonna dive. Everybody ready? And there it goes. There's nothing I'd rather be doing on a nice day, nice weather with nice whales. Although, when there's bad weather and no whales, I'd rather be in bed.
It's been 11 years now. March 4th, 2009. The date you go in and the date you come home, you'll never forget those days.
The day I was arrested was the day I found out I was like 4 weeks pregnant. You think your life's over, and then someone tells you you're pregnant, and it's just kind of, it's a lot. But it's the best thing that could have ever happened to me, all of it.
Coming home, it's just a crazy reality. You've been constricted to this small area for such a long time, constantly kind of being told and through the messaging of the system that you're less than, and it's really difficult to separate from that. I'm Aidan McDonald, and I'm the founder and program manager of Justice Through Code. Justice Through Code is the semester-long coding and interpersonal skills intensive for the formerly incarcerated. I think it's really telling to think about the statistics. About 4 years after release from incarceration, 75% of people will be rearrested. Single most important predictor of recidivism is unemployment, but yet people can't get jobs.
It's very difficult just completely starting over. The excitement of being free, but then the reality of not being prepared. That things that changed rapidly in just the few short years that I was away. And when you're incarcerated, everything is stripped from you. Like, you're no longer who you are. And then when you come home, you're trying to be just be a person again.
I mean, I can speak to my personal experience. I was incarcerated in federal prison for close to 4 years. When I returned home, I went to a halfway house in Connecticut. And for me, it was very difficult to get a job. A year after release from incarceration, 75% of people will be unemployed. When you look at that and think about the statistics that for the bottom 10% of earners in this country, their children are approximately 20 times more likely to end up incarcerated in their lifetimes than the top 10% of earners. Not only is it impossible to get a job, in many ways, because of the way that we treat people that have returned home from prison, these young children don't have a chance as well.
There's definitely a fear, like, all right, so now I'm coming out of prison, who's gonna hire me? I remember looking up different careers and all of these requirements, like, how am I gonna take care of this little girl that I fought for? Like, how am I gonna be able to provide her the life that she deserves? Someone told me about the Justice Through Code coding program, and I didn't have experience, but I always wanted to learn it, but it was just kind of like a big overwhelming thing. Like, where do you even start?
No, we're gonna have fun with this one though. Sharpen your skills.
Why coding? Technology and coding is this great equalizer. The industry cares more about your skills than your specific background.
Self-taught bikes is going to be equal to an empty list.
Excellent.
I really enjoy figuring out the problem, feeling of getting something right.
This time was a lot smoother. We went through that pretty quick.
It was. You guys breezed right through it.
You write a few lines of code, you test it out, and something breaks, and then you got to kind of figure out how to like solve it and then do this and do that, and you have like a picture in your head of what you want something to look like. It's just an amazing feeling of accomplishment.
It's kind of hard to describe because unless you code, it's almost like you can't really understand the feeling. What's up? It's Thursday, man. Last day of class for the week, you know? Trying to get everybody hyped, man, you know?
Well, let's say I get stuck. You know, like, what will be your next step?
Look, your computer is not going to explode if you make an error. And it's good to make an error so you can understand how to fix the error. Because since you're gonna have so many errors, why not know how to fix them?
The code doesn't know I've been to prison. The code just knows I'm a software engineer and that I am going to use it to create something. You want to play the game I made with me? Yeah. See, look, I programmed it, so you type your name here. Now, if I'm faced with a problem, I know how to break it down into small pieces. It's just kind of like rewired my whole brain and how I look at everything in life. Which square do you want?
This one.
You won!
The tech industry has a responsibility to build inclusive technology. And in order to do that, you need to have people from all walks of life.
At least where a person who's formerly incarcerated can apply without having to worry.
Can I have a hug, please? I want her to look at me one day and see all that I've accomplished, where I came from, and what I'm doing in my life and how successful I am. And that's what's behind everything I do every day. I'm definitely gonna teach her early, though.
It's really exciting to see that our students will be a part of that work to shape our future, and that they'll be able to contribute to us living in a more equitable world.
We're rewriting the code. We're rewriting the code.
Imagine a technology partner invested in your dreams, where we take the time to understand your aspirations and give you the opportunity to transform them into reality through disruptive innovation. We are Aws Digital Labs. We are a team of IT professionals, data scientists, cloud solutions specialists, creative design engineers, spanning 7 global offices. We are enriching the lives of over 500 million people. We have successfully delivered projects globally, specializing in digital telco solutions, mobile money, fintech, IoT, AI, machine learning, data analytics, and self-care solutions. Using our expertise and domain knowledge, we have helped challenge the norms of industries and rewrite the rules of engagement. We provide our customers with agility. We provide them future-ready products now. Aws Digital Labs, advancing digital life.
Okay, welcome back everyone. I hope you all got something for your breakfast. So I think Praveen is ready with his interesting and comprehensive demonstration of how to do things with SageMaker. So yeah, over to you, Praveen.
Okay, thanks. Thank you. So in this part of the session, just give me 1 second. Okay. So in this part of the session, what we are going to do now is that talk about how do we do build, train, and deploy your models, machine learning models, right? So let's get into it right away. So for the first thing for the build, what SageMaker provides you is that basically we offer you two flavors of two flavors kind of stuff. I'll kind of talk about it a little bit more detail. So the first thing is that we have something called a standalone SageMaker notebook instance, right? So this is the Jupyter notebook environment that is provided to you, right? We also have another something called SageMaker Studio, which is our end-to-end IDE that we provide. So as part of that IDE, you also have the notebook environment that you could use. So basically the difference between the two things is that the SageMaker notebook instance is just the build tool for the Jupyter environment that is available. Whereas the SageMaker Studio, what I'm going to talk about, I'll also show you a demo. It's a complete end-to-end IDE. You could use it for your training, deployment, for your ML ops, tracking your experiments. There is a lot more features available in the SageMaker Studio IDE that we have. As a part of the Studio IDE, you also have a notebook environment. But if you don't want all of the other features, you want to just have a notebook environment, we also have this notebook instance that is there. So both things I'll show you while doing this, while we're talking about it in demo. So what is so special about the SageMaker, the different notebook instances that we provide, right? Either the standalone one or in the studio. One of the key features is that if you are installed your Jupyter notebook on your laptop and you're using, one of the problems is that, let's say you want to do some exploratory data analysis, right? At that point of time, you need more CPU and memory. Then it's very difficult, right? You don't have that memory, you might get out of memory exception, or you have to do it in a smaller subset of data. Whereas if you are using the SageMaker, the notebooks that we provide, you can very quickly go to a higher instance machine. Let's say for the next 1 hour where you are working, you can quickly go into this higher instance with more CPU and memory. And then once you are done, you can come back to it actually, right? So that's one of the key features that is provided. So if you take the notebook environment in the studio that we have, it provides some more cool features as well. One of the very interesting features is that, let's say if I want to share my notebook into my fellow data scientists in my team, one of the challenges is that, yeah, I can put it in the GitHub and then give it to them. But then let's say I might have installed quite a few system libraries in that, or the outputs of that particular notebook that kind of get lost when you do it, right? Now, what I can do is that I can just click one button. There'll be a button called share. When I click that, it gives me a link. Once I send the link to my fellow data scientists, once they click on it, he gets my complete environment, right? From wherever I left, they can continue to start working on it, right? So again, that's a cool feature that is provided in the notebook environments that we provide actually, right? So to summarize, it's a Jupyter environment. If you are comfortable already using Jupyter, it's very, very easy for you to kind of start using it. Comes in two flavors, SageMaker notebook instance. And then as a part of the Studio IDE, SageMaker Studio IDE, we also have an instance, notebook instance that is available over there. We will see both of the stuff while doing the demo part of it actually, right? So now let's talk about how this is if you're a developer, this is a very, very important slide. If you want to understand one slide out of my entire presentation, it has to be this slide actually, right? So what are all the different training, so algorithms or frameworks options that is provided by SageMaker, right? So I'll break it down into 3 different ways. So SageMaker supports it in 3 different ways. The first thing is that SageMaker provides you what we call it as a built-in algorithms. There are 17 built-in algorithms that is made available to you, right? So those algorithms, or there are some statistical algorithms, basically, right? If you want to do something like a linear regression, logistic regression, if you want to do PCA for those stuff, there are algorithms available. But then if you want to do a deep learning kind of stuff like object detection or machine translation, or you wanted to do something like the PCA in the deep learning side of things, there are algorithms that is available actually, right? Apart from that, we also provide XGBoost as one of those algorithms over there actually, right? So there are 17 different AWS SageMaker algorithms that is available. There are two advantages of using this SageMaker provided the first class algorithms over there. The first thing is that you don't really need to write any code actually, right? You don't need to, let's say if you're using one of the deep learning algorithms, you don't go and define all your layers. What is your activation layer? What is your loss? You don't need to define it. We make it very, very easy for you to start using it, right? That's the first important aspect. The second, one of the other key features is that we have made sure all of these algorithms can run in a distributed manner. So when I say that, let's say when your data size starts increasing, one of the challenges you would have is that the training time, right? Because you can go to bigger and bigger machine, but still your training might take a lot of time. So that is where we actually use this capability to distribute the data, run it in different instances. And these algorithms support that basically, right? To distribute the data in different instances and running it is the capability which the kind of the SageMaker, these 17 algorithms provide, right? So that's the first box. The second way we support algorithms and models is that we support all of the most popular framework, be it TensorFlow, Keras, MXNet, PyTorch, or if you're using scikit-learn, or you're using XGBoost, we support all of these frameworks. So when I say we support these frameworks, what do I mean by that is that, let's say if you have written your TensorFlow code where you have gone ahead and defined all your layers and other things over there, you could easily bring that into SageMaker and use all the training and the deployment capabilities that we speak about, right? So if you're using one of these framework, TensorFlow, MXNet, PyTorch, Keras, or scikit-learn or XGBoost, very, very easy to bring those codes into SageMaker and use all the good features on the training and deployment that I'm going to talk about basically, right? One interesting thing, I don't know if you're noticing, XGBoost is available in the first box also, and then you will see that it's available in the second box. So the difference is that XGBoost, basically what we have done in the built-in algorithms is that we have taken the open source XGBoost and modified it to make sure that it can run in a distributed manner, right? The training can be done in a distributed manner. There's some work that is gone in, but let's say if you want to use the open source XGBoost framework, basically, right, from DMLC, absolutely possible to do it. You could use that as well, actually, right? So that is the second part of it. But let's say if you are coming from you don't want to use the 17 algorithms that SageMaker provided, but you also don't want to use one of these frameworks. You have either a legacy framework or some very cutting edge framework. Still, you will be able to use SageMaker. But the only thing is that you need to build a container, a Docker container, and provide it to us. A Docker container has to be in a certain format. There are documentation which talks about it. Once you provide that to us, then you could start using all the training and the deployment capabilities that SageMaker provides, right? To summarize, three different ways you could use algorithms and models. So the first, there are 17 different algorithms that is provided by SageMaker itself. And then we support some of the popular frameworks that is there. And the interesting thing is that XGBoost is available as a framework also, and as an algorithm also in the SageMaker thing, right? So XGBoost has this distinct distinction between it actually, right? But if you're using, as I said, if you're using some legacy or a cutting edge framework, you could still use it by just that you have to bring that as a part of it as a container and then start using it actually, right? So apart from that, we also provide you something called a marketplace, right? So what does an AWS marketplace for machine learning does is that, let's say I am a company who specializes in creating algorithms and models. What I can do is that I can put my machine learning models. Let's say I've developed some cool model, basically, right? Or a model which I think can be used by multiple people. So I can put it in this AWS marketplace, and I can say that, hey, I will be charging for every hour this model is being used, or for every API call. You could fix an amount, basically say that, hey, it's about 30 cents or $1 or whatever it is, right? You could fix an amount. And let's say somebody, Whale is the person who's like wants to use one of those algorithms. You can go to this marketplace. There you will be seeing algorithms from a lot of people, models and algorithms over there. You can pick and choose which one he wants to use and start using it, basically, right? And let's say if he is using it for the next, he is very happy about it, he continues to use it. That will get for him, AWS will bill him for that in the AWS bill. And for me, AWS, at the end of every month, they will be sending that money back into my bank account, basically, right? So this is the way where, as a developer, or if you think you have a cutting edge model, if you want to reach a wide variety of companies, organization, marketplace is a place for you to look into it. Or let's say if you are a person trying to solve a problem, you might want to look into this marketplace to see if there's something that is available for you, right? And then there is another option. Let's say there's something called Amazon Sagemaker Autopilot, right? So let's say if you have a tabular data where you're trying to solve a regression problem or a classification problem, be it binary or a multi-class classification, right? What you could do is that you could get this data, pass into Sagemaker Autopilot. This is the raw data, right? You have not done any feature engineering or anything like that, right? A raw data, that tabular data that you have, you can send it to Autopilot, Sagemaker Autopilot. So Autopilot, what this does is that it looks into your data, creates multiple features out of your data, right? Just not one, but it creates multiple different types of features. And then what it will do is that if it's a regression problem, it will take a few regression-based algorithms, and then it will run this the features that it has created, right? It will run it on top of those algorithms, basically. Or if it's a classification, then classification algorithms, and then provide. So there are, as I said, it creates just not one set of features, right? It creates multiple set of features, run it across different algorithms, and provides you a leaderboard which says that, hey, with this set of features and in this algorithm, this was the accuracy that came in, right? Or you can select the metric that you wanted to evaluate on, and then it kind of gives the leaderboard. Very, very key aspect of Autopilot is that it's completely a white box. What do I mean by that is that all the code that we generate, the feature engineering code, the training code, is made available to you as a notebook, that is as IPython notebook. So if you want to take it and then if you want to improve on top of it, it's absolutely possible to do it, right? You just make changes into the feature engineering code, and then you could also run it actually, right? So Sagemaker Autopilot, if you want to have a tabular data specifically on regression and then a classification problem you're trying to solve, Sagemaker Autopilot could be of a great help for you, or you might want to look into it as well, right? So that's what those are the three things. Specifically, getting into the 17 algorithms. As I said, it spans across multiple different areas. So if you want to do a computer vision, there is an image classification, object detection, and a segmentation that can be done. Let's say if you want to do a recommendation, factorization machines are there, classification, regression. So there are for specific types of problems, machine learning problems, you will see that there are the 17 algorithms spans across these problems to solve it over there, right? I won't go into detail of each of these algorithms because most of these algorithms, if you are into the data scientist world, you should be familiar, like the k-means, PCAs, are common algorithms that a lot of people use it, right? So that is all available provided to you actually, right? So that's what the Sagemaker kind of built-in algorithms that provides. So let's now talk about how the training part of it. That's the most interesting, right? I mean, if you talk about any data scientist, the training is the most interesting part of it, and it also takes a lot of there is a lot of art and science involved in it, right? So there's a lot of decisions you have to make which comes from your experience, But then there are the science aspects of it is also available there. So we will talk about how you could set up the experiments within the training and how you could run training in Sagemaker actually, right? To understand this conceptually, let's go through this diagram, right? Let's say you have decided you want to use one of the Sagemaker algorithms, basically, right? Let's take that you wanted to use XGBoost as an algorithm. You wanted to use it. You have already prepared the data. You have done all your feature engineering and everything. You have prepared the data. Now you want to do the training on, basically, right? So let's assume that that's the code that you have written. The actual code that you have written is in a EC2 instance. It's nothing. Think of it as a virtual machine that is there, basically, right? So now you have it. So the first thing is that you need to have your data, that all the feature engineering data that you have done, into an S3 bucket, right? S3 bucket is nothing but within the AWS environment. It's an object storage. You can drop in any kind of things over there, any type of object, it can take it. So your training data that is there, you put it in the S3 bucket actually, right? So once you have done that, what you will do, what the training inside happens is that we will talk about those APIs. Don't worry if this is not too clear. I'll try to explain it, and then during the demo also I will walk you through what's happening. Then what happens is that Sagemaker will bring up the training instance for you. Let's say if you're using the XGBoost algorithm, it will bring the training instance, copy all the necessary libraries that is required for this training instance, copy the data, right, the training data into this training instance, and then it will start doing the training for you, basically, right? So during this process, it will also copy the, let's say the XGBoost, you have said that you wanted to use XGBoost, right? That we provided as a container, we copy that container. As a data scientist, you don't need to worry about it. I'm just talking about the internal things. If you don't understand this, it's absolutely fine. We will go and talk about it in a little bit more detail actually as we go along, right? So the training starts happening in a separate environment. It doesn't happen in your notebook, basically, right? So we bring in a separate set of instances, do the training, and then once the training is done, we copy the model output back into an S3 bucket, and then we destroy this training instance, right? So the beauty of it is that, let's say if you are running the training for 2 hours, this training instance machines come up only for automatically. Sagemaker brings in, you will just be making an API call. Sagemaker will bring up this training instances, run the training for you in that. Once the training is done, the model gets copied into this S3 location. You can specify the location, it gets copied, and the training instance is completely destroyed, and you will be paying only for that amount of time the training instance was running, right? Think about it, right? Let's say tomorrow you're going to use a computer vision based, image based project where you might need a GPU kind of a machine, right? GPU machines are expensive, right? All of us know that GPU machines are expensive. You don't want to switch on a machine and then forget about it, right? Whereas in this case, once the training is done, it will automatically shut down. You don't need to wait for the training to get over, then shut down, and or you don't need to write some kind of a process that will bring it down and all of those stuff, right? Sagemaker takes care of it actually, right? So that's what the training capability which Sagemaker provides. Let's get into the details of it. We provide all of the algorithms, the 17 algorithms, and also the frameworks I spoke about, right? TensorFlow and everything. We provide it as a container. As a data scientist, probably this is the only one line you need to understand about containers. You say that, hey, give me the XGBoost container, right? This is the code that you would be writing in your, if you're writing it in Python, this is the code you would be writing, and this is all you need to know about it. Give me the container, what container you want, whether you want to use XGBoost or a TensorFlow, or you want to use something like, let's say for logistic regression, we have an algorithm, you want to use it, or a PCA, you want to use it. Just make sure the framework name, and then we will give you this algorithm, right? So that's all you need to understand about containers, right? Again, as I said, Sagemaker is a platform, end-to-end platform. We provide different APIs. For example, the training part of it, which I spoke about it, right? We provide it as an API to you, right? So the code that you are writing, the actual XGBoost code or whatever you are writing over there, Either you could do it in your laptop that you're currently working, or in your desktop that you are using, or it could be in your EC2 instance, or SageMaker also provides you a notebook instances. You could reside anywhere and call these APIs, right? We provide an AWS SDK. We provide a SageMaker specific Python SDK and a Spark library as well, through which you can make this call to this API, and then the training could happen actually, right? So you don't need to use the SageMaker notebooks to do the training, basically, right? To use SageMaker, all these trainings, all of this is provided as an API. You could call this from anywhere, right? For example, let's say if I'm extremely comfortable using the Jupyter notebook that is there in my laptop, or a PyCharm that is there in my laptop, absolutely fine. You want to outsource the training alone to SageMaker, we provide you there is an AWS SDK or a SageMaker Python SDK that we provide. Import those libraries, and then you can just outsource the training alone to SageMaker, right? That is absolutely possible to do that actually, right? So how does it look like, right? We will go through the code as we go along during the demo. Also, we will talk about the code. You create something called an estimator, right? If you're used to TensorFlow, probably a lot of you know what is an estimator. Estimator is nothing but that is where you will define, hey, what is my algorithm I want to use? Where is my what type of a machine I want to do the training, and what are the hyperparameters that I pass it for the training? I define an estimator, and this on the top of this estimator, using my data, I run this fit method. So once you do the fit, basically the model gets created. And once the model is created, then you could use this model and then basically do the deployment and then start doing the prediction, right? This is a typical end-to-end flow, and SageMaker supports all of this basically, right? We will talk about it. We will go and look into those details as we go along. So for somebody, how does it look like, right? From a code perspective, how does it look like if you want to use training? We have one of this interesting algorithm. Out of the 17 algorithms, there is one algorithm called linear learner, right? For people curious, you might think that, hey, you have heard about linear regression, heard about logistic regression. What is this linear learner basically, right? So this is an Amazon specific algorithm out of the 17 algorithms. What we have done is that instead of creating two different algorithms for regression and classification, like linear regression and a logistic regression, we created one algorithm for linear learner. Based on the hyperparameter you pass, it will be either, if you say that, hey, I want to use it as a binary or binary classification problem, it will behave like a logistic regression. If you say that I'm going to solve a regression problem, it will behave like a linear regression, right? So that is all the difference basically, right? So let's say I have a binary classification problem and I want to start using it actually, right? This is all I need to do. I create an estimator object, right? And I pass in which is the container I want to use. The linear learner is the container I want to use. You will say that, hey, how many training instances I want to run the training on, and what type of an instance basically, right? Here I'm saying that a C4X large. This is nothing but if you Google on C4X large, it will say that a C4X large has a certain CPU and a memory, right? It's 4 CPU, 16 GB, or 8 CPU, 64 GB. Based on the size of the machine you want, you can change whether you want to use a 2X large or a 4X large. You can keep adding it basically over here, right? And then you say that, hey, where do you want to copy that model output? Once the training is run, somewhere the model output needs to be copied, right? So you tell that, and then you also pass some hyperparameter that is needed. You pass in a what is the feature dimension. In this case, since this is linear learner, I have to tell it's a regression problem or a classification problem. So I say that, hey, it's a binary classifier. And I talk about I send some batch size basically. And then all I have to do from my Python code or wherever you're running, call the fit method on it and pass where is your training data, right? So you can pass in training data, validation data as well. Here just they're passing the training data. When you do this, what happens is that when you call the fit method, what happens is that we will bring up this SageMaker will bring up this C4X large machine. That is the blue box that you're seeing over here. We will copy the container, the linear learner container into this machine, right? So into this particular machine, we will copy it. We will copy the data, the training data is located in S3 location, right? We will copy the data into this machine. We will start doing the training. right? Once during the training process, all the logs and everything will be streamed into your AWS, where you will be able to, in the real time, you will be able to see the logs and everything. And then what happens is that once the training is complete, we will take the model that is created, copy that into this output location, and then we will destroy this C4 XLarge machine, right? So if this machine ran for about, let's say it's a small data set, I ran for about 20 minutes, this C4 machine will be charged only for this 20 minutes, right? You could sitting in your Jupyter notebook, which is a very, very small environment, let's say it's running in your 2-core machine or in your laptop, you could just outsource it to a bigger instance, right? If I want to, let's say if it's a object detection problem I'm solving basically, right? Instead of linear learner algorithm, I will be using an object detection algorithm, and I might want to use a GPU instance, right? All I have to do it is that say I want to use a P3. P3s are GPU instances, P3 set of instances, and then boom, you go basically, right? You don't need to worry about, hey, what do I have to install in this P3 instances? What are the libraries I have to install? SageMaker takes care of everything for you, right? Another beauty is that if you want to run a distributed training, my data size is large and I want to do a distributed training, all I have to do is that come here and change this training instance count. Instead of 1, I have to do it 2. Then what happens is that instead of 1 instance, 2 instances will be brought up by SageMaker. The data from S3 will be distributed into those 2 instances, because no fun in running the entire data in one and another data, same data in another instance, right? Because you want to distribute it. SageMaker will take care of distributing. There are different distributed strategy that is available. So it will distribute it. As and when the training is going on, you need to exchange the weights, right? Because you don't want to create 2 different models, right? So it will keep exchanging the weights. Finally, it will provide you one output, one model that will be copied into the S3 location actually, right? So if you want to do a distributed training, extremely easy, just change this one of these parameters from 1 to 2 or 3 or how many instances you want to distribute on basically, right? So that is how the training works. We will talk about it as we go. When we do the demo, we will talk about it actually, right? This is another example of, let's say if I am having a training data and a validation data, I can move this data into S3. As I said, the data needs to be in S3 basically, right? There are other places it can also be there. It can be in Elastic File System and FSX server. Let's not go into it. As you are becoming expert in SageMaker, you could dive into it. But for now, let's assume that the training data needs to be there in the input data, and the validation data needs to be there in S3. So that is what they're doing over here. They're uploading the data into S3. And this is an example, same example like how we saw for linear learner. I am looking at for XGBoost, or for that matter, this container, it could be XGBoost or any of those 17 algorithms that we use, right? So it's saying that instance count, instance type, where I want to write it, pass in for this XGBoost algorithm, pass in some hyperparameters, and then do a fit where you can pass where is your training data and where is your validation data, basically, right? Very, very simple to do the training using SageMaker actually, right? So what happens in this case, we will bring up this M4 XLarge machine. Last time you saw that we were running it in a C4 XLarge. This time we are running it in an M4 XLarge. This is a different machine with a different CPU and memory, right? So you could go to our website and see that I need 8-core 64 GB machine. Then there will be a corresponding machine type that will be there. It will be like, let's say, C4 8x large or C4 4x large. Just come and put that name over here and start using it actually, right? It's as simple as that actually. Okay. So this is, I kind of talked about, this talks about the number of EC2 instances in which the training needs to be run. This is the type of the instance, type of the machine instance that you want to run. And then what will be the wall for the training instance need to have data that is copied, right? Let's say if you're doing a large amount of data, then the file size, this is like 30 GB is what we have provided here. But if you want to increase, you could increase it as well, right? So that's what, while defining the estimator, you will be providing actually, right? So very important to understand, every model runs on a SageMaker training job, which is its own ephemeral cluster. What does it mean by that is that once the training starts, the training job runs, And once it is completed, it gets destroyed, right? That is why we call it as an ephemeral cluster, basically, right? That training instance is not available to you anymore. The model gets copied into a secure location. All the log files gets copied into a secure location, and then it destroys the training instance. So it's ephemeral in that sense, actually, right? And then you will be charged for that, the number of seconds the training job ran, actually, right? That EC2 instance would have, the training instance would have run for, let's say, 3 hours, 23 hours, 5 minutes, 28 seconds. And that is what you will be charged for, basically, right? If it's a GPU machine which ran for, let's say, 24 hours, or let's say 25 hours, 5 minutes and 30 seconds, exactly that is the amount you would be charged for, actually, right? And the cluster comes down immediately after the model finished training. This is what you need to kind of understand on that. Okay, so we spoke about the training, right? So, and just keep the questions coming in the Q&A section. We will try to answer it at the end. I know some people might have questions around this, so please ask us. So we will be able to answer it towards the end, actually, right? Or some of the questions might get clarified when I'm walking through you on the demo part of it. Okay, so we will now talk about what is the next step, right? So you have done the training, and the next step is that you look into your evaluation metrics and you want to fine tune your, you want to do a hyperparameter optimization, right? So as you know, let's say if you're using a decision tree kind of an algorithm, then these are some of the hyperparameters that you see over, right? The tree depth, the max leaf nodes, and other things you might want to change. And if you're using the neural network, you want to change the number of layers, hidden layers, learning rates, or the parameter which we typically tune, actually, right? That is where Sagemaker can kind of help you in optimizing your hyperparameters, actually, right? So there is a way to do it. We will talk about how Sagemaker can help you in tuning your hyperparameters, right? So what's the advantage? So what does the Amazon Sagemaker automatic model tuning or hyperparameter optimization does? It can do it at the scale, right? At any given point of time, I can have 12 different hyperparameters passed to it, and it can ask it to tune. I can select what kind of an evaluation metric that I want to use, basically, right? I can say that accuracy is the metric on which I want to tune my jobs on, training jobs on, right? I wanted to keep increasing the accuracy. Or I can say that a loss is the metric which I'm interested in. I wanted to make sure that the loss is getting minimized, actually, right? So you could tell on what basis, on what hyperparameters you want to tune on. Sagemaker can help you to do it, actually, right? So Sagemaker actually uses two different ways it can do it for you. One is a Bayesian optimization technique it uses to do hyperparameter optimization. And then there is a random, basically, right? So if you, let's say, if you give 10 different hyperparameters, it can randomly pick up, run multiple jobs and tell you what is it. But then Bayesian is a more scientific, if I want to call it, as more scientific way of doing it, which is supported in a Sagemaker as well. Let's see how it works, right? So typically what you will do is that like you do the training, you will also set up a hyperparameter job. In that hyperparameter job, for example, you are interested in you wanted to tune the learning rate parameter. Let's say that you wanted interested in tuning the learning rate parameter. So what you will do is that you will say that, hey, my learning rate goes from 0.001 to 0.1, right? That's the range you will tell the Sagemaker job. And then you will say that, hey, run different jobs, make sure that I have a higher accuracy, right? That is what, just we'll take one example, right? Just one hyperparameter learning rate. I give a range and then say that, hey, I wanted to improve the accuracy, run some different jobs and find out what is the accuracy. What Sagemaker will do is that it will pick up from that learning rate range you gave. It will pick up, for the first thing, it will pick up some values and it will run 3 different training jobs for you, right? This is like a normal how that the training jobs before we spoke, right? Like exactly the same way it will run 3 training jobs. And then the accuracy is the metric that you are evaluating on, right? So it gets the accuracy value out of this, and then it passes it into a Bayesian optimizer, basically, right? It passes this value into Bayesian optimizer. What this Bayesian optimizer does is that instead of accuracy, let's assume that you are doing it in an AUC, basically, right? On the area under curve, you are trying to optimize on. So based on that information, what it will do is that it will select the next 3 different values for the learning rate, right? And then runs that job basically, right? As you would have known in Bayesian, it does that explore and exploit of that particular value, right? But then let's say if you want to do it on 12 different hyperparameters, then it becomes a lot more complex. That's why this Bayesian optimization can help you pick up those values, hyperparameter values, run 3 more jobs, and then it keeps continuing like that. And you will specify how many total jobs you want to do, and it will run it, and finally will tell you that, so this is the second round that is happening, right? Like that, for every round, it will pick up a value and then start evaluating your AUC metric. And then finally, so in this case, I have run like 7 different jobs. And then finally, it will tell you that among all of those stuff, that particular learning rate value for your for the metric that you selected, this is the best value that we were able to get, and this is the hyperparameter value. So that information is what will hyperparameter tuning job will provide you. Again, I'll show you a demo of it to showcase how easy it is and what is the result. It's kind of bringing it in, right? So as I said, what I showed you till now is a Bayesian way of doing it using the Bayesian optimizer. But you can also say that the training job, hey, I don't want to do a Bayesian, I have a time constraint. So run 20 jobs, but use a random as the capability. Then it will bring up all the 20 jobs at a time, and then pick up some values, and then it will show you which particular job was able to give you more AUC, basically, right? So whatever you wanted to do with accuracy or AUC, whichever one. Whereas the difference in Bayesian optimization is that it will take some time, because it runs job based on the output, it selects the next value. Based on that output, it selects the next value. So it might take, in the x-axis is a time over here, right? It might take some time, but generally I have seen Bayesian giving a better result than, let's say, doing something like a random search actually, right? So that is where, that is what the capability of the hyperparameter optimization that we provide. So to do hyperparameter optimization, basically there are 3 things you need to bring in. You have to say which is the objective metric you're going to evaluate on. Whether you want to increase the accuracy, reduce the loss, or whatever, you can define your own metric as well, right? You have to tell on what basis you want to evaluate the training job, right? That is the first thing. And the second thing, obviously, since you are tuning the hyperparameter, you have to give the hyperparameter either as the ranges you have to give, right? In the learning rate, as I said, I can say that 0.001 to 0.1, my learning could range from it. Find the best learning rate value from that, right? Like that, you could give multiple different hyperparameters actually. And the third thing is that the job specification. You want to tell the SageMaker, hey, how many jobs you want to run. You don't want to run 1,000 jobs, right? Because you will end up having a huge bill, basically, right? You will say that, hey, run 20 jobs and find out, among those 20 jobs, find out what is the best hyperparameter value, basically, right? You have to give this 3 information to SageMaker, to hyperparameter job, then it can do this job for you, basically, right? Again, hyperparameter jobs can be run on the 17 built-in algorithms I spoke about. If you are bringing in your own TensorFlow code and other things, yes, you could do TensorFlow, PyTorch, or other things. You can do it on top of that as well. Or let's say if you're bringing in your own Docker container, basically, right? As I said, for either a legacy or a cutting edge framework, you can still use the hyperparameter optimization. It's absolutely possible to do it in all the 3 as well, right? This is how the hyperparameter, this is a simple hyperparameter you're declaring, right? You're not giving any range. In a dictionary, you are passing these are all the hyperparameters. And then let's say you are saying that you are defining other hyperparameters. These are some of the standard hyperparameters you will define. Let's say you wanted to do a hyperparameter optimization. What you will do is that here I'm saying that a ETA is the one of the parameter which I wanted to do optimization on. Min child weight, alpha, max depth. In this case, I'm giving 4 different values or hyperparameters which I want to tune it on, and I give some values as well, right? It can be a continuous parameter, or it can be an integer, or it can be, so we give that. And then I'm saying that the metric I'm interested in tuning on is a validation : AUC, right? Area under curve. And then I go and say, define a hyperparameter tuning job, which says that, okay, this is the objective metric validation AUC. This is, I'm running it on an XGBoost algorithm. Maximum jobs run for me is 20 jobs, and then at a time run only 3 jobs, basically, right? So what happens is that it will run first 3 jobs, it will select randomly value from these things, run 3 jobs, take this validation AUC. Based on the validation AUC, it will select, the Bayesian optimizer will select the next 4 values of this, and then run next 3 jobs, basically. Like that, it will keep running till it completes 20 jobs, right? So in that, it will tell you what is the good AUC value for this ranges that was obtained is what it will produce you, right? It will say that, okay, ETA was 0.135, a min child weight value was like 1.85 or whatever it is, right? So the integer max depth was 5. So that is what the output it will produce you, basically, right? I'll show you an example as we talk along. This talks about, from a code perspective, it talks about how would you write it is exactly like what I said. So when I say maximum parallel jobs, it will run 4 jobs at a time. And then based on the output of this value, the accuracy value or whatever, in this case, the objective metric in terms of AUC, they are looking into validation accuracy, right? So the validation accuracy, it will run the first 4 jobs. How the output of the jobs is looked into it, of the validation accuracy. Based on that, it will keep selecting the other jobs actually, right? Like that, it will run 20 different jobs. So that is what happens underneath actually in the SageMaker model tuning, right? Now we spoke about how to build, how to do the training part of it. Now let's talk about the deployment part of it, right? Very, very important. I mean, it's no fun if you develop the model, you are happy with the accuracy, right? You have to really deploy it somewhere for your businesses to start using it. Correct. So that's where the the business outcome starts coming in for you, right? So when it comes to deployment, right? You can deploy it multiple different ways, right? There are 4 primary ways we have seen customers deploy. One, SageMaker provides you a real-time deployment capability. So it provides you a real-time endpoint where your application can make a direct call to the SageMaker, the real-time endpoint API, and get the result, right? So this is classically used if you want to have a synchronous, let's say you are trying to identify a fraud, basically, right? And if a transaction is happening, you might want to pass in that request into a SageMaker endpoint, the model does the inference and returns the results back, right? That is what the SageMaker real-time endpoint does. But then there could be a lot of use cases where you don't need to have a real-time endpoint, right? The use cases could run every day or the night time or every week, or there could be some monthly process or quarterly process you wanted to run. So that is what the batch transformation helps you to do it, right? We will get into the details of these 2 things as we go along. So batch transformation, SageMaker supports if you want to run a model in a periodic manner. It's not a synchronous call, it's kind of an asynchronous request that you would make, and it will do it, right? Typical like a batch process. That's what called a batch transformation, basically, right? But then we have also seen people, what they do is that they can take that model that is generated out of SageMaker, and then you could take it and deploy it into your containers as well, right? It could be let's say it could be your Kubernetes cluster, or Amazon also provides you something like a Fargate and other things. So you could take the model and deploy it as well in your own cluster, Kubernetes cluster or a container environment that you have, basically, right? And the 4th thing is that this again, the model is, let's say you have created a TensorFlow object detection model, basically, right? You use the hyperparameter optimization capability and all of those stuff. You have created a great model. You can just take the model and deploy it wherever you want, right? You might want to deploy it where, let's say if you're an industrial company, you might want to deploy it in your factory premises where the action is actually closer to where the action is actually happening, right? Absolutely possible. There is nothing like a SageMaker library or anything in the training that happens. It's a pure TensorFlow model, right? Take the model, then you can deploy it wherever you want it actually, right? Either in other cloud, your data center, or in your phone, wherever you want it, take the model and then deploy it as well, right? So these are the 4 options that we have seen customers using it. What we will concentrate on, we will talk about the two different, the SageMaker real-time endpoint and the batch transformation capability is what we will talk about it now today, right? So what does a real-time endpoint does, right? As I said, real-time endpoint is used when your application wants to make an API call to your model, right? Your model needs to be exposed as an API so that your applications can make a call and then synchronously get the response back, basically, right? So think of it like this, right? So your application is sitting over here, making an inference request. Your model is hosted somewhere. We will get into that, what it is. It does the inference and the response comes back, right? This architecture is completely supported by SageMaker. So all you have to do it is that, again, you have to call an API, like how you call that estimator fit for training. There is an API that we provide. You call the deploy API and say that where is your model present, right? The model file that you created, where is it present? And then in what type of an instance that you want to deploy the model on, right? Again, like you will say it's this many core and memory type of a machine, right? And in how many instances you want to deploy the model on, basically, right? You can say that to start off with, you can say that I want to deploy the model in one instance. So instead of 3 different machines over here, it will be just deployed on one particular instance. And then we will create the load balancing for you. SageMaker creates the load balancing. It will create an endpoint that your application can start consuming it, right? Let's say if you're a person who has used scikit-learn and other things, you don't need to worry about the Flask layer and everything. SageMaker does it automatically for you. All you have to do is that make an API call and say that, hey, this is where my model is present. Let's say if you have a TensorFlow model, this is my TensorFlow model is present, and I want to run it in a machine which has 8 core, 64 GB machine. Go and create an endpoint for me, right? Make this API call. We will provide an endpoint capability for you, right? We also support auto scaling capability. What do I mean by that is that, let's say you deploy the model in only one instance. Let's assume that this is the blue box. The second blue box is the one instance that is running. Forget about the first and the third one, right? You can configure it while doing the deployment, saying that as and when the load increases, the CPU in this machine increase. Let's say if it goes above 70%, or the number of people hitting my request becomes more, right? More than 30 requests is coming per minute or 60 requests coming per minute, increase the number of instances, right? So what SageMaker does is that under the load balancer, it will increase one more instance. If the load is still increased, it will keep adding the instances so that you don't suffer any latency, basically, right? And as and when the number of requests goes down, it will shut down the other machines and it will have only one instances running. This concept is called as auto scaling, and which is very popular generally in the cloud world. We are bringing it to your model deployment as well. SageMaker brings it to a model deployment. This is just all the rules that you have write. Based on the rules, the number of instances can go up or go down, and it will have minimum number of instances always running for you, right? Your application wouldn't even know that the number of instances have gone up or gone down, because you will be still interacting with just one API. This all happens underneath the load balancer. Load balancer takes care of distributing the load across all of these machines, actually, right? That is what the real-time endpoint capability does. So we talk about how the scaling works, right? I talked about the auto scaling. As and when the load increases or the number of invocation increases, you could add the number of machines, actually, right? Very, very easy. I mean, you can configure a rule. It will automatically increase and it will automatically decrease when the load goes down, bringing in your significant cost saving for you, actually, right? Again, it talks about how in a UI you could do it as well, right? The auto scaling options, how you could set it up. And then there is another features in the real-time endpoint that I want to talk about. So what is that? Is that we call it as a multi-model endpoint, actually, right? So in the previous example, I told that I have one model which I have deployed it in a, let's say, in a machine which is a 8 core 64 GB machine, basically, right? But then let's say that model is not very actively used, right? In the sense that you still need it as a real-time endpoint, you still need it as a request response mode. But let's say in a day that model is used only for 100 times in a day, right? Do you really want to waste the resource, the 8 core 64 GB machine, For all of the 24/7, I mean, only for that 100 requests, you want that resource? Probably not, basically, right? That is where we brought in this concept called multi-model endpoints. So what it is that you could pack in multiple models into one endpoint or one machine, right? So inside this one 8-core 64 GB machine, I can put in multiple different models into it and provide only one endpoint. When my application is calling, while passing that endpoint, it also has to tell me which is the model it is going to call, right? Because now I'm having multiple models in one endpoint, right? For let's say somebody wants to access Florida model, the predict code will call an endpoint and then will pass in a parameter saying that, hey, I'm interested in the Florida, invoking the Florida model, basically, right? It's a query parameter, nothing great. If it's an API, it's just a query parameter. Once you do that, what happens is that we will load the model, because the 64 GB machine can hold in the memory only certain number of models, right? Let's say I have 50 models, and in the memory I can hold only 10 models. We keep those 50 models in an S3 bucket. As and when required, we will load the models, right? And then the request will start coming in, right? For example, let's say the Nevada model is not there in the memory, but already there are 10 other models and the memory is full. But somebody is requesting calling this Nevada model, basically. What happens at that point of time is that SageMaker uses an intelligent algorithm, will kick out one of the models that is not being used, and it will load the Nevada model into it, and then it will start serving the request for you, basically, right? So for the first request, it might be slightly a latency if it is not there in the memory, because it has to load it into the memory, which is actually fast. It doesn't take too much of time, but you will see a slight latency there, but it will start serving the request, right? But for the next request onwards, it's already there in the memory, so it will keep sending it to you faster, right? So the biggest advantage is the cost saving. If you have models which is not used extensively, it is only, but still you need to have a real-time endpoint, please do consider multi-model endpoints, where you can get a lot of cost saving for you over there, actually, right? So just to show you, if you want to deploy this 10 models in 10 different instances, probably you will end up with this much of amount, right? Let's assume that each machine costs you $343. You will end up paying $3,430 per month. Whereas if you could use the multi-model, then you could pack everything together and you will be just end up paying $343 per month, right? So again, the caveat here is that, but if you have one model which is extensively used, then it is no point in putting that as a separately, no point in using a multi-model endpoint. Probably you have to deploy it separately, actually, right? So that is where the advantages kind of start coming in, where you can deploy a model that can share and is not very used that often. Yeah, you can think about using a multi-model endpoint, right? But then let's think about a scenario, right? Endpoints are easy to spin up, right? I mean, you could, we saw how it is, but I need to do a prediction on a schedule daily 6 p.m. or every day, or every alternate day, or every weekend. I want to run a particular model, basically, right? So how do I do it? That is where the batch transformation capability kind of comes into picture, actually, right? So again, the way the batch transformation kind of works is that, I'll just bring it up. The works is that you could have an event trigger. Event trigger could be something like a cron-based trigger, which wakes up every day at 6 p.m. or right, every alternate day or every week and all of those stuff, right? Or whenever a file gets uploaded, a trigger could happen. What happens is that we call in a Lambda function. Don't worry too much about it if you don't know Lambda. It's a function as a service, a piece of code that can be called when some event happens, right? So what this Lambda function will do is that it will make a call to the SageMaker API, right? The transformation API, the batch transform API. And then there are 3 inputs that is required for it, the transformation API. The first is that where the model is present. Obviously, you need to know where the model is present. You need to tell where the data is there, in which S3, because now it's not a synchronous request, right? You are sending the data, you have collected a bunch of data on which you want to do the transformation on. So the second parameter you will pass is that where is your input data that is available in which S3 bucket. And then finally, you will also tell where that output, once the model does the inference, where the output needs to be returned. Once you pass in these 3 parameters, SageMaker will bring up this model in a specific instance. It will start reading the data from S3. It will process it. And then once the results are written back into S3, let's say this particular bucket had 100,000 records it has to process. It will process all of these 100,000 records, write the results back, and this particular SageMaker instance is deleted after that, actually, right? So it wakes up at 6 o'clock. If you've configured it, it wakes up at 6 p.m., reads the data, it brings up that instance, reads the data, does the inference, all of those 100,000 records is processing is over now. Then that particular instance dies down, and you will be charged only for the amount of time that instance ran, basically, right? Let's say you took 15 minutes to do this, do this 100,000 records. You will be charged only for that 15 minutes, actually, right? That's the capability which the SageMaker batch transform kind of provides. Again, very, very easy to use those APIs. And as I said, the cluster kind of spins down immediately after the job is finished, actually, right? So as an architect, if somebody asks you, hey, when would I use a SageMaker endpoint and when would I use a SageMaker batch transformation? So this is a kind of a tabular column I typically like to show. In SageMaker endpoint, auto scaling is enabled. The number of instances can go up and down based on the load. Whereas in the batch transformation, it is while starting the batch transformation, you will tell that how many instances you want to run. There is no concept of auto scaling. If you say you want to run the batch transformation initially in 2 machines, you have to tell that. Then it will do it for you, actually, right? Both are AWS managed. You don't need to worry about doing the patching and everything like that, right? So all of it's completely AWS managed. And then when you come into the cost of it, it's very, very important, right? SageMaker endpoint being an endpoint, it will be running 24/7 or till you bring down that particular instance, because you are expected, somebody might call you at any given point of time. So you need to be aware that the cost will be charged till you are running the machine, or till you bring down or it will be charged for you till you bring down the machine, basically, right? Whereas batch transformation, the cost is definitely will be lower because you are just bringing down the machine to just process those records. So if it's running for 5 minutes or 15 minutes, you'll be charged only for that, basically, right? So that batch transformation, the cost is lower. Obviously, latency, that's a real-time endpoint, a synchronous endpoint, so you will have the lowest latency. Whereas the batch transformation, you're saying that, hey, bring the model in that particular machine, right? So the machine will take a few minutes to start up, then we have to deploy the model, then the processing starts. So that will take about 3 to 4 minutes, right? But that is what expected of a batch transformation as well, right? So that is what, that's the deployment options you have, and which you could use it over here, right? So we'll talk about one important concept before we kind of go into the demo aspects of it, right? How do you monitor the models? As I said, one of the important things in SageMaker, or one of the important things in the machine learning world, is that you wanted to detect the model drift, right? So now you have deployed the model, you are happy, but then the model drift can start happening any point of time. How do you detect the model drift is what we are going to talk about in the model monitoring capability, actually, right? So I'll give you a high-level view on what SageMaker Model Monitor does. So as we know, when does a model drift starts happening, right? Either a data drift or a model drift, when does it start happening? I'm happy with my training. I've deployed the model, but over a period of time, my whole business starts changing. Classic example is COVID, right? How your customer behaved pre-COVID versus post-COVID is huge difference. Or during the COVID time, it's a huge difference, right? Most of the model built using the training data during the pre-COVID stage probably might not work for you, right? The models might start predicting bad results. Just not COVID, right? But there are a lot of factors where your business starts changing. So the data that is going to come in after you have put the model in production might start changing. The characteristics of the data might start changing, right? Once you know that, then that means that your data model is going to drift, basically, right? So that's the whole model drift and data drift concept, right? At that point of time, what as a data scientist you have to do is that you have to do a retraining and then deploy the model. How do you identify that there is a data drift or a model drift that is happening? That is where SageMaker model monitoring can help you. So what it does is that it first runs it takes your training data, runs it through a certain framework, understand the characteristics of your training data, right? For each of the feature, it will understand what is the standard deviation, what is the min, max, and multiple different statistics value it connects, and what are all the constraints, whether it needs what kind of a data it needs, a numeric data or a float data. All of those information, it looks into your training data, creates that information, right? That's the first part of it. Second part, what SageMaker model monitoring, if you enable it, it can also do it is that it will keep collecting your inference data that is coming in, right? So it will collect the data and store it in an S3 bucket. Then that's the second step, right? Collecting the data. And then third, what happens is that you can periodically in the model monitor, you can schedule it saying that every 2 days once, keep checking it, right? So when you say checking it, what happens is that there is a model monitoring job that comes up. It will take the training data, basically the information we collected from the first part, right? All the constraints, the statistical information. It will try to compare the data that is got from the last 2 days actually, right? And it will tell you that which are all the features that is deviating it. It will tell you that this particular feature is deviating it by 5% or 10% basically, right? So at each feature level, it can tell you what is the deviation that is happening. That information is provided to you. Now you know that when a feature is deviating, let's say you could come out and say that if its feature is deviating more than 20% consistently, probably this is the time I have to start doing my retraining of my job, right? Obviously, it's not going to work properly anymore. The model's results are not going to be proper anymore. With the new data that is collected, probably I have to go back, do the retraining and deploy the model, right? This whole capability, model monitoring, can help you to do that actually, right? So that's the model monitoring capability. Now what we will do is that we will get into, for the next half an hour or so, we will see some of the demos, some of the capabilities that SageMaker kind of provides. So let's get into that. I'll open up my browser. So people who have used the AWS might be, sorry, I thought this will happen. So just give me 1 second. This one got logged out. So let me log back in. Just give me a second. Okay, so people who are comfortable, who have used AWS already, this console might be familiar, right? This is what you log in. So once in it, you could use any of the AWS services from here. So I am interested in SageMaker. That is what we are going to talk about it now. So let me go to SageMaker. So this takes me to the SageMaker console, actually, right? So from the AWS console, we came into SageMaker console. If you remember, well, the starting of my session, when I started at 10:45, I kind of spoke about there are two types of notebooks. You can use the notebooks from two different places, basically, right? So the first thing I'll talk about a standalone notebook instance. So if we, on the left-hand side, if you see something called a notebook over here. So when I click on this, you see that there's something called a notebook instance. I already have one notebook instance that is running already. I have it created, but if you want to create it, it's extremely easy. Just go into this create notebook instance, give it a name. I'm just going to say Praveen-notebook, and then select the instance type which the notebook needs to run. Be careful. This is not your training instance. This is not your deployment instance, basically, right? Unlike in a traditional way of doing, we have a tendency to run a notebook in a bigger instance because that is where you will be doing the training, right? Whereas in SageMaker, I told you, training, you can offload the training into another instance, right? So you could have this machine, the notebook machine, where you're going to do this Jupyter coding and everything. That's a very small machine, right? So if you click over here, we provide you different types of machine. Each machine has a certain core and memory. If you Google about it, you will find that. I mean, or you can go to our documentation page. It will tell you T2 medium is a 2-core 4 GB machine, right? T2 large is a slightly a bigger machine. That T2 X large is a bigger machine that we call it as a T-shirt sizing, basically, right? Like that, you have multiple different machines on which you can start the notebook. You can also use, if you want, you can also use the GPU machines, but it can be expensive. So be careful with that. But I will strongly recommend you to start with a smaller instance, basically, right? So you select this. You need to give some permissions for it to run because your data resides in, let's say, in S3, and you're running it out of SageMaker. So you have to give something called an IAM role. So you can say that create a new role, and then you can say that allow SageMaker to talk to any bucket and just say create role. I already created, so I'm not going to do it. So once you do that, you will see that I've gotten a new role. So you select that role, whichever role that is created. This is the role probably that got created, right? Yesterday I created. So this is the role. Rest of the stuff you can leave it and then say create notebook instance. When you do that, what happens is that this notebook instance will go into prepare phase. It will take some time, like about 3-4 minutes, to come into the in-service state. Once that is there, okay, this notebook instance is available. What you could do is that there are a couple of things you could do. A couple of important tips I'll tell you over here. At any point of time, you can stop your notebook instance, right? Let's say if I'm not using, end of the day, I'm leaving and I will come back only tomorrow morning for work. You don't want to keep it running, basically, right? You don't want to be costed for that, basically, right? So you can just stop your instance. All the data, all the code that you have written is available. That doesn't get destroyed. And then once you start it, you can just start using it as if you left wherever you have left yesterday, basically, right? So that is the feature that is there. So please always stop it and then restart it whenever it is required, right? So that you can save some cost. But then when the stopped instance can be deleted as well. The difference is that once you delete it, all the underlying code and everything that you have gets deleted. So once you have completed a project, moved everything to GitHub, and then you don't need this instance anymore, do a delete. Otherwise, just do a stop and then restart it, basically, right? So that is a tip I have for you. And also, when this is in stopped state, I'm not going to stop it, but when it is in stopped state, I can go into this instance, and then this edit button will be enabled. I can click on this edit, and then I can change this machine type to whatever. If I want to have a bigger machine, I can move this to a bigger machine type as well, right? And then I come back and restart it. So all the code that you have written is absolutely there, just that it's running in a bigger machine now, basically, right? So that is the capability that Notebook provides. So let's go back to the notebook, right? So once it is hubbed, either you can open it as a Jupyter or a Jupyter Lab. Let me see. I open it as a Jupyter. Right. Initially, when you open, you wouldn't have any of this. This will be empty. For people who have used Jupyter, you will be familiar with this, right? This is an exact notebook instance that you would have seen. One very, very important tip for both the people who are starting in machine learning and also people who are expert in machine learning, we have this tab called SageMaker Examples. When you click on it, you will see that there are multiple notebooks that is available within SageMaker, actually, right? For every feature of SageMaker, we provide multiple different example notebooks. And the interesting thing about this example notebooks is that once all of these notebooks are self-contained, what do I mean by that is that there is a data that is available, either open source data or some data that we provide. And then you could run the notebook to understand how it works, right? So you can just go there and then say that, hey, I want to use it, and I can start using that particular notebook, actually, right? For example, let's say I wanted to understand, hey, how hyperparameter kind of works in, let's say how hyperparameter kind of works in TensorFlow, for example, right? I can go here, you'll see multiple examples of hyperparameter tuning that is available. You can, how to use PyTorch, how to use TensorFlow 2. You can just click on it, look into the notebook, execute it, get comfortable with it, and then start using it in your environment, actually, right? Very, very useful. I have found this to be immensely helpful. A lot of times when I do my work, I take the code from here, run it, understand it, and then kind of repurpose this code, right? Very, very lot of times I have done that, right? Having said that, you don't need to be inside SageMaker to look into all of this code. Basically, we also provide you a GitHub, basically, right? You can just search for, let's say, GitHub SageMaker, it takes you to our public repository where whatever I showed you is available over here as well. So you can just actually look into it, and then you can click on it and then start using it as well, right? The same hyperparameter tuning, you will see it for TensorFlow 2. So, okay, the code is there, and then you can start using it as well. So you can go use the GitHub, or if you want to run it and have a feel of it, use it from SageMaker as well, right? So that's the notebook instance which I spoke about, right? So let me go back. So we spoke about the standalone notebook instance, but let me talk to you about SageMaker Studio as well. So when you see the Amazon SageMaker Studio, I click on it. I already created a SageMaker Studio environment for you. There are a couple of important benefits the SageMaker Studio brings in, as I said, right? It's a complete integrated development environment, right? Unlike a notebook instance, which is a standalone notebook environment, I can have multiple developers running, multiple data scientists in the one SageMaker Studio, and everybody gets their own login actually, right? And let's say if I open up the studio, I've already done it. When I click open up the studio, it opens up something like this, right? So this is a Jupyter lab kind of environment which we have taken, and SageMaker team has modified quite a bit of it. We will talk about those features as we go along, but this is the studio environment that you have actually, right? And it provides a lot of cool features which we will talk about it as we go along, okay? But this is the studio environment that we have. If you remember, I told you something, right? It's very, very easy to change in the studio. It's very, very easy to change the size of the instance that you're running on. For example, this particular notebook, it's running in a 2-core 4 GB machine you will see over here, right? 2 vCPU 4 GB. I can click on it and I can quickly change it to a 4-core 16 GB machine. Or if I want to use a machine which is like 96 vCPU 304 GB machine, it's just a single click. I can select it and save and continue. I can start using that machine, right? And if I want to go down, I have done my data engineering work, I want to go down the machine size, again, absolutely easier to do it actually, right? So that is what very, very easy to do it. At least in the notebook instance, which I showed, right? The standalone notebook instance, you have to stop the machine, increase the instance size, and then restart it. Still the data and everything will be retained, but then you have to restart it, right? Here, you don't even need to do it. Just click on it, change the machine type, boom, you go. You can start using it right away, right? I also talked to you about the sharing capability in the studio, right? How you could share. For example, this is a notebook which I have written, and I wanted to share it with my fellow data scientists, right? This has all the output code and everything, right? All the output that is there. So all I have to do it is that in the right-hand side, you see something called share. I click on this share button, and then it asks me, hey, whether I want to include GitHub repo information, include outputs. I can select whatever I want and then say create. So what it does is that it gives me a link. I can just copy the link either through Slack or whichever communication medium you're using, send the link to your fellow data scientists. And once they click on it, right, the notebook that I have gets created in their environment with the output and everything. That's a separate environment, right? It gets created over there. And then now they can start making the changes from their end and then continue working on it. And then I can continue from wherever I left actually, right? So that is a very cool capability, sharing capability, which the SageMaker kind of brings in actually, right? That's on just the build part of it. Apart from that, studio has a lot of capability, which I'll talk about it, right? But before that, what we will do is that we will go back to the notebook environment, the standalone notebook environment, and then run one of the SageMaker's algorithms, right? To get an idea of how the APIs and other things work. So what I will do is that I open up, if you want to understand the Amazon SageMaker algorithms, all of this information is available here. I'm going to run an algorithm called Linear Learner MNIST. Okay, so if I want to use it, all I have to do is that I have to go to Linear Learner MNIST and then say use, and then create a copy. It gets copied from the GitHub, it gets copied into your local environment basically, right? I've already done that because we may not have enough time to go over this. I've already run this notebook, right? I'll kind of explain what I have done over here. So in this, all of our notebooks are well documented. In this case, what it will text, what this particular notebook is trying to do, right? So what we are in this notebook, what we are going to do is that we are going to take the MNIST data set. Most of you know MNIST is a handwritten data set, very, very popular, right? With the labels, it is available. We are going to do a binary classification to identify whether if an image is passed, whether it's 0 or not. We are not going to do multi-class or anything. If the image is passed the 0, we will identify 0 or not. For that, we are going to use the MNIST data set to train our model, basically, right? So in this case, I'm going to use a SageMaker specific algorithm called linear learner. This is one of those 17 algorithms. I spoke about it, right? Linear learner behaves like a linear regression or a logistic regression based on the parameter you pass, right? So that's what we are going to do. I'll just walk you through the code, which I have already run, basically, right? So I mean, this is a Python code. As you could see, I bring in some libraries. I set up some buckets where I have to copy the data and download the data, right? So I set up some AWS buckets information over there, nothing great about it. And then I download that, the data set is available in a bucket that we have created, right? The MNIST data set. So I download the data, right? That is all I'm doing, download the training data. Instead of downloading it from the website, I'm downloading, we have a bucket that we provided this data. I'm just downloading it from there. And then I'm visualizing the data, basically, right? So I'm saying that, okay, look into the training data, the 30th item, and then what is the label for it? So it is 3 and the label is 3, right? Just I'm confirming that how the data looks like and all of those stuff, right? Now I have the data. So this algorithms requires the data in a certain format. Okay, so you might ask me a question, hey, how do I find out each of the SageMaker algorithm, what format you need it? So let's go and find that out, right? So I type SageMaker algorithms, right? So if you go into a SageMaker documentation, you will see that there are different algorithms that is there, right? All the 17 algorithms that is there. I am interested in linear learner, so I go over here. It talks about what this algorithm does, what are all the different hyperparameters this algorithm supports, how you can do the model tuning. All of those information is available over here, but I'm interested in knowing how basically on that algorithm itself, right? So I go here, and then there is one interesting link. It says that what is the input output interface that is required. I click on it. It says that for training, either you could send the data in a record IO wrapped protobuf format, this is one of the open formats, right? Or CSV format. For inference, again, you can say send the data in these formats, right? So this is what it says. So let's go back to our notebook. Now that I've figured this out, let's go back to our notebook. What I'm going to do is that the data that I got, I'm going to convert it into a record IO format, basically, right? That is all I'm doing. I'm not doing anything great over here. I've converted into the format it is asking. I could have converted into the CSV format as well, but in this case, I'm converting it into the record IO format, actually, right? Once I have done that, I upload the training data. As I said, my training data has to be in S3. We also support 2 different things like elastic file system. We call it as an EFS and FSX luster. But this is not important for this particular module that we are doing now, right? For this workshop, we won't talk about it. But let's assume that the data has to be in S3. So we are uploading the data into S3 basically, right? So that is what I have done till now, right? I downloaded the training data, I looked into it, I converted the data into record IO format, I uploaded the data. We haven't gone into the algorithm part at all till now, okay? So, and then I defined, once the training is done, where I have to copy my output, right? That location I'm defining over here, S3 location, that I have done. Now comes the key part of it, right? I want to use the linear learner algorithm. So I need to get the container, right? This is all you need to know about the container. So you call this command and then you call this code and then you get that linear learner container. Once you have got the container, you create something called an estimator. Okay. So in this estimator, you pass what is the name of the container. So in this case, I'm saying that linear learner is the container. And role, if you remember, we created a role that SageMaker can talk to so that I'm passing it over here. And then in which instance I want, how many instances I want to run the training on. Here I'm saying that run the training in only one instance. And then what is the machine type I want to run the training on, right? C4 X large. This is a machine with a certain CPU and memory, and where I want to copy the output once the model finishing is complete, right? There's an S3 location that we defined over here. I am mentioning it over here, okay? And then I set some hyperparameters. So I say that since it's a MNIST code, I know that it's a 28 cross 28 matrix or pixels it has. So I'm putting the feature dimension as 78. And then I'm saying that this linear learner, as I said, need a hyperparameter, right? So I'm saying it is a binary classifier, and I'm giving a batch size, basically, right? And then I'm doing a linear fit on the training data, which is there in S3. Once I do a fit, what happens is that it brings up the C4 X large machine. See, the notebook itself is running in a smaller machine, right? In a 2-core machine, it's running, but I'm offloading the training using this APIs. It brings up a C4 X large machine. It copies the data. It copies the container into this machine. Okay. It copies the data into the C4 X large machine, and the training starts happening. As and when the training happening, there is another service within AWS called CloudWatch. You can go there and see the training actually, right? I've already done the training. So if you are doing the training for the first time, what happens is that you can go into the SageMaker console. Under the training, you can see your training jobs. You will see that one of your jobs will be still running, right? For example, this is the linear job. For me, it's completed, but it will say that for you, it's running. When you click open that, you can, if you keep going down, it will tell you all the information about your training jobs, what are all the metrics it's going to collect, and all of those stuff. And interesting thing is that you can also see view logs, right? When I click on this view logs, this is the CloudWatch part of the logs, and you will be able to see the logs that training machine generated, right? Those logs are available over here. I can search on it if I want to see it for the last 1 minute, 1 hour, all of those stuff, I can do it over here. Okay. So it starts, as and when the training is happening, it starts streaming the log into the CloudWatch. Once the training is completed, it will create the model file, and then the model file is copied into this output location. Okay. And this particular instance is destroyed after that. Okay. So I'll show you, this is a very small data set, right? As people might have used MNIST. Here also you can see the logs, but you cannot search or anything like that. That's why you go and do it in the CloudWatch. If you see, this machine was charged, I was charged only for 177 seconds, less than 3 minutes, because the C4 X large machine, the training got over in less than 3 minutes, basically, right? And that is what I will be charged for, actually, right? So, and that machine got destroyed after that, and I don't need to worry about it, right? So this is how you do the training. So once you do the training, you want to deploy the model, obviously, right? Again, see, for me to deploy the model, it's again a one-step process, basically, right? I say linear.deploy, and I say that I want to deploy this in one machine. In what type of a machine I want to deploy, right? I ran a training in a C4 X large machine, but I'm deploying a model in a M4 X large machine. It's a different CPU and memory, right? Because your inference requires a different set of capabilities, different memory requirement and a CPU requirement. I just call this, and then my model gets deployed. I am provided with an endpoint, right? I can go here and see my endpoint as well. So if I go to console, I say endpoints. Okay, I deleted this endpoint, but you would have seen the endpoint. And then what you could do is that on this endpoint, you can do your predictions, right? I create a confusion matrix out of my test data set and other things, basically, right? I mean, this is not very important part of it. I mean, obviously, when you are doing machine learning, you have to do it. But for this workshop, what confusion matrix and other thing, I'm not going to go there. But you can just use this API to do the deployment. Boom, your endpoint is ready. Then you can start using it, right? And then I actually deleted the endpoint after I finished running. But yeah, I mean, that's why you don't see it over there. But this is how it kind of works, right? I could do exactly the same thing in Studio as well. If you see, I've gone to Studio, exact same code. I have run it in Studio. Only difference is that the examples, the tab I showed you, right, by default doesn't come in Studio, but all you can do it is that you can go into this repository, Git repository. You can say clone a repository, and then you could get the repository ID from here, right? For example, I can say that, hey, this is where my code is there. Basically, let me go to Amazon SageMaker examples. Okay, I can grab that HTTPS request, and then I can go there and clone a new repository, right? I've already done it. So it gave me Amazon SageMaker examples. In this example, like all of what you saw in the notebook, it's available over here. I took the same linear learner MNIST, and then I ran it over here, basically, right? Exactly the same thing I ran, and you will be able to kind of use it in the SageMaker Studio as well, right? What I wanted to do next is that I wanted to show you the features of SageMaker Studio, right? So what I have done is that I took an example, right? So last time we did a linear learner. So let's say this time I'm using an XGBoost as an example over here. Okay. So in the XGBoost example, there is some libraries I install. I'll skip few things because of the lack of time. This is the data set I have. I'm trying to do a churn prediction, whether the person will churn or not, basically, right? That's the label which I wanted to predict. I'm going to use an XGBoost algorithm to do that. I do some feature engineering, which is not important for this course. So I'm doing the feature engineering, and then I upload the training data and validation data into S3, right? Like how I did it before I'm doing it. Now, SageMaker Studio provides a way where I can track my experiments and trials. Typically, as a data scientist, you will run multiple experiments, right? Multiple trials, basically. Let's say you are doing a churn prediction as a problem, that's an experiment, right? Under it, you might run multiple trials where you might change multiple hyperparameters, you might change the data and other things, right? You want to capture that information so that tomorrow you want to come back and look at, hey, if I change the learning rate, what was my evaluation metrics, basically, right? What was my validation metrics? You might want to see that, right? So for that, SageMaker provides a way where you create something called an experiment. Again, it's an API call. I'm creating an experiment called customer churn prediction as an experiment. And then what I do is that I go create a trial, right? Before creating this estimator, like how we did for linear learner, I'm creating an estimator where I pass in the XGBoost as a Docker. I give this hyperparameters like max depth and everything over here. And then training instance count output. And then I call this XGB fit, right? And then I pass is what is my training data and validation data. With it, I am also saying what is my trial name actually, right? Once you do that, we keep capturing the trials actually, right? The experiments that you run, we keep capturing all the information, like what is the hyperparameter you passed, what is the training evaluation metrics that came out, where was your data, all the information. SageMaker stores it for you, right? I'll show you how you could retrieve it and use it, right? So that is how I have run. Remember one thing I told, XGBoost is a slightly interesting I think, okay, I'll come to that later. So now I have done this trial. So the training is run. It is showing me all those information about this training. Now, just to show the power of the experiments and trials, right? I am changing the min child weight. In that, one of the hyperparameter is min child weight. I'm giving different values of min child weight, and I'm running this algorithm again, actually. Okay, I'm running the training again. So I've already done it because we might not have enough time. I've already done it. So let's go and look into it, right? I wanted to see how the trials and all of those stuff happened. So on the left-hand side, you see something called components and registries. I click on that. You can have multiple projects. The data wrangler I spoke about, feature store, all of this information, you can access it from here. Today, we may not be able to go into all of these details, but let's go into this experiments and trials, right? So I go over here. So it tell me that, okay, I already created the customer churn is the experiment that I created. I open it up, and then I ran this experiment, something called this framework mode, let me go back quickly. All the experiments that I've created is shown over here, right? I can select this and say that, hey, open it in a trial component list. Now it will tell me what is the component name, when it was created, and other things it tells me, right? Now I'll go ahead and then say that add a chart for me. Okay, so when I say add a chart, it tells me summary statistics. I'm interested in doing a scatter plot. If you see, I have actually, what was that? Let me go here. What was that? Min child weight was this thing which I was seeing, right? Sorry, where was I? Where was I? Yeah, sorry, I was here. So I'll select min child weight as in my x-axis, and in the y-axis I will select. Let's say I'll select validation error last, basically, right? And the color is the trial component name. So you can see over here, right? I mean, see, for me, this is like just 5 different trainings I have done. So it tells me that for min child weight is changed when the value is 1, what was the validation error it came in? When the value was 8, what was the validation error it came in, right? I'm not sure if you're able to see this, but I'll just, the point, the colors, you're seeing it over here, right? So it makes it, let's say if I have run hundreds of experiments in your team, you have run hundreds of experiments, in one single graph, you would be able to see it actually, right? So that is one of the key features which kind of, one of the key, how you can track your experiments and trials within SageMaker Studio Notebook is one of the key features actually, right? I also wanted to show you one more feature. This is not a feature of Studio, but generally I wanted to talk about. I told you, right, XGBoost. If you see, I've used XGBoost like how I used as a SageMaker algorithm. Okay, you could use it also as the second one I talked about, right? Like a TensorFlow, you could bring in this as a framework. That is also supported in, that is also kind of supported, right? So how you have to do it is that, let me go over here. This is a typical XGBoost code. I have written my XGBoost code elsewhere, right? I am just doing a pigmentize. It's there in the folder. Normally, how you would create your training and everything like that, right? Like that, let's say this is an XGBoost example, but you could also do it for TensorFlow, right? Let's say if you've created a TensorFlow code already, bring that Python file over here. Okay, once you have bring that Python file, now instead of using the normal estimator, you are using that XGBoost estimator directly. Like if you're using TensorFlow or a PyTorch, you could use the TensorFlow or a PyTorch estimator directly. And then instead of passing the container, you are going to say where your code is present, right? In my case, this is where my code, the code I showed you over, right? I have created the file name. So it's a variable name called entry point script. That is where I have the file name. Then I say that which version of XGBoost framework I want to use. Then the rest all remains the same. The training instance, output, and everything remains the same. The fit method remains the same. I can pass in the trial and everything remains the same. So if you want to use the bucket where I talked about TensorFlow, PyTorch, scikit-learn, instead of using the normal estimator, you will be using the specific. For scikit-learn, you will be using the sklearn estimator. For TensorFlow, you will be using the TensorFlow estimator, PyTorch estimator, and then you will pass what is the entry point to it. Right, then it will know that you're using a TensorFlow, you're using a PyTorch, and then it will start using that in that mode actually, right? So this is how you use it in this, we call it as a script mode actually, right? So this is how you use something in a script mode and use it, right? I know we are kind of running over time. I just wanted to show one thing very quickly. How do you do hyperparameter optimization, right? So let's go here. I have again from this example folder, right? I went to this example folder and kind of picked up this hyper. In this, I am actually taken this hyperparameter TensorFlow MNIST IPython notebook. So that is what I have run already over here. This is again, in this case, I'm using TensorFlow, right? So remember that I'm using TensorFlow. So here we are creating the data part of it we are creating. Let's not go into that, right? I'm downloading the data and then creating the data into a GZ file and other things like that. So you see over here in this, I'm setting the estimator as a TensorFlow estimator, and I'm given this file name train.py. Okay, if somebody is interested in what the train.py is, that this is what the train.py as. I go to my files, TensorFlow code. Under that, I have that. I have this train.py. So this is where this is a normal TensorFlow code which you will be used to, right? You're defining your you're defining your functional or a sequential keras thing you want to define. All of those stuff you define over here, your layers and everything over here. And then then you give other things like framework version, what is the Python version you want to use. And then let's go into the hyperparameter tuning. In this case, I just want to tune hyperparameter just the learning rate alone, right? I can do up to 12, but here I'm saying that a learning rate can range from 0.001 to 0.001 basically, right? That's what I'm saying over here. And then I'm telling the metric which I want to tune my hyperparameter, my jobs is based on this average test loss, right? How do you find the average test loss? Whenever my training job completes in this particular training.py, I throw out a metric called test loss. Test loss colon is what I throw out. So go and get this metric. Okay, so this is how you will be getting the metric. And I always wanted to minimize the test loss, right? If it's a loss, you wanted to minimize it. That is my objective metric. So in hyperparameter, you need to know what is the metric that you want to tune it on. That is what I have defined. I have defined the hyperparameter which I want to tune it on. And now I define a job which says that at any point of time, run only 2 jobs, but maximum run only 4 jobs. Ideally, this is very less when you're doing hyperparameter tuning. It has to be in the numbers of 30 or 40, but just for the test purpose, to showcase the purpose, I want to finish it fast. So I ran it like this, and then I do a fit. Now what happens is that what SageMaker does is that it will first run 2 training jobs. It will pick up some values in between this range. It will run the 2 jobs. Once the 2 jobs is completed, it will take the test loss value from those 2 jobs, pass it to the Bayesian optimizer that we have, and then gets 2 different new values for that particular learning rate, and then runs the next 2 jobs actually, right? And then let's say if in this case I put only 4, so after that it stops. But let's say if I put 20, then the cycle keeps going like that, right? So it will run for 10 times. 10 into 2 is 20, right? So now let's see what is the output, how I can see what is my best job. So I'll go back to my console. I'll search for my hyperparameter tuning jobs. You will see that I have ran this 4 jobs, right? So you see those jobs over here. I click on it, and it will tell me all my 4 jobs and what was the objective metric that came for that, the test loss metric that came for these jobs, right? And I can also go into the best training job, and then it will tell me, hey, what was that value? Basically, the best learning rate it got selected was this value, right? 0.00064. That is where you are able to get the least loss, basically, right? So this is what the hyperparameter, like that I could have done it for 12 different parameters at single point of time, right? In this case, just to showcase, I just have one hyperparameter which I tuned. Okay, so this is what hyperparameter. You could either do it in the notebook instance, but if you wanted to have other features you wanted to use, like let's say, I haven't spoken about this, the features like data wrangler and other things like that, right? So if you wanted to use that, let me go back to where's my, okay, sorry, just give me 1 second. Okay, I was searching for this tab. So apart from that, I also quickly ran. The SageMaker Studio provides multiple features, right? You can have things like model registry. We didn't have time to go through it, so I can have models registered and use it. And then you can do a ML ops here. I already ran an ML ops basically, right? So I can I can create pipelines, right? Using the ML ops capability. It shows me how my pipeline looks like, and then it also shows me, hey, this is my pipeline, which I created a pre-processing layer. I created a training pipeline. Part of the pipeline, these are the different steps. And if I want to see what is the output of each steps that came about, all of this stuff like the ML ops capability and other things also provided by SageMaker. Since because we didn't have time, I didn't cover on that, but I kind of encourage you to go back and look into it. If you want to do data wrangling, if you wanted to do feature store and all of those features, it is kind of available over here, right? So finally, I wanted to finish it off with this particular slide, which talks about quite a lot of features that we had. So we covered some of the important things probably that you would require in the immediate for this your hackathon and other things. But then if you are a data scientist or a machine learning developer, please go into it, look into these features. There are some amazing features like distributed training, where you can distribute your data, or you can distribute your model, which is like very, very high end, cutting edge. That features are provided. We allow you to debug your code, actually, right? Debug your training as and when the training is happening. You could enable a debugger and see that if your tensors are getting small or exploding, your gradient vanishing, all of those stuff, you will be able to do it actually, right? And also, if you want to deploy the model in edges, let's say in my phone or edge devices, and you want to monitor it, there are features available in SageMaker, right? So multiple different features. As we don't have time, I didn't cover a lot of this stuff, but I'll leave it at here, and I'll see if I can answer some questions for the next 4 minutes or so, which we have.
Yeah, Praveen. Thank you so much for that detailed explanation. Yes, we have some of, I think, well answered most of the questions.
Awesome.
So just that we have remaining 4, we can quickly go through them.
Sure.
Yeah. So yeah, we have one question. What is the best practice when using SageMaker notebooks when multiple developers are working on a single project?
Yeah. Okay. So that's a great question. So if you're using SageMaker Studio, what happens is that you can create multiple users within SageMaker Studio, and each of them gets a separate domain, basically, right? I mean, so there's one domain. Under domain, there is a file system that is created, but each of them has a separate folder allocated to them, right? So let's say me and Vail is a part of a project. So in the SageMaker Studio, Vail gets an IDE. I, as a Praveen, I get an IDE. So I can open it up, and then whatever changes I make and everything, Vail cannot look into it, right? He doesn't have visibility to it. But I can share my notebook to Vail, right? I talked about the sharing feature. Once he does that, then it's made visible to him, right? So you create multiple different users. If you're using SageMaker Studio, create multiple different users, and then you have the separate environment that is created for you, right? If you're using a standalone notebook instance, the first option which I talked about it, right? One way is that each of you can have an account, and then you can create a notebook instance within it, or create a notebook instance environment for each one of you, right? And then you can work with your AWS team and see that how, let's say if I'm Praveen user, I get access only to that notebook, right? You can configure all of those stuff using roles and other things, but we can do that configuration as well. We can go to the next question.
Yes, yeah, I think that was clear. So, and there's another question. In which stage we should use model explainability in data science process?
Yeah, great question. So model explainability, there's actually 2 different places you could explain, right? One, you could use that. The first place where you would use it is that when you are doing the training part of it, right? So when you are training and doing the validation, that is the first part where you could enable the clarify, which I spoke about. You could hook in the clarify, and then it can provide you an explainability at that point of time, because you're doing the training, you wanted to identify which are all the features that is impacting you more, right? So that is the first part you could do it. And then the next thing is that when you're predicting the values, right? So let's say you have created an application which validates whether a loan can be given or not. Your business team wants to know which are the features that influence your decision of either giving it or not. So you can hook and clarify at that place also. And then whenever an inference happens, you could say that this particular feature impacted my decision, basically, right? How much, whether it's a positive direction or a negative direction, it had an impact. That can be done. So once you are done the training, you as a data scientist wants to understand which are all the key features that is impacting your model, and then inference, you want to give these details to business value. So these are both the places where you could provide that capability, actually.
Okay. So the last question.
Okay.
To access a trained model for web app, we have to work with Sagemaker Studio or Sagemaker Notebook.
See, the model deployment is an API that is provided, right? In fact, you don't need to be in Sagemaker Studio or Notebook instances. I can be in a PyCharm environment in my, let's say, in my laptop, and this is an API that is provided, right? So we have a Sagemaker SDK or a AWS SDK. So through that, I can make a call to that Sagemaker API and deploy it. Okay. I can also do that in the Studio instance or in the normal Notebook instance, basically because it's an end of the day, it's a Python API, right? So you don't need to be in one of this environment, but if you are there, all you're doing is that calling that API and doing the deployment part of it. So it's just a Python API. It doesn't have, you don't need to tie that with either a notebook or the Studio instance or a normal Notebook instance.
Okay. So I think that's all that we have for the Q&A.
Awesome.
Yes. If anybody
Awesome.
has.
Yeah. So thanks for your time. As I said, this is an overview that we gave, a lot of features. So please look into it and reach out to us if you have any questions. Yeah. Back to us. Yeah. Back to you.
Yeah, on behalf of ADL, I would like to thank both of you, Praveen and Well. You did a very good explanation and a very comprehensive presentation session for our participants. I think that will be definitely important for the people or the teams that could be participating in our hackathon. So thank you so much for your time in Saturday. So I would like to thank both of you on behalf of ADL. Thank you so much. So for the participants, our next speaker, we have from our Dell Technologies. So let me introduce him.
All right, thank you so much, Ashni, and the whole.
Thank you, everyone. Thank you.
Right.
Thank you.
Thanks, sir.
Yeah.
Thanks,
Thank you.
Praveen.
Yeah.
All right. So we have completed our morning session, and so here we are with our afternoon session. So we have Roman Butcher for the from the Dell Technologies. Roman is one of the Dell Technologies HPC and AI subject matter expert in Asia Pacific. And Roman has been there in the industry for more than a decade and worked closely with the data science teams to ensure the software and infrastructure solutions. Hi, Roman.
Hello, good afternoon, everyone.
Good afternoon. Yes, we can see you. Yes. So Roman will give the presentation or conduct the session for the next hour. So over to you, Roman.
Thank you very much, Ashani, and good afternoon, everyone. So again, thanks, Axiata, to give us the opportunity to talk today for you guys. So hopefully, I know it's lunchtime for you. So hopefully my session will be probably a bit easier to digest, less technical, and I wanted to touch base on a topic that will touch you as data scientist or data scientist to be, which is AI in enterprise. Okay, so of course, thanks Praveen and Vel for the sharing of Sagemaker. It's an amazing product. So Ashani already presented myself, so I will not go through it again, but for those who have never heard of me, so I'm French, I'm based in Asia. I've been at Dell Technologies for the last 4 years, and my core activity is to work with scientists and data scientists, whether it's in the high performance computing field of activity or artificial intelligence field of activity, and sometimes combined to help them solve problems. Right. Even though I do focus more on infrastructure and platform, I'm not a data scientist myself, beside a hobby, but I do work closely with them. So I do understand the challenges that you guys face when it comes to AI. Very quick word about Dell technology. I'm not sure everyone is familiar with Dell technologies. For sure, you know what Dell is. So Dell is our customer-centric branch, laptop, desktop. But Dell Technology is actually a company that has been created back in 2016 after the merger of Dell and EMC. EMC was the leading storage company globally. So we created this Dell Technology umbrella that has multiple sub-companies in it. So I come from the company called Dell EMC, which is the data center-centric business. But we have other solutions such as VMware that you are most likely familiar with, Secure Work for security, Pivotal, or Virtustream, which is actually a cloud platform, same as AWS will be, but for customers who have like critical needs for infrastructure. Okay, now we're going to move toward artificial intelligence. So again, my session will not be deep technicals, but I will raise some points and probably questions that will come to you when you have to build and deploy AI models or AI solutions in enterprise. First of all, as you know, AI is not new. That's a topic that has been discussed already for the last 50, 60 years, with machine learning already being conceptualized back in 1953, right? When Arthur Samuel created the first machine learning algorithms to play checkers, right? So you will say, like, when did computer vision, deep learning started? Deep learning did not start far after that. And actually, the first deep learning algorithm, the perceptron, was already created back in 1958. So today we're in 2021. We are using more and more AI. What happened in between, right? And actually, in between, there were multiple waves of interest when it comes to artificial intelligence, right? Some period where businesses were interested into it, invested into it, did more research into it, and ultimately it did not really lead to anything very useful for business. And ultimately, if business does not drive it, globally, it's not going to be adopted. So there were a few waves. So some AI summer, AI winters, and we are currently in the third wave of AI. And actually, within this third wave, there's actually a few things that makes artificial intelligence relevant and useful. The first one is the next-gen algorithms. So there were a lot of work that has been done through algorithms to make it more performant and more accurate. Also, there is, of course, the rise of big data for the last decade, where whether it's company or research have been gathering more and more data that make it relevant to solve specific problems with artificial intelligence. But also coming from the high performance computing world, the ability to have access to high level of compute, especially accelerators, now with GPUs and upcoming devices that accelerate AI, makes it easier and faster to train AI. And last, and I guess what you are seeing today during those two workshops with AWS and Snowflakes, is the make it easy AI. So the ability to simplify access to AI for everybody. So today, you data scientists have access to it, but ultimately in the future, it will become more and more simple to leverage artificial intelligence. So today, in this third wave of artificial intelligence, which is what will be ongoing for this decade, AI will help us actually drive decision, right? Or explain decision in business, okay? The next coming wave, which might change a bit, but what we do expect for the next wave of artificial intelligence is actually having the ability to have a more human-like learning from algorithms, and also ability to learn from less data, more context, less data, and ultimately able to learn interactively, right? So the model will keep learning over time by itself. And this is ultimately what it comes down to. So I like to have a picture of my boss in my presentation. So I will quote him. Companies will succeed or fail based on their ability to translate data into insight and business actions. And this is where artificial intelligence become really useful now. We have been talking about digital transformation. So businesses, enterprise, are leveraging their data, and data will drive the business, right? Ideas are not enough, gut feeling is not enough. we need to learn from data, we need to leverage data, and BI, data analytics, has been there for the last few years, understanding what's happening from data. Now we need data to drive us further. And when we come to AI or data science in businesses, actually there is a full chain of events. All come from a business problem, right? I know that you guys are more into technicals, getting some data, find the right model, which is great. But ultimately, when we talk about artificial intelligence, it has to solve a business problem. If there's no business problem to solve, there is no need to use an AI algorithm behind it. So the ability for you as data scientists to translate a business problem into a data science problem, find a solution for it. So which data, which model, find the right models, the right tuning, and then put that back into the business perspective so it can drive solution for the business with measurable KPIs, right, is essential. We can't just leverage AI as a tool and no real outcome behind it. Okay, so I would like to share with you quickly from Dell perspective, what do we do with AI? Because it's easy to talk about AI nowadays, but it's interesting to see how a company like Dell Technologies leverage AI. And we have this AI strategy, which is basically 3 pillars: AI on Dell, in Dell, and for Dell. And I will go very quickly through it because I'm not here to sell you Dell. But ultimately, so we do leverage AI, and we have a large team of data scientists in-house that work on those things for specific products. So we focus a lot on infrastructure products, and we bring artificial intelligence, especially machine learning, into our products, mainly into workstations and laptops for monitoring, predictive maintenance, but also for our storage environment to be able to optimize the way storage is used, I/O, tiering, right? So all that is leveraged with artificial intelligence today. So this is our strategy when it comes to in Dell, ability to put AI in products. The second one is AI on Dell. So again, Dell Technologies focusing a lot on infrastructure. We want to bring artificial intelligence on top of this infrastructure to solve business problems. So we do create regularly some AI-ready solutions. So basically, ready solutions which are not like cloud, such as AWS or Snowflake, but things that could be deployed on premises with an infrastructure, software stacks. It can be bare metal, can be virtualized, can be with Kubernetes, does not matter. We have different solutions. And also that bring you like modern analytic or smart edge if you're looking at edge AI. And last, AI for Dell. So we do leverage inside of processes a lot artificial intelligence, especially for internal and customer services support to make sure that we deliver the right level of service, but also when it comes to supply chain, marketing, or even finance. Okay, and that's all I want to say about Dell, how we do leverage AI. But I guess it's important for you to understand how enterprise use AI in their businesses. So now when it comes to AI, again, there's still some barrier to adopt it in enterprise, in businesses. And this is a survey from O'Reilly, which was done last year, but there is still a lot of relevance in those points. Surprisingly, the lack of skills or skilled people is not the main problem when it comes to artificial intelligence, right? There is more and more data scientists available. You guys are knowledgeable, you learn quick, so skill set is there. But when it comes to the company culture, it's not there yet, right? Having the right mindset within a company to drive business with artificial intelligence, with data analytics is not there yet all the time, right? The ability to leverage what we call data literacy. So educate everyone in business, not just the data scientist, not just the C-level people, but everyone in the company to learn to leverage data, gather data, leverage it to solve your problems, right? The tools, you will learn about the tools. You will become somehow a data scientist as well at some point. But this is a shift that's happening and it's taking time. Another point is also the difficulty to identify business case, right? There's a lot of good ideas, like, hey, we could do that, we could use AI. That's a good idea, but maybe it's not feasible yet. Or maybe there is ethical issues behind it, and I will talk a bit about it, right? Of course, there's also a lot of other problems, from technical infrastructure challenges, efficiency of tuning hyperparameters, even though we just saw with Sagemaker, it's getting easier and easier because platforms have the ability to test it on your behalf and tell you which one perform best. But again, it's assuming you have the right infrastructure to run multiple models in parallel, because if you do it sequentially, it's going to take a very long time, right? And of course, there's always legal concern, risk, and compliance issue, right? I heard a bit about explainability in AI. I will talk a bit about it also, right? And something that at Dell, we do see a lot when we talk with our customers and data scientists, the main problem that we can see them facing is they are struggling to align with IT, right? Ultimately, to do data science, you need at some point IT involvement. And when you look at the challenges that data scientists face, like needs to experiment quickly, right? That's why most of the time you will use a desktop or a laptop to build your model on a notebook, right? The ability to scale your apps in production. You develop a model, how does it scale, right? How does it go beyond a laptop? Can it scale across a cluster, across multiple environments, edge? That's thing that needs to be looked at. From the IT side, most likely IT people are not well versed yet into the needs of infrastructure and software stacks for AI, right? And that's where we try to bridge the gap. So how do we do it? So we leverage what we call the hierarchy of needs. And if you guys have been through any philosophical training back in the days, I did not. This is something we borrow from actually philosophical training. This is Abraham Maslow hierarchy of human needs. Basically, like there's 5 different things that needs to be assessed and looked at to get your true potential free. So we leverage the same concept with the hierarchy of AI needs, which come with just 5 things: use case, data, model, software ecosystem, and IT environment. Okay. And this is something that I would like you to look at, because as data scientists, you will be actually involved, or you should be able to be involved in all of those. Okay. And as I said, it all starts with a use case. I've been in workshop with customers, whether it's in banks, in healthcare, or even in climatology, and we talk about how can we leverage AI, how can we make use of AI in those fields. Like, let's try to find the low-hanging fruit. Sure, but first of all, what will be the strategic impact for you to bring AI in this? Because there is a cost, time, resources. So what's the impact if we manage to bring AI and improve either it's a product, a service, or reduce the cost? Is there a real impact? Is it feasible with the current technology? Maybe not yet. And how can you measure success? Because like every project where people put money in it, you need to see a return. How do you measure the return, right? And this is things that you as data scientists, and that's probably when we say like there is lack of skills, that's where the real problem usually lies. The lack of skills, it's the combination of data science skills and the domain expertise that you want to work on, right? Just data science itself is good, but if you don't understand the business under it, it's going to be hard to solve the problem as it is. Okay. The second point is around data. And coming from a company that sells a lot of storage, I'm not going to talk about storage devices here. But you as data scientists, you do understand data, especially data sets, are critical to train your model, right? Ultimately, when people talk about AI, there is a big chunk of the whole AI lifecycle which is actually consumed by working on data, right? From collecting the data set, whether it's local data, streaming data, IoT data, log files, right? The fact that you have to clean it and organize those data, catalog it, right? You might have to enhance it over time, prune it a bit, right? This process around the data takes around 80 to 85% of the whole AI lifecycle of an AI project, which is insane. So having access to the right tools, right, to get access to data, but also being able to catalog it and being able to be reused later on, either for yourself or other teams you are working with. And I heard earlier about sharing Jupyter notebooks and stuff like that, which is a good start. But ultimately in businesses, you want to make sure that you can share more than just a notebook, right? For a specific project, we have data. For this project, it might be relevant. Let's share this data set as well, right? And when we talk about data, it brings a few other questions. And I want to bring it to you because this is questions that we get more and more in those workshops with our customers. The problem of ethics and bias in the data, right? And actually, there's a bunch of stories around that, and I will share a couple of them with you. And if you look more and more, especially from the hyperscalers, whether it's Amazon or Google or Microsoft or even IBM, you will hear public stories of projects that now they don't want to do or they will drop, not because it's not technically doable, but because ethically, it's probably not good to do it now. We are not ready for it, right? Or maybe because the data sets that we have, which is probably biased, will give us an outcome that is probably going to be an ethical issue later on. And businesses, companies don't want to be liable for this type of thing. So AI could potentially work. AI might make sense, but because of legal concern, bad publicity concern, probably not. And I'm just going to share a couple of stories with you. That's things that you can keep in mind. I'm not going to go through all those different pictures because all of them tie to a specific story. I will just share a couple of them, right? And probably the first one is from IBM Watson. And I don't know if you heard about this one. IBM Watson was trying to have a very good goal in mind. They wanted to cure cancer. And don't get me wrong, I'm all in on this. And so they created this IBM Watson solution for oncology. So basically, the idea is you will give scans to the AI algorithm, and it will tell you where to look at and probably give a recommendation for medication to use. And ultimately, this was started back in 2013. And after 5-6 years of development, this ended up by having the algorithm to give wrong medication suggestion to patients, like patients which are going under chemotherapy. If they will get the medication suggested by the AI algorithm, it could be lethal. So ultimately, after spending $62 million in this project, IBM dropped it, right? So having the right algorithm, the right model might make sense, but liability is always a concern, right? Ethically, you don't want to give the wrong answer and get a life. Another one will be from Microsoft. So Microsoft, again, had a very good goal in mind. They wanted to develop a chatbot that will improve its conversational understanding from young people by learning from Twitter. Not a bad idea, and they named this chatbot Tay. Ultimately, within 24 hours of learning from Twitter, because of course Twitter users knew that they were a bot learning online, trolls jumped in and fed the bots with racist, misogynistic, and anti-Semitic tweets. So basically, after 24 hours, the bots were already praising Hitler's against the Jew, against women, and Microsoft they just dropped the project, say no need, right? And last story that I want to share with you comes from one of the hyperscalers that is focusing a lot on artificial intelligence, but I will not name this one. They had this idea to leverage artificial intelligence to help the human resources to screen resume for engineering, right? And so they built this AI algorithm that will get like a batch of resume, and that will select just the top 5 based on the training that they had. And basically, this company will try to hire the 5 top resume that was suggested. The fact is, the team that trained the algorithm used engineering resources resume that they had already hired in-house. And somehow it happened that most of the people working in this engineering team were white males. And when they start to use this AI algorithm, it showed that actually the AI learned that white male were better fit for engineering jobs, which is technically not true. But because this is the data that they had in hand, this is what the algorithm learned from, and that's what the algorithm suggested. So this was back in 2018, and the company dropped this AI algorithm because ultimately you don't want to have a misogynistic algorithm as part of your human resources solution. Okay, so that's good stories that you can use for dinner. Next, the models. So you guys have been looking at this platform earlier, Sagemaker, right? But you're also familiar with TensorFlow and PyTorch, MXNet, you name it. There is multiple frameworks, there's multiple algorithms behind it that can be used, whether we're talking about like traditional machine learning with classification, regression, or decision tree, or SVMs, or deep learning. And there's so many neural networks, like from CNN to LSTM and deep convolution network, or even GAN. GANs are my favorite, by the way. Ultimately, there is many models that you could use, and many models could actually solve the same type of problem, right? But you, as a data scientist, will have always to figure out which best model solve my problem. Which tool should I use, right? To build, to train, and to prove this model. And trust me, working with data scientists a lot, everybody has different needs, right? Oh, I want to use TensorFlow. Oh, but me, I need PyTorch, and I need RStudio. Can I have Flask? Everybody has different requirements all the time. But there was an interesting point that was touched on earlier, which was around explainability. And that's a very good question, actually, that was asked. Something that we come across a lot, especially in financial service industry or insurance, right? Or potentially healthcare. We can't use artificial intelligence as a black box, right? We need to be able to explain how a model works, why a model reached to a certain decision. And the example that Praveen used was pretty spot on with the financial service industry when it comes like to lending. If you want to borrow money at the bank, why did it get rejected? And it's not just because you want to satisfy the curiosity of the person that got rejected, but because there is regulation and regulatory bodies that will go after you if you can't explain it. So I will say today, whatever field you're working on, explainability is always good to have. Unfortunately, not every type of models or algorithms are easy to explain, right? Like going from classifications and regression algorithms, which are probably the easiest one to determine which feature make it easier to reach an outcome. When you go into complexity, especially in neural networks, it gets hard or even impossible right now to explain why it's working, right? You gain better accuracy moving from machine learning to deep learning, most likely. But because of the complexity of feature and feature mixing that happen within those models, it's getting almost impossible right now to give an explanation. So at Dell Technology, we work with some partners, especially the one that focus on auto machine learning. So basically, you just put your data in, you just select which feature you want to focus on for prediction. We'll be able to build a model with an explanation beside it, like tools like Data Robot, H2O, driverless AI will give you the ability to build the model, select out of many models which one works best, and what were the features selected that were actually driving the outcome. And for specific inference or use of the AI for specific customer, for example, you could generate a report for a regulatory body to show how come the AI algorithm decided of this specific outcome. And then we move to a software ecosystem. So there's something that is very important because you guys today are focusing on two specific platforms, which is AWS and Snowflake, right? Ultimately, when we develop models, even if you are developing it on your laptop right now, the question is, where is it going to live in production, right? It's not going to stay in your laptop forever. Else, it's probably a waste of time or it's a research project. So is it going to end up in a monolithic application? Is it going to be on a cloud native application, like with an API? Is it going to just be a serverless function somewhere, right? And this is questions that needs to be answered before even you start working on it, because you need to anticipate the whole life cycle of development. The development of AI projects are not limited to building a model and work on AI. You will have most likely to interact with development teams that actually will have to interact with your model, right? And so this is something that we do at Dell Technology a lot with our sister partner VMware. So VMware, you are most likely familiar with the virtualization portion of it. So vSphere, which allows us to create virtual machines that run on infrastructure that we offer. But VMware goes way beyond that. They do also offer container serverless capability. So ultimately, you can have a single platform that will allow you to run virtual machines, container, serverless function. So you can have your legacy traditional applications. You can have your new AI models running within a new application. It can be a Flask, can be a Dask. It can be a RStudio and Shiny. Or it can be just a serverless function, just a basic API that will leverage maybe some accelerators just to answer some inputs given output, right? But today we do know also that our customers in enterprise don't limit themselves to just what they have on premises on their computers, right, on their servers. Today you are talking with two prominent cloud providers, and this is the reality of the market. Enterprise today is not all on premises, and they are not all on the cloud neither, right? There is different needs and different purpose. So in some cases, cloud make more sense, especially when you want to use specific tool such as SageMaker, or you want to have an easy way to get started on a small project. Maybe you have some lack of funding, you don't have the infrastructure in-house. The cloud will probably make it easier for you, right? But ultimately, when it comes to enterprise, you want to have the ability to actually create those AI models, those AI functions, or those AI applications, and make it live wherever it needs, whether it's on premises, somewhere in a public cloud, or maybe somewhere at the edge, maybe closer to where the data will come from, right? And this is what we do with VMware today. We have this virtualization containerized platform called Tanzu that allow you to leverage Kubernetes type of environment with GPU capability to run virtual machine containers, whether it's on-prem, on the cloud, at the edge, on demand, right? And because you guys are most likely focusing on deep learning today, from what I have seen with SageMaker and TensorFlow that you were focusing on, you know that today, when we go into deep learning, if you want to be able to accelerate the time it takes to train, you will need acceleration. So today, the most popular way of accelerating deep learning algorithms is GPUs, and NVIDIA is kind of leading this market right now. And Dell Technology has been working very closely with VMware and NVIDIA to also provide what we call NVIDIA AI Enterprise. So this is a solution that leverages, again, VMware and Dell Technology. So we have this overall solution called VxRail, which is basically a combo of infrastructure and VMware. And on top of that, we bring the capability and the stack of NVIDIA to accelerate applications, whether it's for virtualization and visualization, for data analytics, or for AI. So all the frameworks, whether it's TensorFlow, PyTorch, MXNet, that have been optimized for AI, and also the ability to scale. So to go beyond one single machine, one single GPU, how do you scale your algorithms? And it all comes with like single dashboards to make it easy to use for the IT administrator. Keep in mind, from Dell Technology perspective, our goal is to bridge the gap between the data scientist and the IT administrator. We want to make sure that data scientists have access to resources quick and easy, but when it comes to deploying model at scale, IT administrator have the ability to put that, deploy that, and scale it. So when it comes to the software stack or software suites that comes with it, so NVIDIA AI Enterprise is only certified on what we call VMware vSphere and the Dell PowerEdge platform, so hyper-converged solution, right? The software stack that comes with it will be NVIDIA CUDA-X, which is basically the AI frameworks with CUDA acceleration, Magnum IO, which is for GPU acceleration towards storage, NVIDIA vGPU, so you can create virtual GPUs. So if you have multiple data scientists that work on separate projects, you can share GPUs into small portions, and each of them can have access to a portion of GPU to accelerate a bit the activity. But also you have like Rapids, which is a machine learning. I see like you were playing with XGBoost earlier. So those version of machine learning algorithms that have been optimized for CUDA and GPU acceleration, TensorFlow, PyTorch, sorry for that. But also the NVIDIA Transfer Learning Toolkit, so the ability to just download a model or pre-existing model from NVIDIA or whoever it is, and leverage on that model and just bring you additional data just for your specific problem. But also when it comes to inferencing, Triton Inference Server or NVIDIA TensorRT, which are actually pre-made solution or softwares that will just load a model in, optimize this model for inferencing, maybe by reducing from FP32 or TF32 to maybe int8, int4, and maybe pruning a bit the model to make it smaller, more efficient, because at the end of the day, when you run your model, you might want it to run fast, low latency and fast, right? So all those softwares will come preloaded within the whole platform. So for enterprise, you don't have to think anymore about how do I build this, right? It comes pre-made. So I know that it's not as a cloud provider would provide its own solution on the cloud. This solution will allow you to choose what you want to use and where you want to run it. And the last is the IT environment. So we talk about GPU a little bit, but ultimately, private, public, or edge cloud matter. You need to know where it's going to run. Is there any latency requirements? Is there any throughput requirements, right? The hardware that you will require will be different if you are trying to do facial recognition out of a camera streams, maybe in a branch of a bank, or if you are doing a prediction on the market in the data center once a day, right? The requirements are different from the model, but also from the infrastructure behind it. And something I want to show you through a very quick video is the impact of the infrastructure when you do training, right? So this is something like for image classification. You want to classify images from that's probably a standard data set. With a simple CPU, it will go at 4 images per second. With a GPU, you will be able to work on like 900 to 1,000 images per second. If you scale to 8 GPU in parallel, you might be able to process up to 7,000 images per second to do your inferencing, right? So this is what I want to point at. When we talk about what is my requirement to solve my business problem, you need to look at the infrastructure to make sure you can deliver the right outcome, right? And this comes down to different type of accelerator today that are available. We've been talking about CPUs, which are the base. And to be honest, for a lot of use cases, CPUs are far enough, right? Especially if you are using like something like OpenVINO from Intel that will allow you to optimize a model to run on an Intel CPU in a way better way than if you just run it out of a framework. FPGAs and GPUs, which are widely used. GPUs mainly because it's easier to use. FPGAs because it gives you latency consistency, right? You basically build a chip virtually that will solve a specific problem, so it's less flexible, but it brings better latency. And more recently, we have more and more TPU and IPU that comes to the market. So you might be familiar with the TPU from Google that you can rent when you train your AI models that allow you to accelerate the training phase, but it's only available in the cloud at Google. What happens if you want something on premises? So Dell Technology have some partnership. One of them is GraphCore, which is basically developing, after designing their own IPU, which is a graph chip. So that's basically an accelerator that is designed for deep learning only, right? So those type of accelerators perform very, very well when it comes to very large and complex models, such as BERT, right, or PageRank, those large-scale models that will require scalability and low latency, right? So this is a type of technology we are looking more and more towards the future. So I will just keep it simple, just to recap this session. There is 5 needs that we do believe needs to be looked at if you want to be successful in an AI project. Something that needs to be developed in companies, in businesses, and you will play a big part of it, is to change the culture toward data literacy. You need to make sure that everyone in the business is able to understand the purpose of data and what can data bring to them, especially when it comes to insight, right? There's no more gut feeling. Like, I think that, no, there's nothing that you have to think. Data is there, models are there, we can get something out of those data. Right? Ethics and bias actually overweight data science solution, right? We can find a right model, the right data, but if ultimately there's an ethical problem, this will never go to production, or it will be very short-lived, right? And please, please, when you build models that you know that needs to go into production, look at the bias, especially if it's a model that has to somehow, the outcome has to interact with humans, whether it's in healthcare or it's in financial services. Make sure that you remove as much bias as possible. And it's very hard. It is very hard. There is plenty of companies that drop AI projects because right now it's very hard to do. AI explainability mainly required when you have regulation or regulatory bodies that will oversight the outcome. So financial services, healthcare, maybe telco will look at it. In some other case, you want to do an AI black box with computer vision for farming, explainability does not really matter there, right? There's plenty of nice cases that you can build a nice black box and that will be fine. And last but not least, leverage the right tools and infrastructure to solve your problems. Infrastructure for training and inferencing, multi-cloud is the solution. It's not 100% cloud, it's not 100% on premises, it's a mix of both. And think AI factory, hello everyone. Right? AI factory, where basically you want to use multiple tools from multiple vendors on different platforms to solve your problem. You are not limited to a single one. Okay, so I'm reaching the end of my session, so we have a bit of time for any questions that you might have. Thank you very much.
Yes, thanks, Roman. So from the audience, we are open for any Q&A that you have with related to the presentation which Roman did. So, but let me bring 2 questions that we found on the live streamings. So I can raise them to Roman here. So if you are capable of answering them, so you may answer. So yes. So there are a couple of questions. Those are general questions. According to your knowledge, which is the best platform to learn AI?
So it's hard to tell because there's so many platforms right now. So as I said, I'm not a data scientist and I will not claim to be one, even though I did some learning myself, because I guess if you want to talk about it, you need to know about it. So I did follow training like from Andrew Ng, which I guess is one of the best trainings so far. because it goes technical enough and it covers a lot of different topics. There is plenty of AI training class available online for free, especially on Udemy, Coursera, that are pretty good actually. I've seen some nice one from IBM, some nice one from Google. So of course they focus on specific platform, like Google will focus only on TensorFlow and Keras, but ultimately it brings a lot of knowledge that can be translated later on to other platforms as well. So online, plenty of good knowledge for data science as is, but my recommendation would be to not just limit yourself to the data science, but also you need to have a certain domain expertise or domain knowledge to apply data science to a specific problem.
Exactly. So do you have any suggestions for any IDEs that you came across which seems good to practice AI?
Say that again?
Do you came across any good IDEs?
IDEs?
Yes, integrated development environments that which was suitable for AI.
So there is a few, right? You have seen today Jupyter Notebook, and that's mainly the one I pitch also to my customers. So similarly to what you have seen, we do have a solution that basically allow data scientists to just ask on demand some resources in a Jupyter Notebook with CPU, GPU, or whatever. Whether you use Python, you use R, that's probably the best way to do AI today, or the easiest one to do it. You can always do it in a traditional text editor if you want to. I have seen some customers doing it that way in just text editor instead of notebooks, but I do believe the notebooks are probably the best way. Now, having said that, there is also those tools that I mentioned earlier to do auto machine learning. So platforms such as DataRobot or H2O that you can, H2O, you can probably test it for free. Those platforms actually are not necessarily developer focused. So you don't really need to be a developer to do AI with those platforms. You just need to find the data you want and the problem you're trying to solve. And the platform is going to build models for you. It will show you the code if you want to, so you can modify the code, interact with it. They have their own notebooks in it. And then you can just push that into a container to production. So there is, again, many solutions to do, many ideas that will allow you to do it. Google has its own with Colab. I suggest Jupyter Notebook because that's what most people are using today, and it works pretty well.
Thank you so much, Omar. So yeah, it seems your session was pretty clear to everybody.
Yeah.
So we have no Q&As.
No problem.
Yeah, so I just take a moment. Okay, so there's one question. Maybe it came to chat. Okay, when considering Python, it is quite slow. I think this is again a technical question. Is there any language for in future for fast execution of tiny ML and AI?
That's a good question actually, and so I wish I have my data scientist colleague here to talk about tiny ML. Usually, tiny ML is a topic that we touch on because with the arrival of 5G globally, we are going to see more and more AI used at the edge. And edge devices might not be as powerful as a laptop, a desktop, or even better, a server in a data center, right? So the ability to work on tiny ML, so do the pruning of your models, as I said earlier, with like OpenVINO from Intel, the ability to transform your model into something that would fit into like just a CPU with almost the same level of accuracy. So those tools are already available, right? If you develop a model in C, you will get amazing performance compared to what you get with Python. Python is convenient, or R are convenient because of the set of libraries that come with it that makes the development easy for everyone. not everyone will be familiar with C or C++ to get into AI. But yeah, there is tools to convert already. So you have ability to convert your model, whether you do it with SageMaker or whatever, TensorFlow, PyTorch. You have those ONNX option now to do open neural network models that can be loaded with TensorRT, Triton, OpenVINO that will optimize the model for you and that will run it optimized for the hardware that you are using. One other thing that I like with OpenVINO from Intel, which is part now of the One API software suite of Intel, it will optimize for whatever Intel hardware you have. And as you might know, Intel is not limited to just CPU. They also do FPGAs. They have some neural chip. So you can buy from Intel for like what, $99 those USB sticks, which are actually an FPGA for neural networks, right? And you can run your model on that. So yeah, the tools already exist for that.
Okay. Thanks for the answer. Yes. So that's all for Q&A we have. So thank you, Roman. I just take a moment to thank you for the time that you have dedicated for this workshop session. Thank you once again, and hope to work with you even in future events also. Thanks, Roman. Thanks, Roman.
My pleasure, and good luck this afternoon for the second workshop. Thank you very much, everyone. Have a good day.
Yeah, you too. So for the participants, we have 10 minutes more for the next session by Snowflake. So we'll have a short break, 10 minutes break. So you can grab something for your lunch and sit in front of the laptop to listen to another interesting session done by another cloud computing company, Snowflake. So see you in 10 minutes.
The true potential of limitless insights has been out of your reach. The constraints of 40 years of on-premises solutions have persisted in the cloud, making the data your business depends on disconnected, siloed, and too hard to unite. Imagine the possibilities if the barriers to acquiring, uniting, and securely sharing data disappeared. No such access has existed until now. Introducing the Snowflake Data Cloud. We have built a global data network where your business can reach previously unforeseen potential. In the Data Cloud, Snowflake handles any data workload with virtually unlimited scale and performance. It enables instant, governed, secure, and compliant data access. It delivers a single experience no matter where data lives, no matter where you are. Across your business, across your ecosystem of suppliers, partners, customers, and with the thousands of organizations that operate in the Data Cloud, Snowflake unlocks the true potential of data, so you can uncover a new horizon of vast insights. Mobilize data like never before. Join the Data Cloud. Snowflake.
Thanks for taking a look at Snowflake for your data engineering workloads. Data pipelines are the lifeblood of the modern enterprise. Efficient data pipelines can be the difference between an architecture that delivers real value to the business or one that becomes a burden. Data engineers need to be able to collect, transform, and deliver data to different lines of business while keeping up with the latest technology innovations to stay ahead of the business demands. However, traditional legacy architectures create challenges along every step of the way. First of all, data of every shape and size is being generated at different speeds. With a legacy architecture, data often lands in different databases, data lakes, and even data marts, as well as in the cloud and on-premises. Secondly, with resource scarcity comes performance degradation. Data pipeline performance suffers due to the prioritization of analytical workloads. This creates a bottleneck for both data integration and consumption downstream. With complex pipelines and architecture, data engineers spend most of their time configuring and managing infrastructure instead of focusing on delivering data. Data engineering often entails multiple systems, languages, and tools, making data pipelines extremely time-consuming to design and maintain. As a result, IT teams are stuck under a staggering amount of technical debt and can't respond fast enough to business requests. Analysts and business decision-makers are limited to incomplete and inaccurate data. With Snowflake's unique cloud data platform, every organization can now collect more data than ever before, simplifying data pipelines and modernizing data integration workloads. Snowflake offers a single platform for ingesting all structured and semi-structured data and provides secure and governed access, delivering the performance and scalability modern enterprises need to support thousands of concurrent users without resource contention. In addition to streamlining data engineering, Snowflake consolidates advanced analytics, data lake, and data sharing workloads into a low-maintenance, easy-to-use service available across all 3 major clouds. With Snowflake and our partners, all of your data can easily be ingested through streaming or batch and securely centralized, making both structured and semi-structured data available natively to your users. Pipelines can run on optimized dedicated resources without manual configuration and automatically scale up or scale down as needed, driving better pipeline performance and lower cost. Moreover, Snowflake allows you to build pipelines in the language of your choice, streamlining pipeline development, reducing complexity by not having to manage additional clusters, and provides built-in capabilities to ingest data and manage pipelines. Every day, thousands of Snowflake customers transform their organizations by turning data into valuable insights and business actions. Rakuten Rewards operates the largest online loyalty service in the United States. Previously, they had a legacy architecture that required all data to be stitched and blended together, causing resource contention between their data pipelines and analytical workloads. With Snowflake, Rakuten Rewards is now able to deliver dedicated resources for their data pipelines, in many cases achieving a 95% faster runtime, providing a single source of truth for internal users to access the data they need, and also building a secure data sharing network with more than 3,000 of their partners. Rakuten is excited to see how rapidly Snowflake is being adopted internally and the transformational effect it is having on its extended ecosystem. To see how Snowflake's cloud data platform can transform your organization's use of data, sign up for a free trial today. Your data is locked in dozens, possibly hundreds of silos across your organization. From your executives to your frontline employees, decisions are made more on gut than fact. To gain a truly competitive edge, you need to share data across your organization with suppliers, other business partners, and customers. But your costly, risky, and cumbersome methods only deliver stale, incomplete data. This has all changed. The Snowflake Data Cloud has arrived. Join this global network to discover, access, and securely share data throughout your business and with thousands of other organizations. So how does the Data Cloud work? The engine that drives the Data Cloud is Snowflake's platform. Snowflake customers use our platform to unify, integrate, analyze, and share data. They do this for many of their critical data workloads and at nearly any scale or speed they desire. Once you mobilize your data on Snowflake, that data becomes part of the Data Cloud. You retain complete control, but can seamlessly and securely share governed slices of your data with anyone in the Data Cloud. But how do you and others connect in order to share data? Through Snowflake's innovative secure data sharing technology. Unlike traditional data sharing methods, with Snowflake you can share live, ready-to-query data across cloud and region without any ETL. In addition to sharing data, you can also share business logic and services, ensuring your ecosystem has the data and tools they need. And with fine-grained governance and access controls, it's safe, secure, and can meet industry and region-specific data regulatory requirements. With the Data Cloud, you can create one-to-one, one-to-many, and many-to-many data sharing relationships. First and foremost, you can break down barriers of siloed data within your own organization and share data across departments, subsidiaries, geographies, and with your business partners. You can also find new data sets listed on the Snowflake Data Marketplace, The data marketplace is where SaaS providers, commercial data providers, data service providers, and Snowflake customers can list and deliver data sets and data services. Data products and services from over 100 providers can be discovered in the data marketplace. Why should you join the Data Cloud? To easily access your data and a vast array of third-party data, and to obtain the deepest insights about your customers, your organization, and what lies ahead. The Data Cloud. Mobilize your data. Mobilize the world's data.
Welcome back, everyone. We are here with the evening session. So I think we have our speakers also logged in. So for the evening session, we have invited another cloud computing-based data warehousing company, Snowflake, to share their knowledge with us. So I would like to introduce both speakers for the evening session at the same time. So we have our Head of Sales Engineering, South Asia at Snowflake, Tatvi Khan, who has more than 2 decades of experience in the industry. Hi, Tatvi.
Hello, everyone.
So our second speaker would be a senior sales engineer in Snowflake, who also has a decade of experience in the industry. So he's Jay Hon Kim. So I will hand over the audience to both of you to conduct a very interesting session on Snowflake. Over to you.
All right, thank you very much. Hello, everyone, and a very good afternoon. So my name is Tatui. I'll be your host for this session. And currently I'm speaking live from Singapore. So really welcome to the ADL AI Summit 2021. Snowflake is really very honored and privileged to be invited into this event as a sponsor. So the summit can be broken down into 3 main events: the AI workshop, the AI hackathon, as well as the AI forum. And today's content is specifically curated for the AI, machine learning, and data science enthusiasts. So the workshop will empower you to attain an understanding in terms of how to use cloud to build AI-related products and services. So for the next 2.5 hours, my co-presenter Jay Hong and myself will be going through with you in terms of what is Snowflake and how you can leverage and benefit from the platform for subsequent summit activities. So Snowflake is the data cloud, as you have heard from the video itself, and we help companies to manage their data in a scalable and secure manner. So we are a software as a service, and we have patented technologies that enable customers to benefit from the next generation of modern design and architecture that leverages on the elasticity of compute and storage of what is being provided by modern cloud providers such as AWS. So we do hope that you enjoy the content and the event as much as we've enjoyed in terms of organizing for this. So let's do a bit of warm up, because presenting for 2.5 hours and for you to sit through this session continuously isn't something that we do on a daily basis. So I do hope that you're all comfortable on your chairs as we bring to you off through this magical journey on Snowflake. So with that, let's just get started to introduce the presenters for today. But before I begin, I think it's also very important for you to take a look at some of the safe harbor and disclaimers itself. So obviously, we wouldn't be going through a deep dive in terms of what all these sentences meant, but I think it's very important as it touches on the Section 27A and other sections of the Securities Act. So typically, if you have any questions, please feel free to speak to your legal team about it. With that in mind, again, I'm part of the sales engineering team over here at South Asia. So I joined Snowflake about 1 year plus ago. And before that, I was really working a lot in terms of the machine data and NoSQL space, dealing with time series data, dealing with signals, dealing with recommendations, as well as search engines itself. We also have Jay Hong, who I'm really very honored to invite as part of the co-presenters for today. He is also based out of Singapore, and he's really very much involved in working with the Singapore public sector as well as the Singapore enterprise customers. He has extensive experience in terms of machine data, as well as the data science area, additionally in terms of the security arena as well. And he has definitely worked on with a lot of numerous customers in this space. So this is the agenda for this afternoon. We are done with the introductions as well as the openings, and I'm going to move straight to the Snowflake Cloud Data Platform. I think, again, it's very important just to iterate a bit about what the Cloud Data Platform really meant. And for you all to, understand this before we go into the technical bits and pieces itself. Once that is done, I'll just pass the session over to Tiehong, who will be covering on the data science on Snowflake, and then we'll do a Q&A and a wrap up. But before I begin, I think if y'all can just go to the chat window to cut and paste this link itself, I think the very first question will be, have y'all heard about Snowflake before? I'll just give y'all a minute to basically access this URL. So it's a bit.ly link that once you do, you'll go into a Google poll, and then we can essentially see if, so Jiehong has already pasted this link onto the window itself. So let me just give y'all maybe 30 seconds more for you to click on the link and then just do a quick submission of the poll. Okay, I'm getting some responses. So there's about maybe 80%. Oh, okay, so that's about half. So about 50-50 of you. Some of you have heard about Snowflake, some of you have not. So that's quite interesting. Oh, it's exactly 50-50 right now. So that's interesting. So I'll just give you another 10 seconds. Okay, so I'm seeing maybe about 60-40, somewhat. That means 60% of y'all have not heard about Snowflake. 40% of y'all have heard about Snowflake. So I'm not sure how much y'all know about Snowflake itself, but I think this is precisely what we are trying to do to bring you up to speed in terms of what we do. So let me just get my slides back up. All right, so with that, I think earlier on, there was this video that really tries to explain about the data cloud itself. So I think the idea that data is the new oil really went from a revelation to something of a cliche in a few short years itself, but it's still a very useful metaphor in terms of the major shift in businesses and the economy. And so we all know that oil is energy and everything runs on energy, and businesses are increasingly running entirely on data. So it's really fair to say that just as oil drove the economic progress in the 20th century, data is driving the progress today in the 21st century itself. And the combination of so much data with all these new tools for analyzing it gives rise to what we call the data economy. And the data economy is essentially this ecosystem where the businesses, the governments, the social enterprises, and the individuals succeed or fail based in large part of their ability to extract value from data. So it's also this network where organizations and people share data and collaborate in ways that provide outcomes for all. So a digital enterprise is essentially an organization that aggressively digitizes all this data, put data at the center of its strategies, operations, and culture. And this is what we call the fundamental building block of the data economy. And this data cloud that we're talking today provides this energy for the data economy. So a bit about Snowflake. And obviously, this rise of the data cloud did not happen overnight. So if you have heard about the story of Snowflake, we were operating in stealth mode between 2012 to 2014. And in 2014, we announced the world about this cloud native data warehouse architecture that was really built from scratch and leverages on the elasticity and scalability of the AWS cloud service provider back then. So our co-founders started from scratch, and they didn't just port a SQL warehouse into the cloud. And it's not, Snowflake is not based off on Hadoop, which was very popular back then about 10 years ago. So in 2019, we announced what we call the Cloud Data Platform, which is what we term it as a 6 workload that is really very much focusing on bringing value to enterprises through the usage of the Snowflake platform to perform some of these tasks, such as data engineering as a data lake in data science workloads, along with powering the data applications that many of our customers are running on. So all this enable the data economy sharing and then offer the ability to share data across multiple Snowflake accounts using data sharing, as well as the cloud native data warehouse. So if we fast forward today, we are really firmly positioned as a data cloud, similar to how you have the CSPs today, such as AWS, Azure, and GCP on the infrastructure cloud. And then we have Workday and Salesforce, for example, as application clouds itself. Snowflake today is positioned as a data cloud. And this is what Snowflake firmly believes in the positioning itself as it's entrenched itself as the cloud platform for the future data economy. So we are really in this middle of the great migration of technology and information and commerce into the cloud itself. So first of all, you have the websites and search engines and e-commerce stores, and then there came the cloud computing infrastructure services, software as a services applications, and then the smartphone apps. So this data cloud is really the latest phase of that great migration. So much of the existing data in the world is moving to the cloud, and at the same time, there's this explosion of new sources and new types of data. And in the cloud, the data is secure, is accessible, is combinable, is shareable, is analyzable. So we're able to understand how businesses work and how humans operate and what they want and how they want it with so much more precision and certainty than ever before. And we can nowadays get all these insights in seconds. So if I'm to represent the data cloud today and how it looks like, in this diagram, we are able to, in fact, visualize how the data, in terms of how the different forms of Snowflake accounts and customers are sharing data across each other. So cloud computing really changes this game, making data sharing much easier. And that's mainly because a public cloud with all this multi-tenant architecture provides easy access to secure sizes of data for an unlimited number of data consumers simultaneously. And it really makes it easy for anybody with a Snowflake account today, and even those who are not Snowflake customers, for example, to gain access to all this data that's stored in another account in the data warehouse, but only if they are granted permissions by the owner of this data. So you all would see all this during the hackathon itself as we set up the environment for you all to go in. You'll be able to see how you're able to get data from other places, what we call the marketplace. You are able to interact with some of this data into your own hackathon account, for example, where you'll be able to run your machine learning in your workloads directly through Snowflake itself. So that's one thing. So with this setup itself, for example, if you want to stop sharing with a partner, it's very easy to revoke their access. The key thing is that you get very timely updates of the data itself. Another consideration is that sometimes you want to be able to find out who are accessing your data. So in this case, Snowflake has the ability to run on report tracking, for example, to see who have access to your data, what they did, when they did it, and exactly what sort of objects they were being accessed. So using all this information itself, a lot of the sellers of the data are in fact monetizing, and they could in fact modify their offerings and pricing based on the shifts in the demand itself. So I'm just going to deep dive into the Snowflake architecture so that y'all would be able to draw comparisons, especially when you're working on the hackathon. So this is from a very high level how the Snowflake platform looks like. You can see that we are, you have your data sources on the left, you have your data consumers on the right. And earlier on, I was speaking about the 6 workloads ranging from the data engineering, data lake, all the way to data sharing. Now, at the very core of it, there are 3 unique layers that deliver all these critical requirements. So these are what we call the elastic performance engine, the intelligent infrastructure, as well as a cross-cloud Snowgrid itself. So I'm going to jump into some of these details so that you all will be able to understand it and appreciate it. So the elastic performance engine gives you what we call speed, right? So there's really this single engine itself that's able to support every of the workloads that you may bring into the picture itself. So there's no need to bring in multiple, different computes or different types of processing engines or different ways of analyzing, even trying to stitch all this data together. So with Snowflake, you get all this blazing performance for very large, complex pipelines in terms of if you want to do feature engineering, in terms of if you want to, do interactive applications, analytical dashboards, and as well as much more. So this engine is built for speed. You get all this leading performance and concurrency out of the box itself without ever needing to worry about resource contention or tuning. So subsequently, I have a few more slides that will deep dive further. We will give you a logical representation in terms of how Snowflake works. So, and this performance engine is really designed for anyone. So if you are familiar with SQL, for example, you can use SQL directly and interact with Snowflake. If you're not familiar with SQL, you can also be using things like Java or Scala, and soon to come, we will be supporting a Python language where you can write in your own language that you're comfortable with, and then you can take advantage of this performance engine. So I'll touch on a bit more about the performance engine in the subsequent slide, but this is at least from a very high level how Snowflake works. And then we have the intelligent infrastructure. So Snowflake itself is really designed to ensure that everything just works. So we are fully managed. We have all the automations, and that really allows us, as we speak to customers, that really allow their teams to focus on what actually matters to the business itself. And these automations support the team throughout the platform. So for example, you need to encrypt data. you need to eliminate, patching and all the upgrades and so forth. You need to partition your data. You need to scale the resources, vacuuming. So all these are all done automatically behind the scenes by Snowflake, and the platform is really designed to stay up and running no matter what happens, right? So there's always this always on availability zones that we leverage on in terms of some of the more complex scenarios where you need to replicate data across into different regions. So we're not just talking about replicating data, but we're talking about replicating objects, users, roles, policies, and so forth. All these are being managed through Snowflake. So you could be replicating across cross regions, or you could even be replicating across cross clouds. So all this essentially translate to more efficiency, more reliability, ensure costs are, optimized. And really fundamentally behind is that Snowflake's usage adopts a usage-based or pricing model, and you only need to pay for what you use. So there's also some of the nifty features such as built-in storage compression, for example, that allows you to store data in a much cheaper manner. And constantly from a company, from a technology, from a product roadmap perspective, we are always continuously innovating in order to improve the performance, to deliver the new optimizations, as well as to further enhance the efficiencies itself. And all these are transparently delivered to the customers with no action required. So that's about the intelligent infrastructure. And then the lastly is really the Snowgrid itself. So this is really the third layer that connects the businesses in a very different ways, right? So it has this unique technology that spans globally, that connects the different regions and clouds together. So for the hackathon, we have created a AWS Singapore region for you all to gain an experience in it. So we'll touch on that a bit later. But obviously, with this Snowgrid infrastructure, you could essentially replicate your data to anywhere that you want. And then all these things happens automatically behind the scenes through Snowgrid itself. So there's no more the need to work with ETLs, or you could have silos that could potentially hold your business back. What Snowflake does then is to enable data to be instantly accessible, and these can be distributed and discovered between the teams, the business units, the partners, customers, and so forth, right? And this whole thing is backed by a very robust cross-cloud governance controls and policies. And that follow the data, not just the cloud itself. So the policies are constantly enforced. It really simplifies the governance at scale. It really minimizes the risk and unlock more value from even sensitive or regulated data. So a lot of our customers are obviously benefiting in terms of the business continuity at very, very high level, cross-region, cross-cloud, through this global connectivity, so that the business can operate without the disruption, and then they can deliver the leading experience that, for their customers itself. So how do you represent all this? I think I do have some diagrams just to let you all know. So because we are just going deeper into the conversation itself already. So just now, again, the 6 workloads, data engineering, data lake, all the way to data exchange. Obviously, for this AI Summit itself, we're going to focus a lot more in terms of the data side. So these are the various AWS services for the different Snowflake workloads. So take, for example, you want to be able to use Snowflake to augment your S3 data lake. So you can see that what is happening is that, you could have your data landing into the S3 itself. And then from here, there's various ways in terms of how you can interact it with Snowflake. So Snowflake can, use the files. Maybe you could have Parquet files being landed on the S3 data lake, and you do not want to ingest it into Snowflake, for example. So you can, in fact, use what we call external tables, which is a way for us to read the files, the Parquet files on the S3 data lake, and then we can provide further analytics on it. You could be using, say, for example, Amazon QuickSight, which is, a BI solution, and you can connect it into Snowflake itself, or you could obviously be running on some of your machine learning analytics. You could be running on Jupyter Notebooks, you could be running on Sagemaker. So later on, we'll be teaching you in terms of how you can connect into Snowflake. So that's one thing. The other thing is, obviously, if you deep dive into it, you also remember the 6 workloads, and then you deep dive into it. This is a very typical example of how Snowflake enables data science with AWS in a variety of ways, right? So the first one is that, okay, I could have data sources from Sagemaker itself. I could be combining it with the external tables on the S3 itself. I could have my own data warehouse tables, and I could have external data that I'm getting through the data sharing, the data exchange, or through the marketplace. So later on, I'll be doing a quick demo for you so that you understand how to get all this data. So all this, additional capability and ability, and Snowflake has this, a few of the functions that allows you to take in structured, semi-structured, as well as what we call unstructured data. So unstructured data typically refers to things like videos and images, and it could be things like PDFs. So if you are able to create a metadata out from all these things, you can subsequently use it for your modeling, for example. We also have some of the other features, such as what we call zero copy clones. Essentially, it allows you to do a quick clones of your data. So it's very useful during the data science type of scenarios where the data science team is able to get very good quality training sets without necessarily interfering with the production data. So that's some of the features that Snowflake has. But with that, let me just go into the Snowflake architecture so that you will understand how the whole thing will work and how this would relate to you as you embark onto the hackathon. So this is a Snowflake architecture. So we are built on the CSP. So when I talk about CSPs, it's the Google Cloud, the AWS, as well as the Azure. And we provide what we call a cloud agnostic layer. So the way how you interact with Snowflake is through what we call the cloud services. So you'll be logging into via the cloud services. So we'll be giving you essentially a URL for you all to access Snowflake into, and when you are accessing that, you are interacting with Snowflake through the cloud services layer itself. And so from a look and feel, from a UI, from a functionality capabilities perspective, we provide what we call the cloud agnostic layer, meaning that you don't really need to know where Snowflake is being hosted, what sort of CSPs is being hosted on, because we will manage this as a software as service. So we leverage on a few things. We leverage on the centralized storage provided, by the cloud providers. So if you're on AWS, for example, we are leveraging on the S3 internally. And then we have what we call the multi-cluster compute. The multi-cluster compute is really the brain behind Snowflake itself. So this is the intelligent infrastructure that I was talking about earlier on that allows Snowflake to really rapidly scale up and down and so forth. So I'll touch on subsequently in this slide itself. So hopefully you all will be able to relate this and start to leverage on this very incredible and powerful compute. So this is at the simplest form. This is the blob storage that's been provided by the CSPs. So obviously you see a key sign there. Essentially what this means is that all data, whenever they come to the Snowflake, is all encrypted. And then you can keep extending your data, right? So there's no limitations whatsoever. You don't need to add new loads and so forth if your data, just happens to grow. And you have what we call the global services. So on this bottom left. So this is really the brain behind Snowflake itself. It manages all the metadata repository, all the logical models, all the security and so forth. And then earlier on, we were talking about what we say the virtual compute. So these wheels that you see over here are essentially what we call the virtual compute. So I think Snowflake really makes it very easy for anyone when they start to use Snowflake to really understand, in terms of the sizing itself, what it meant. So we go by what we call t-shirt sizing. And I think from an industry, this is really a first. So we start off from an extra small type of what we call a cluster. And then it goes all the way up to, from extra small to a medium to a large, just as how you buy a t-shirt. So we go all the way up to very large sizes, a 6XL. Just to give you a bit of perspective, an extra small Snowflake cluster is in fact a single server behind the scene. So as you move from an extra small to a small, what it's doing is that it's doubling the server size behind the scene. So yeah, in fact, jumping off from a 1 cluster to a 2 cluster server to a 4 cluster to an 8 cluster, all the way up to a 512 clusters, right? So you think about it, 512 servers behind the scenes that you can just spin up to perform specific tasks for a workload itself. And these 512 servers behind the scenes is, we could be running on AWS and, it's all the EC2s and things like that. But because we manage it as a service, we are in fact providing thousands of CPUs, terabytes of RAM and a lot of SSD in order to run a particular workload. And then you can start to structure your environment in such a way that, hey, I could be spinning up an extra small virtual warehouse, for example, to do some form of ETL. So I could be bringing in data from structured, semi-structured. I could be working with Informatica, with Attunity and with Talent and so forth with some of these providers out there. And we could be bringing data into Snowflake. And then you could also be bringing in data from, say, for example, I have some real-time or almost real-time type of streaming through Kafka. I could have a data lake. I want to bring it into Snowflake. So Snowflake also provides what we call serverless service. So obviously some of these you wouldn't see it during the hackathon, but we will also be doing something similar so that data can be brought into the hackathon environment, in a very seamless manner. And obviously, you're leveraging on some of these technologies. And then you could also have, different types of warehouses in this case. So I have an extra small warehouse for the ETL, ELT. I have a warehouse for this sales team right now. So it's a medium warehouse. So they could be using things like Tableau, they could be using things like QuickSight or, whatever that they choose to use. And we could actually spec it up to a medium warehouse because maybe there are a lot more users, for example, who's going to use this and the load is higher, and that's why we spec it out to a medium warehouse. And then you could have your data science. Now, this is really the one that we're familiar with. I guess for most of you also, you could be using things like Python, you could be using, tools like Sagemaker and so forth, data equal data robot, and you can connect into Snowflake. So maybe, for example, you're not doing anything complicated, you're just building a very light model itself. You don't need a lot of horsepower. You don't need a lot of servers behind the scenes, a lot of CPU cores and memory and so forth. You could spin up with a small warehouse first to work on your tasks, and then whenever you do not need it, right, you can just spin them down. So this is really what we call the instant elasticity. You will have to see it for yourself during the hackathon. You will understand how easy it is. So over at Snowflake, this is what we call scaling across for the workload isolation. So each of these warehouses are operating independently of each other. So you wouldn't have situations where, in certain cases, there are noisy neighbors where, because you only have one single gigantic cluster itself, if you have someone who's running something really heavy, that could really cause, an impact or performance degradation onto the other users, for example. So each of these, the warehouse Snowflake manages it, is what we call scaling across. And then if you do not need a warehouse at all, you can essentially just suspend them. So we have this ability called auto suspend that will automatically suspend the warehouses when they're not in use and automatically resume them when they are needed. So this auto suspension and resumption happens very quickly. Typically, it happens in milliseconds, if not just seconds. So most of the users wouldn't even know that their warehouse has been suspended or the warehouse has just been resumed from a sleep state. It just works. So why you need to do all this suspension and resumption is because it helps the company to save costs. The warehouse Snowflake charges is based off on this thing called per second billing. Whenever the warehouse is alive for how many seconds, for example, you get charged by that, and whenever it is sleeping, in this case of suspended state, you wouldn't need to pay for anything at all. So this is one plus point in terms of how you would learn how to size up, and as well as how to use Snowflake itself. The other part is really the scaling up. So in this case, you can see that essentially earlier on I was giving the example that the data science team, they don't have a very heavy intensive type of data model that they're trying to train. And then in this case, if someone says that, hey, I need faster speed, I need more horsepower, what they can do is they can immediately upgrade the small cluster to what we call extra large cluster by itself. So all these things can be done automatically behind the scenes, and it provides you the data science team with that much needed power. So in the hackathon, we are just going to start off with an extra small warehouse, just to let you all know. And then obviously from a horsepower perspective, we can definitely tweak some of these things behind the scenes, and we can control them so that we can keep the spend to a considerable and manageable amount. But very often people would think that, hey, if I'm going to run a large warehouse, for example, it's definitely going to be very expensive. So I may say, oh, okay, I may think that, I may want to run all my warehouses in the smallest, what we call the extra small. So this is a very interesting chart because it's telling you that we did some simulation in terms of the loading of a 1 billion of records by itself. So you can see that originally I have an extra small cluster over here, and I'm loading 1 billion worth of records. So essentially when you're loading it, a warehouse is alive just to essentially load the data into Snowflake. And it's taking about close to 30 minutes to load the data itself. So based on the pricing and so forth, it's roughly about 88 cents. Now, if I use a small warehouse, what happened essentially is that earlier on I was telling you that the warehouse sizes doubles as you go from one t-shirt size to the next. So from a 1 cluster to a 2 cluster to a 4 to a 8. So you can see that as I jump from an extra small to a small, I currently, I'm adding another server or, so from a 1 server to a 2 cluster scenario itself. So I double the horsepower, I'm able to complete the task in half the time. But because I'm also paying twice as much, in the end, you can realize that the net of it is that I could process the job at a faster rate, but yet I'm also paying the same rate as one would use when they are on an extra small. So you can see that there's always a sweet spot depending on the type of workloads that you're executing. And in this case, for the loading of 1 billion worth of records, the large cluster would make sense because I could run and process 1 billion worth of records in 1 minute and 39 seconds. And what this is taking, the cost spent by itself is also similar to the rest of it. So you know that in the future, when you're training for your data science model, for example, you will know exactly how to right size your virtual warehouses. So this is very important for you all to understand. The other part is that, I didn't really touch on is what we call the scaling out for high concurrency. So earlier on, I was giving the example that, hey, I could have my sales team logging in. I could have a warehouse for the BI. So, they could be using Tableau and so forth, right? So again, what happens is that imagine you have a lot more users. So this is talking about dealing with high concurrencies. So maybe you have 10 users who's logging in simultaneously. They are loading, running their reports, and each of these reports, each of these dashboards and panels have subsequent SQL statements that needs to be run. So, we are talking about hundreds of SQL statements that needs to be run and so forth. And this number just keeps increasing. So how do you scale out the hardware automatically behind the scenes? So remember, because all these requests gets hit onto the global services that you can see on the bottom left. So the global services will be able to know that, hey, I'm getting a lot of requests coming in. There seems to be more and more users. So Snowflake, behind the scene, what we can do is that we can add additional hardware. We can add additional servers to buffer and to handle the queries by itself. So again, some of these things are configurable. I'll show you during the demo itself how you configure for some of these things. But Snowflake will be able to add more servers behind the scenes to cater for this. I do have a subsequent slides that will talk on a bit more in terms of the detail, how all these things work. But again, so I was talking about how we scale up, how we scale out. So these are what we call the various form of the multi-cluster warehouses itself. So it's very interesting because the way how you design the warehouse will really talk on a bit about the type of use cases or the type of workloads that you're catering for. So you could have one case that you can have a warehouse which is 16 servers behind the scenes, right? So maybe you want to scale for performance. You set up a one server of 16 servers behind the scenes to crunch some very heavy duty type of computation. Or you could on the right itself, you could be actually building for concurrency. That means you build a small server, but you build 8 of these small servers. So you can see over here that, but all in is also giving you the magical number of 16, meaning that you would be paying 16 credits per hour in this case, but it's being used for very different types of matter because I'm having more smaller servers to cater for the high concurrency versus one very large cluster to cater for the deep pipelining and for the complex SQL execution by itself. So how all these things works out is that is interesting in a way. Sorry, I'm getting a bit lag from Zoom itself, so this is pretty unresponsive. So I hope you all can still see the screen. But how all this works out is that we have what we call the multi-cluster warehouses. So this, you can see from the screen, there are 3 main examples. The first one is that I'm building what we call a medium cluster. And what basically happens is that this yellow line that you see here are simulations. So we are simulating that users are coming in. So I could have 5 users, 10 users, 20 users, 30 users before it drops out to 20 users, 15 users, 10 users, and 5 users, and so forth. And I am, putting in a standard medium cluster. So you can see that the medium cluster is only able to handle this baseline of load itself. So what happens is that as the number of users increases, you can see that the latency is obviously going to increase. because it's not able to handle all this load. Essentially, it doesn't have enough horsepower to handle all these users simultaneously. So there's a queue in here, so you can see that it's getting slower. But from a cost perspective, obviously, it's the cheapest because I'm just paying for a medium server. Now, likewise, maybe another administrator or another company might say, hey, we want to set up a extra large cluster because we need to be able to handle all the loads, including the peak itself. So this is traditionally what is happening in a lot of the companies. They will be building a gigantic cluster, but all in, they are really trying to handle that particular spike. So that spike could be a year-end processing, could be a month-end processing, but most of the time they are really, from a workload perspective, they are not going to benefit from that extra large cluster. So again, what happens is that they're paying extra, right? So all this area underneath these servers itself, they're all paying extra, because they're just all this hardware has just not been used. But from a performance perspective, it's not bad, right? Because you can see that an extra large cluster is able to handle all these. The latencies are manageable, but from a cost perspective, it's not the most cost efficient. Now, if you implement this, what we call the multi-cluster way of doing it, again, as your users come in, the 5 users, 10 users, 15 users, you can see that, from behind the scenes, more servers are being added into the pool itself. And as the users or the queries or the workloads decreases, that servers or pools of servers are being removed automatically. As a result, you get the highest throughput, you get the lowest latency, but also you get the most best bang for buck because you are only adding in new servers when you need it, and then you're removing it when you don't need it anymore. So this is really the modern architectural way. So you think about it in terms of how you will apply to your data science, to the way how you build your models and so forth, the horsepower that you need behind the scene, you would have the ability to run very complex workloads only when you need it, and then you can just remove the pool of servers when you don't need it. So if I put everything up together, this is how typically a very typical environment of how customers are using from a Snowflake perspective. So they could have all the ETL and processing, they could be using a medium cluster all along, and maybe during the weekend or during the month's end, they will spin up an extra large because they just have so much data that they need to do the ETL and transformation and so forth. And they could have a data science team working behind the scenes. So all these are provisioned on demand, and then they are discarded, or the warehouses are in fact suspended when they're no longer in use. So this data science team in this example itself, maybe they're just using it every Thursday, for example, to update some of the models. And then you could have your BI users, your sales team, they could be doing reporting. They could be starting off with a medium cluster, and subsequently they could increase to a 5 servers behind the scene before it gets down again. And then you could have all these ad hoc analytics, and so forth used by the other departments. You can leverage on the auto suspend and the auto resumption. So Snowflake will be able to handle all these workloads all at once. And if you compare it with some of the traditional data warehouse that you see out there, you will definitely be able to see the differences. So all this, right? So if I talk about the secure governed access to all this data itself, from a security point of view, this is how Snowflake keeps the data secure. So from an access point of view, from a network point of view, everything is secure and encrypted. TLS 1.2, you can even implement things such as IP whitelisting. You could have authentication. So this is, it goes a bit deeper down into the layer itself. So when at the authentication level, you could have things like multi-factor authentication. You could have key pair. We support SAML 2.0. If you have an IDP like Okta, then it makes it very easy for you to integrate it with Snowflake. From an application point of view, right, from a managing of the objects, you talk about things like role-based access control, you talk about things like secure views and so forth. Again, all this, we probably will have to go into a deeper, but a lot of this from a security point of view is provided by Snowflake. And then you talk about data. Once data gets into Snowflake itself, as it lands into the S3, earlier on I was telling you there's this icon that you see that keeps the data encrypted. And how do you keep it encrypted? So this by itself is quite a complex topic. So we can even integrate with some of the cloud HSM, for example, where part of the key is being stored by the customer's HSM. And then there's other things like key rotation and so forth. We have this very nifty feature called time travel, meaning that at any point of time from 1 day to 90 days, you are able to go back to basically kind of like undo some of the data or undo some of the changes, right? So say, for example, if a system administrator accidentally updated the wrong value in an entire stretch of column, for example, or whatever, you can in fact just undo some of these changes. Or if someone accidentally drop a table or drop a database, for example, you can just undrop the table, or you can just undrop the database. So this gives additional assurance from an operational point of view, so that then this is obviously a lot easier to manage. And then from an infrastructure, obviously, say for example, on AWS itself, we leverage on a lot of their physical security, on the redundancy, on the multi-AZ type of design. And earlier on, I was also talking about SnowGrid. I hope everything starts to make sense, because it's just so difficult to describe what Snowflake is all about. But hopefully y'all will be able to recollect some of the things that I was talking about earlier on. So that's just from a security perspective. And then if I move on, right, there's a few things, right? The way how we do sharing of data. So we do have this thing called a data sharing, data exchange capability. So in the hackathon itself, your data that you are seeing is in fact just shared through from other sources. You'll be able to leverage on the data marketplace as well. We have a lot of providers that's available out there. I will later show you all in the demo how all these things works, but you're able to get data. Maybe you want to get some footfall data, maybe you want to get some COVID data to train your models and so forth. Traditionally, you need to get the data, maybe it's from a JSON or a CSV or somewhere out from the internet, and then you try to download it and load it into your usual database or into Snowflake itself, and then you try to make sense of it. But this is very tedious. This is indeed quite troublesome, and what happens is that your data will be outdated in no time, because given how rapidly things are evolving. So I'm just taking, for example, COVID, right? So you can just grab this COVID data set through the marketplace, because we have providers that's providing all this up-to-date data. So there's no need for you to copy any data. There's no need for you to have any data movement. For example, you are just working on this single set of data that's constantly being updated. Whenever the publisher updates the data itself, you as a consumer will also get the updated data. So that's really a cool thing. So this is just an example of the data marketplace. You can search for the data. There's hundreds of providers out there. I'm not sure how it will help you all in terms of the the competition. So wishing you all the best, but certainly do take a look at it, because it really opens up in terms of how is what we call the art of possible. So earlier on, I was showing you this nebula, this whole kind of like star grid of all the dots, right, that's being interconnected with each other. So each of these dots are in fact one of our customers. So you can really see how organizations and companies are leveraging on data, forging partnerships and so forth, so that they have this competitive edge over the rest of the competition, right? So this is all powered by Snowflake today. So that's one thing. The other thing is, earlier on I was talking about data cloning. So it's a very interesting way. Very often, as you all know, that in the data science team, you all need to get timely access to data. You all need to get good quality data. It's always so difficult, because you could be operating an environment that you have your production data warehouse, you could have your UAT, you could have your tests, and then obviously trying to get the data across and to train and so forth. It's not something that's so straightforward. So Snowflake has many other functions. One of this is what we call data cloning, where you're able to clone or do a snapshot just in time, where you run that clone statement itself to have that data ready in a separate table or in a separate database, for example, for you to work on. So whatever changes that you do wouldn't affect the production copy of it. So yeah, in fact, just working on your own parallel set of data that you can obviously do more analytics on and so forth. So all of these things are, and we call it zero copy, because there's no need to physically copy everything bit by bit or block by block or object by object. So we are able to do this because, again, we have this thing called the global services. This is really like the brain behind Snowflake itself. It's able to know exactly what's going on and then provide the users, in terms of the management, in terms of the role-based access, in terms of security and so forth. So that's just one of it. The other part is that there's this thing called the data protection, the replication, the time travel. So earlier on, I was giving you all the example that, you can go back in time from a day to up to a 90 days. So in terms of what is happening, what are some of the changes, you are able to undo some of these changes itself. And we have indeed helped a lot of organizations, sometimes they were loading the wrong scripts and it has accidentally overwritten a lot of the data itself. So they are able to go back in time. So say for example, I want to go back to yesterday 6:09 p.m. because that was the time that we implemented the change and it was wrong. So we wanted to roll back some of these things back to the time point of time. So the time travel itself allows you to have a very easy way to manage some of these things. If something is to go wrong. So this is how we will say, from a comprehensive data protection perspective, there's a few things, right? So we talk about infrastructure failures itself. So all the data transparently, they are being replicated. There's a three-way ASIS behind the scene. You can replicate from a cloud, even from across cloud. So maybe from an AWS to an Azure that you have in another region that you want to build the resiliency. There's also the protection against the corruption and user error. So that 1 to 90 days that I was talking about, as well as this long-term data protection, right? So you could have what we call the zero copy clones. You could even export out. Depending on how you architect your strategy, for example, you could even export out some of this data onto a data lake into a S3 region as a Parquet format, for example, and this allows you to manage it accordingly. So with that, I just wanted to come to another polling question because not sure if you are still listening, because it's obviously still challenging to do everything through remotely. So this whole question is quite interesting. What do you think you are most likely to use Snowflake for? So obviously, I know given the context of this, Summit itself is a lot to do with AI and so forth, but some of y'all, maybe y'all have some data projects and things like that. After you hear about the way how Snowflake works, how we separate compute and storage, how it's being built onto the CSPs itself, how we offer this as a software as service. I think later on, as you do some hands-on, I believe y'all would have a better appreciation about the entire service itself. But maybe right now, y'all may have some, I don't know, projects in terms of data engineering. Maybe you all need to do some, data warehouse probably, right? Maybe you all can just fill up this and then I will just give you all another, I guess, 10 seconds or so. Yeah, so I think Jie Hong has already pasted the link. Okay, I see some responses. So I think some of you are saying that you want to use Snowflake for everything. So in terms of the way how you can share data, in terms of as a data warehouse, not so much in terms of a data lake, but yeah, I think most of you are saying that you are pretty keen to use Snowflake for everything. So I think that's good. So with that, let me just move on to some of the other resources. So as you embark into this hackathon itself, obviously, if you have any questions and so forth, you can check out this website. So it's called community.snowflake.com. So you can go over here, you can search for some of your questions, and then it will just give you in terms of the responses itself. So it's very useful. We have a very good documentation page as well. So it's called docs.snowflake.com, or you can just go through Google and just search for like Snowflake, how do I do role-based access control? How do I spin our warehouse and so forth? You'll be able to find, you will link directly into the docs page. From a training perspective, so we do have quite a fair bit of trainings. So we have what we call the Snowflake Fundamentals 4-day. We have some of the 2 days one. So it covers different topics by itself. So, but if you go to training.snowflake.com, you'll be able to see more details in terms of what is being covered. And then we also have the certification. So from a certification perspective, there are just like these two main ones, the Snow Pro certification. We call it a core certification itself, as well as what we call the architect. So this is a very advanced level. So it deals with a lot of very advanced topics. So if you're very keen to learn more about this, you can just check out the trainings website. So there's a section under certification itself that you can find out more information. So it's very interesting. I'm back to another polling question. And then after this, I will just move on to a quick demonstration so that y'all will understand how Snowflake works. So I'll be doing a quick harbor cruise so that y'all can see how Snowflake looks like. But before that, I will just give you another 30 seconds or so, So do you think Snowflake can help you to overcome your concurrency issues? Yeah, usually I do this poll. In fact, it's quite interesting. So the polls are, in fact, just to gauge whether the participants are still following us or whether they have fallen off. So because during the poll time, I'll be able to see whether, are they clicking on the thing or, clicking on the poll, or they're just maybe doing some other things. Because after all, today is a Saturday. I mean, really appreciate everyone for staying almost the whole day since morning itself. I mean, that's incredible. All right, I'll just give you another 10 more seconds. So yeah, most of you, in fact, 100% of you would say that Snowflake will be able to overcome your concurrency issues that you're experiencing today, and 90% felt that Snowflake will be able to help you to increase your query performance. So that's really interesting. So with that, what I would like to do is to go on to the Snowflake. I'll be doing a quick harbor cruise in terms of how Snowflake looks like. I hope you all will be able to see my screen. So essentially what happened is that for those who will be taking part in the hackathon itself, you'll be given a set of credentials, usernames and passwords to log in, as well as a URL. So I'm just going to try this on my own account by itself so that you all would have at least a basic understanding of how Snowflake works. So the very first thing is obviously you have to. Oh, there's such a lag. I don't know why. I can hardly type. Yeah, there's such a lag on Zoom. But you'll be able to log in. Obviously, you have some other methods like single sign-on and all those things. But I don't think we're doing this for the hackathon for itself. But I'm just using John. It's just a fictitious username. I'm just going in. I happen to be onto this region called the AP Southeast one. So this is in fact AWS Singapore. So as I log in by itself, I'm just going to show you how the user interface looks like. So there's a few things, right? So as you go in itself, I'm logging in as John. So you can see that John, he is assuming this role called the DBA CityByte. So you can create roles and so forth, inside Snowflake by itself. And then you can see that where am I? I'm logging into the AWS region. I'm going in from the Asia Pacific. That means the Singapore region itself. So this is my Snowflake look and feel. So there's a few main parts that I wanted to touch on by itself. So this is the place where you can change your password. You can switch your role. So again, I was just saying that we created some roles and things like that, for my own personal account. So I'm just going in as what we call the DBA CityByte role. You have some of the other roles like account admins. Account admins are users who are essentially like root, right? So they have all the full access. They even have access to the billing, for example. So if you want to put on your credit card and all those things, usually it's done by the account admin. Sysadmin, so there's a few other types of admins and so forth. You can find out more information from the documentation itself. For the purpose of the hackathon, it won't be too complicated. It wouldn't be like multiple users and so forth, because that's not the point, right? But I think you all get it that from a Snowflake perspective, there is every possible way to tighten from from the objects perspective, from a database, from a tables, from a views perspective. You can all set and configure some of these privileges and so forth. So I'm a DBA CityByte. I'm going in. There's of course a few other tabs. Now, what I find it very useful is this help page, because as you're set up, Snowflake, as you take part in the hackathon itself, you may need to download some of the drivers, ODBC drivers, for example. So where do you find it? So a very easy way every time that I'll go on is that I'll log into my Snowflake instance. I'll go into the download page. So once you go inside here, there's a few type of clients that you can download onto your laptop. So we have what we call a CLI client. So this is for you if you happen to have some scripts, that you want to run, you want to, automate in some form, you need essentially a command line client for you to interact with Snowflake. So this is where you can select, the Linux, the Windows, the Mac OS versions. You download it, you install it. There are some configurations that you can do, and then from there you can just interact with Snowflake through the command line itself. Excuse me. So you don't necessarily need to do this via the web UI. That's one thing. Or you need JDBC, ODBC drivers, and so forth. So this is where, maybe your Jupyter notebook, or you need some Python connectors. You need some of the other, ODBC. Maybe you're connecting through. Like Tableau and so forth, right? You can just download all these things and install it on your laptop itself. So there's a whole slew of drivers that's available. Snow CD is more interesting. So in the event that you run into any connectivity issue, so this is what we call the connectivity diagnostic tool. But most of you, if you're running this off, from your home PC, for example, or personal laptops, then I think typically it's fine. But if you have you are working on this through your corporate laptop, for example, there could be some firewalls and things like that, and you think that you are running into issues, I think it's a very good idea to download this thing called Snow CD. You will do a series of checks to make sure that you have access to the right port numbers, the right URLs, and so forth, and it will tell you in the report whether your connectivity is it proper or not. So these are, I find from a help perspective, is quite useful. And then I'm going to just to show you how Snowflake from an administrator point of view, how it works, right? So it's quite interesting because I have, the very first step is what we call the databases. So this is where you create the database. Now, again, it's interesting, right? Because I'm interacting with what I call the global services layer right now. The global services is the one that provides all this logical model, the security controls, role-based access control, and some of this functionality. So as I create a database over here, it is in fact creating, behind the scenes, right? If you still remember the architecture, I am landing all this metadata into the S3 blob storage inside AWS region, because I'm using AWS Singapore at this point of time. So it's creating all this metadata. So if I'm to create a test database, for example, you can see that it looks and feel, and it is like a data warehouse. It is a data warehouse, but the way how we build it is to leverage on all the cloud components, and then we create the metadata behind the scenes. So once I've created the database, you can create your tables, your views, your schemas, your file formats, and so forth. So I can have a test. Again, a database called test and a table called test, and you can add your column. Call tests again. Wow, so many tests, right? So you can obviously do all these things, but this is through the UI. Most people probably wouldn't do this through the UI itself. You're doing this through a SQL. So we are NC SQL compatible. So the look and feel will be something that most of you will be familiar with as you execute and run your SQL statements in Snowflake itself. So that's from a database perspective. And then we have some of these things called shares. Again, how shares work is that it's part of a capability to share data from one account to the next. So for example, I can say, I want to share a specific table, I want to share a specific database with another account. So there are ways in terms of how you can share the data. But what is also most important is that you can do everything through what we call the data marketplace itself. So you will be able to explore the marketplace. So this is how we have all this data that's available. So maybe I want to look for Star Schema. Star Schema happens to be a company, by the way. It's not that schema thing. So I want to look for COVID-19 data. So maybe, you might think that, okay, I wanted to make my hackathon more interesting. I wanted to bring in a lot more data. So where do I find all this data? You can come into the marketplace. You can search for it. So you can go by the providers. You can search by the business needs. So there's a whole slew of data sets that's been available. So take, for example, since we're still in the middle of the COVID itself, I wanted to know more about COVID. You can just get the data. So you can see that some of these data sets are free. Some are obviously these data providers, they are monetizing the data. So it will be commercial, you will need to pay for it and so forth, right? But other than that, you could still find quite a fair bit of data sets that's being available free of charge. So in this case, for this COVID data itself, I can just say I want to get the data. And then you can just say, I want to create a database. So essentially what happens is that when I get this data and I create a database, This data would then be made readily accessible on the database name that I've just mentioned, right? So in this case, you could call it whatever that you want, or you can just call it COVID and 19 or whatever that names that you want to give, and then you can just get the data. And what happens is that then a database will be created where essentially what happens is that whenever Star Schema, the company, whenever they update the COVID data sets, automatically that local database called COVID would also get all these latest changes, in almost real time. So that is really the power of this data marketplace itself. And it really paves the way in terms of a lot of the business partnership, because I mean, we've been working with so many customers, and a lot of them are telling us that they have difficulties in terms of sharing data securely. They are still trying to SFTP and putting data somewhere or into a S3 bucket region. And, over time, it poses security concerns that the data are outdated and so forth. And it's not easy to withdraw privileges, so to speak, because over here, once you are used to the Snowflake way of data sharing, you can easily just turn off access to specific customers and so forth, and you know exactly what sort of data they are reading and accessing, how often they read, or and some of these things. So that is very useful. So the warehouses, this is really the brain of the entire Snowflake by itself. So during the hackathon, you all wouldn't be able to create your own warehouses because we will pre-create the warehouses for you. But I think it's very important for you all to understand. Earlier on, I was talking about all the different t-shirt sizes, right? From an extra small all the way to a 6X large. So we really make it very easy. Extra small is a single server running. So if you run a single server for 1 full hour, okay, you pay 1 credit. If you run a 6X large for 1 full hour, you'll be paying 512 credits, because behind the scenes is really 512, like EC2 type of things running. And, you're talking about very, very massive. And these are 6X large is really meant for very, very massive type of workloads and computation that you need to do. Most users are very happy with a large or medium or even an extra small, depending on the workload. So the key thing about Snowflake is that you want to turn on auto suspend, meaning that because the global services will know if there's any users or if there's any applications that's interacting with Snowflake itself. If it detects that, say, for example, in 10 minutes, or you can set this to 5 minutes, or you can even set it to lower to a minute, for example. If there's no activity, Snowflake will automatically suspend the warehouse. So why do you want to do that? Because, well, if you suspend the warehouse, you wouldn't need to pay for any credits because it's suspended. So we don't need to charge you. That's one thing. And the second thing that is, I think, most important is that the technology itself allows you to auto-suspend, auto-resume at the flick of your fingertip. It's just so easy. So in the hackathon, you will see for yourself how easy it is to automatically suspend, to automatically resume without you needing to do anything. And all this behavior helps you to save the cost. And obviously, you want to make sure that auto resume is enabled, because if you disable the use for whatever reason, what this means is that the warehouse, may not automatically resume when you need it. And then if you turn off auto suspend, for example, never, you set it to never, means that I don't want this warehouse to be auto suspended. It's going to rack up the bills unless you know exactly what you're doing. And you have a very good reason for it. Most of the time, we always recommend that you auto suspend and auto resume the warehouses. So you can also set the clusters. So earlier on, I was saying that, hey, as you have more salespeople coming in, you want to automatically create the clusters behind the scenes itself, from 1 cluster to 2 to 3 to 5, right? So this is to handle the multi-concurrency. You can configure all of them inside here. So again, you don't really need to do this via the UI. A lot of people just do this, via the SQL statement itself. Once you are used to Snowflake, you just be doing this by the SQL itself. So in this case, I do have some of the standard, warehouses being created. You can see that they are all various sizes, because I would just be right sizing them based on the workloads, based on the type of task that it's supposed to do. So that's one thing. So I'm just going to touch on just a few last things. So the worksheets by itself will be something that most of y'all will be touching on, and this is where the bulk of the sequels, for example, if you're going to do this, the hackathon directly using Snowflake, or very likely you'll be doing this via Jupyter Notebook, for example. I'm not sure what sort of toolings that y'all will be using. But anyway, so Snowflake by itself has a pretty comprehensive worksheets that you can leverage on. So these are just some sample SQL statements. So you can see that, okay, I can just run this and set the context. There's always a history, and every of the query that you run, there's always what we call a query ID. And that's very important because through the query ID itself, you can then look at the query profiler. And through that, it's going to tell you whether query is optimized, whether you need a bigger warehouse, whether there's any swapping and so forth. And then you'll be able to tune for the performance and subsequently, right, to improve the queries and the system and the resources. So this is just very simple type of query. I'm not going to spend too much time in terms of telling you how it works and things like that. You probably can catch some of these via YouTube. We do have a YouTube channel. There's a lot of demos that goes on in terms of how Snowflake works. But again, this is just to show you that, we are fully answering SQL. Once you set up everything, you can say, for example, I want to create these tables. I want to create this trips table, for example, and you can see that a trips table has been created, and I can start to load data into Snowflake itself. So just for this, I'm going to load what I will call a some data that I have on the S3 region. Obviously, you guys wouldn't be doing this in the hackathon because will be loading the data directly into your account by itself. But you can do this, and then if I do a select count star, for example, you will see how fast Snowflake is. And what I'm running is that I'm just running on a pretty small warehouse, and then I can set the warehouse size to a different sizes. For example, I can start to load more data in, and then subsequently I can just set the warehouse to a smaller size, and automatically behind the scenes you can see how Snowflake manages all these resources on the fly. So it's quite interesting. Once I do all this, I can in fact just suspend my warehouse so that I wouldn't need to pay for this. So currently, if I go back to the warehouses page, because I've automatically resumed. So when I first started, all the warehouses were asleep. And then right now, as I load some sample data sets and so forth, you can see that the warehouses are in fact alive. And so you can see my node warehouses is currently alive at this point of time. So it's and I'm being charged for it. But we know that because I set up in such a way that this warehouse will automatically suspend in 5 minutes. Okay, so if we just sit here for 5 minutes, you can see that this thing will be suspended. Or I can go ahead and suspend this warehouse at this point of time. And then you know that, hey, once this is done, I don't need to do anything and the warehouse will be automatically suspended. So this is just some of the benefits of Snowflake that you all will get used to as you all work on the hackathon by itself. All right, so I think I am coming pretty soon to a break. So I'm just wondering if there's any questions or so forth that I can try to answer. Let me see.
I think the both questions were answered by Jaehong. So.
All right, very nice. So in this case, then let's go for a short break, and then we can be back in 10 minutes time. So yeah, in fact, oh gosh, yep. All right, so I'll see you all back in 5 minutes then. All right, thanks so much, everyone.
Imagine a technology partner invested in your dreams, where we take the time to understand your aspirations and give you the opportunity to transform them into reality through disruptive innovation. We are Aws Digital Labs. We are a team of IT professionals, data scientists, cloud solutions specialists, creative design engineers, spanning 7 global offices, we are enriching the lives of over 500 million people. We have successfully delivered projects globally, specializing in digital telco solutions, mobile money, fintech, IoT, AI, machine learning, data analytics, and self-care solutions. Using our expertise and domain knowledge, we have helped challenge the norms of industries and rewrite the rules of engagement. We provide our customers with agility. We provide them future-ready products now. Aws Digital Labs, advancing digital life.
The true potential of limitless insights has been out of your reach. The constraints of 40 years of on-premises solutions have persisted in the cloud, making the data your business depends on disconnected, siloed, and too hard to unite. Imagine the possibilities if the barriers to acquiring, uniting, and securely sharing data disappeared. No such access has existed until now. Introducing the Snowflake Data Cloud. We have built a global data network where your business can reach previously unforeseen potential. In the Data Cloud, Snowflake handles any data workload with virtually unlimited scale and performance. It enables instant, governed, secure, and compliant data access. It delivers a single experience no matter where data lives, no matter where you are. Across your business, across your ecosystem of suppliers, partners, customers, and with the thousands of organizations that operate in the Data Cloud, Snowflake unlocks the true potential of data, so you can uncover a new horizon of vast insights. Mobilize data like never before. Join the Data Cloud. Snowflake.
Your data is locked in dozens, possibly hundreds of silos across your organization. From your executives to your frontline employees, decisions are made more on gut than fact. To gain a truly competitive edge, you need to share data across your organization with suppliers, other business partners, and customers. But your costly, risky, and cumbersome methods only deliver stale, incomplete data. This has all changed. The Snowflake Data Cloud has arrived. Join this global network to discover, access, and securely share data throughout your business and with thousands of other organizations. So how does the Data Cloud work? The engine that drives the Data Cloud is Snowflake's platform. Snowflake customers use our platform to unify, integrate, analyze, and share data. They do this for many of their critical data workloads and at nearly any scale or speed they desire. Once you mobilize your data on Snowflake, that data becomes part of the Data Cloud. You retain complete control, but can seamlessly and securely share governed slices of your data with anyone in the Data Cloud. But how do you and others connect in order to share data? Through Snowflake's innovative secure data sharing technology. Unlike traditional data sharing methods, with Snowflake you can share live, ready-to-query data across cloud and region without any ETL. In addition to sharing data, you can also share business logic and services, ensuring your ecosystem has the data and tools they need. And with fine-grained governance and access controls, it's safe, secure, and can meet industry and region-specific data regulatory requirements. With the Data Cloud, you can create one-to-one, one-to-many, and many-to-many data sharing relationships. First and foremost, you can break down barriers of siloed data within your own organization and share data across departments, subsidiaries, geographies, and with your business partners. You can also find new data sets listed on the Snowflake Data Marketplace. The Data Marketplace is where SaaS providers, commercial data providers, data service providers, and Snowflake customers can list and deliver data sets and data services. Data products and services from over 100 providers can be discovered in the data marketplace. Why should you join the Data Cloud? To easily access your data and a vast array of third-party data, and to obtain the deepest insights about your customers, your organization, and what lies ahead. The Data Cloud. Mobilize your data. Mobilize the world's data.
Hi, Jiho. You can start the
So,
section. We can start the session.
all right. Can everyone see the screen?
Yes, we can
All
see
right.
it.
Yep. Welcome back, everyone. So, hope everyone has a wonderful experience in the first half of our session. All right. So, in the second half, basically, we are covering, really the essence of today's summit, right? So, on the data science workload for Snowflake. So, before we begin, yet another poll question. But this is the only poll question that I have, right? So, I think Tatwi has actually put that in the chat window. So I'll give everyone some time to take a look at it. I hope you have grabbed your drink. This is the home stretch. All right. So really it's more about, trying to see what you'll be doing with Snowflake in the area of data science. And I guess hopefully by the end of the session today, I'll be able to convince every one of you that, putting your workload on Snowflake will be the right choice for you. All right, with that, I will proceed on. So as Tatwi has kind of touched on in terms of the different workloads that we have, and I think more importantly in terms of the elastic architecture that he has elaborated, right? So I think from the UI perspective, you can see that it's really, really easy and simple to bring out compute clusters of different sizes. So if you think about doing that today, right? So if you are going to, spin off or provision some infrastructure to run some of your data engineering workload, preparing the data right before you publish it or push it into a machine learning model, before training it, before deployment, that bulk of the work, right? So if you think about that, how are you going to do that today? And I think with that earlier demo, it gives you a very quick sense in terms of how easy it is to have, the power of the cloud behind Snowflake and bring you that simplicity of leveraging, the compute environment, so-called unlimited, storage at the back, and most importantly is for you the ability to centralize and consolidate data in one platform. All right. So with that, let me walk through where we are fitting into the whole machine learning workflow. I guess for many of you, this workflow is definitely one of the common workflow. Of course, we can go into a little bit more details, but I think generally these are the main phases that you bring the data in, trying to build pipelines, getting the data in. You could be streaming data, you could be getting data from the open data marketplace, and of course on the Snowflake end, how do we actually enable that for you to simplify the whole flow. Of course, as data is coming in, there's a whole lot of visualization, coring, and trying to understand, making sense out from the data, and then hopefully we can identify key features, or we have to test, right, and see whether we have features that we need to better improve our models. And it's always a very iterative process, right? So you go on and on repeating the same process, but I think what is more important is through this whole flow, how can we simplify, and also how do we provide a very elastic platform to help you in this entire workflow. So what I'm going to do next is I'm going to introduce layers by layers. And of course, with that, we'll talk about some of our key capabilities from Snowflake, helping you in each of these process over here. All right. So I think we have covered a lot in terms of the platform and the architecture that we have uniquely designed to provide a very unique separation of compute and storage architecture. And not only that, if you look at how compute environments are automatically resumed as you're running your queries and suspending when they are not in use, right? So it's really something that you will never experience in other data platforms. So in that sense, it's really, one key platform that you can bring all your data in to power all the different type of workloads. Of course, I think today we didn't really go in detail in terms of the governance side of the house, but I realized there was a question around that. So how do we govern the data, right? So I think more importantly is how do we govern and put policies in place that is applicable to everything from a single platform perspective, whether you are working from a data engineering perspective all the way to data science and analytics. So how do you have a uniform policy and a uniform experience across all of them? And I think we have seen the unlimited performance and scale. I will definitely be showing that in the demo later on. But I think the key point to take away is really on this, right? So you can see that as we are spinning our warehouses up and down, you will realize it's going to be a transient, immutable kind of infrastructure, right? So it's in a way almost a serverless experience where you are literally not managing or maintaining any servers, but then you can easily, call upon a single node, extra small warehouse, or you can call upon a large or extra large warehouse going from 1 to 4 to 8 or 32 nodes, servers at any point in time. And all of these are done very easily. And then we are actually leveraging on SQL to perform most of these operations as well, right? So in that case, you'll see that there isn't a need for you to maintain, different EC2 instances. And as we all know, right, as any point in time, if you're spinning up servers, you need to maintain, and patch is definitely a very costly maintenance affair. All right. So with that, that really sets us the base as a Snowflake data cloud. So as we are building on top of this, so what are the other capabilities that we really bring to the table here? So of course, first of all, as we are bringing and collecting data, there's definitely many, many ways to bring data into Snowflake, right? So you could be landing data on S3, and then we could be loading that into our platform. I think earlier we talked about, if you're already, have a large amount of data that's already in S3 as a data lake perspective, how do we then map without bringing it in? If you want to leverage on Snowflake as a query engine, that is one possibility as well. But of course, in my demo, I'll definitely demonstrate, what is the key difference between loading the data directly into Snowflake versus, leaving them in S3 and leveraging on Snowflake as a query engine, right? So those will be the things that we would like to demonstrate. Of course, there will be other streaming ways of bringing data into Snowflake. Things like having a Kafka connector, so we will be able to subscribe to existing topics that you have already and bring those data into our table. So each topic will get its own table, and then you can further transform the data from there from a Snowflake perspective, as well as leveraging on our capability called Snowpipe, right? Because Snowpipe is a very easy way and it's a serverless way to bring in data into Snowflake as well. All right. So later on in my demo, I'm not leveraging on Snowpipe to bring in the data, but I'm actually creating a warehouse to load the data into Snowflake. So in those situations, usually we'll try to anticipate the size of the data and perhaps project a certain size of warehouse to bring the data in, right? So in those cases, if the data loading process is rather consistent, then we will know that a certain size of warehouse will be sufficient to load the job. And if you have seen the earlier chart about the cost and the duration to load a billion record, I always like that particular chart because I always like to quote one of our founders saying, faster is literally free in Snowflake, right? I can bring the data as fast as I can, leveraging a cluster as big as I want, but yet I'm still paying the same amount of money, right? So that will be part of my demo later on. Of course, then why do we need Snowpipe? So Snowpipe is actually a serverless method, right, to bring or to load data continuously into Snowflake. And in those situations, the data volume might be big, might be small. You can't really anticipate and size for a certain warehouse. So what you do is leverage on Snowpipe. It will be just a very simple and serverless way to bring the data in. All right. And of course, the data marketplace, why is it so important? I think as Tawi has highlighted earlier as well, I think what is really key is that as we are bringing data in, there are definitely a lot of open data sets that we can already work with. All right. And I think the main idea is that the data are available live and they are ready to be queried. So there's no need for you to, create a separate pipeline and bring the data in. And more importantly, if you're monetizing your data, right, as a data provider, you would imagine, let's say you are monetizing your data, you would like to provide it on the marketplace and consumers are consuming your data. You have your pipeline to, extract, compress, encrypt, and publish it into the ecosystem. And your consumers have to reverse that whole process, downloading, decrypt, uncompress, and load it into a table and perform further transformation. But what the marketplace really brings to the table is that this whole process of a table being processed into multiple stages can be all removed at the provider end as well as a consumer end, right? So you can easily share a data live and a consumer can easily consume it right away without moving or copying the data, right? So I think this is very, very valuable. So from a data scientist perspective, I guess what is useful is that we will always love to enrich our data. So, getting additional features requires some form of data enrichment as well. So it's very, very useful to bring additional data on board. Then, of course, the next thing is when we have data in, I kind of touched on this earlier about the external table. So we could also query additional data without loading the table using external tables. So in this situation, you have files in S3 already. We would create, a mapping and external table mapping, and we can right away query the data using SQL, right? So of course, I will definitely demonstrate what is the key differences from a performance perspective. Then that will give you a better idea in terms of how often are you going to query the data, because if the query load is low, perhaps it's easier to leave it outside. But then if you are always querying it, and as we know, Snowflake goes by a per second consumption model, maybe it's more beneficial for you to load the data in, even though there's data loading cost, but you will save in the long term from a querying perspective. All right. And then from a platform perspective, then what do you get during this phase, right? So I think this is a phase where we are really, really just mining the data and trying to make sense of what do we have in the data sets, what are the fields available, what are the values, what are the range. So in this case, we can easily leverage on Snowsight. So Snowsight is actually our built-in interface for us to then visualize the data very simply on our worksheet interface. All right, so just now, Tawi has shown you the worksheet interface. So part of it is that as you run your queries, you can also visualize your results and have some quick, rapid exploration of your data. So all this can be done within the platform, without leveraging on a separate BI solution, right? So, maybe you want to connect Tableau or QuickSight into the system to do some of this visualization, but sometimes we're just exploring the data. So we're just going to run quick queries, do some simple filtering, and that can be done within the user interface itself. All right, so that will really simplify the whole workflow. So I think the key thing is just to keep everyone productive, right? So we just want to save as much time as possible, without pivoting from one tool to the other, one interface to the other. All right, so this is just another view of the worksheet itself. So I could be putting in my SQL query over here. In certain cases, I could actually specify a where condition, and that could be defined as a dashboard filter as well. So based on this simple, SQL editor, I can actually create a dashboard out from multiple widgets. And in a situation where if you need to quickly publish, some of these data insights, and if you'd like to share to as many people as possible, and without additional licensing from a BI perspective, this is actually a very, very good way to do that. Of course, I would say at no point in time, Snowsight is meant to replace, any of the BI solution out there. It's really, an interface for you to provide a rapid exploration. And also if there's a need for you to publish, to a large amount of users, this is actually a very, very good way to do that. Okay. So I guess I'm kind of experiencing the same thing with Tadwi as well. You can see that my laser pointer is not really going that smoothly, but it happens sometimes. All right, so the next phase over here, I think this is where it's the most important part. And I know it sounds very cliche, it sounds very overused term where data prep, feature engineering, and transformation takes up 80 to 85% of a machine learning workflow. But I think that's a fact that we can't escape. So that's literally a fact. Everyone is facing it. So we know that we spend a lot of time really looking at the data, preparing, cleaning it up, and kind of extracting additional features out from there. So I think what we are providing in this part in our Snowflake perspective is during this whole feature engineering process, I think we touched a little bit on the zero copy clone. So I think this is really, really important, right? Because imagine today, if you would like to train your data, what is actually stopping you? So first of all, you have no production data, right? And getting production data might be a long-winded conversation, getting approvals, and more importantly, trying to get data cleansed, and there's PII data, you have to clean it up, you have to anonymize it, you have to mask it. So there's actually a lot of process to get through that whole phase of getting production data into your test environment for training. And if you don't have production data through simulation, it's not going to be effective at all, right? So we all know that. So it's actually very difficult for us to get production data. So from a Snowflake perspective, with this capability called zero copy clone, right? So you can easily duplicate data in Snowflake. And the key thing is, why is it called zero copy? It's actually not consuming additional storage. So let's say, for example, you have a terabyte of data, right? So you have a production table with very important data sets, and it's probably consuming about a terabyte, in Snowflake. In this case, if you like to make a copy of that, at the same time, apply a data masking policy in Snowflake. So we could mask out the PII data without changing the underlying values in the columns. So the original terabyte of data still remains, but we are making a clone, to the developers, to the data scientists, for them to perform their respective feature engineering. In those cases, because they should not have access to PII information, any PII values from a column perspective will be masked for them. All right, but then the production data still remains. More importantly, it's still a terabyte. You could be making multiple clones, but then we are just on the underlying storage, we are just consuming 1 terabyte. So that is very, very interesting. Of course, I often get questioned, what if there is new changes that's happening in the production table? And what if from a clone table perspective, there are additional changes as well? So the good thing is when I'm making a clone, it's literally making a fork, right, in the data itself. So the production will continue to be updated and changed. However, the underlying data for the clone at that point in time remains the same. Of course, if the clone data is taking on changes as well, it will be totally isolated. So you have totally independent data sets, right? But yet minimizing the storage, down to the bare minimum. Of course, as you make changes, those will have incremental storage consumption, but then the bulk of it still remains the same, right? So that's really, really flexible. And of course, you can iterate through very, very quickly. And when that is done, you can easily tear it down. So from that perspective, there's no worries in terms of leaving unused data around. I think sometimes the scary thing is that when we make multiple copies of data, we leave it around everywhere and we forgot about it, and we fail to protect the data with the right role-based access control, and then you get accessed by malicious or unauthorized personnel, and that's where all the trouble comes, right? So for us, in this case, because it's so easy and so agile for me to duplicate data, I don't need to worry about keeping the data because it's so slow. I can just easily reclone a fresh set of data next week, for my data engineering. All right. Of course, from the infra scale perspective, it's also very fast. I will definitely show this in the demo. I think it's hard to visualize what do we mean by instant warehouse resizing, but literally we could be working off a pipeline where we are loading data, we are making simple changes, maybe with a small warehouse. As I progress further down into my script, I have more complex, data joins, and perhaps I need to aggregate the data and perform a more complex analysis. I would then scale up to a bigger warehouse to then work through the rest of the script from a complexity perspective. Once I finish that, as part of my data pipeline script, I can then scale it down, because maybe at the end of it, I'm just creating some simple joins and that's about it, right? So in that instance, I can easily scale my warehouse up, right, to deal with a more complex workload. As I'm completing that and finishing it, I can actually scale it down, and that really saves us a lot of costs, right, in that perspective. And more importantly, you will not have any more underutilized compute resources, right? So in today's world, on the on-prem perspective, there is always, a certain bias in terms of over, catering for capacity, because you're worried about hitting the limits. In this instance, we can easily resize up and down, so you don't need to worry about utilization, because you'll definitely be utilizing the warehouse through and through. Of course, what are the other additional features that's absolutely useful, from a data engineering perspective? If things are already set in stone and you're kind of going to operationalize this model, you can also leverage on stream and task. So it's our Snowflake capability of handling CDC. So we have a source table where we will be monitoring the streams coming in. As you're making changes to the table, it will then be executing certain tasks, right? So task is basically a way for us to schedule a certain job in Snowflake. So in this case, I could be updating a table, and those updates will help us inform the task that's being scheduled to perform certain changes or kickstart, a whole new pipeline in ensuring that the new data that's being inserted can be then further transformed along the pipeline. All right. So I think the good news is that we have also recently announced a public feature for a serverless task, right? So in this case, no matter how simple or complex your task is, Snowflake will definitely manage the compute size for you automatically. So you don't need to worry about defining a fixed warehouse size for that particular task or that particular pipeline. External function is interesting. There are a few ways to use it, but in this phase where we are performing our feature engineering, so a very good example could be leveraging on some of the AWS services in terms of, sentiment analysis, or it could be translation, right? So there are some of these key services that they offer. So we can easily create an external function, and this external function can map to an existing AWS service to perform, I mentioned translation, right? So let's say you have, some feedback column with non-English or other languages, and you would like to normalize everything to English, for example, then we can use some of the translation services through external function, right? So this is really, really powerful because, you're no longer just stuck with what we have in SQL, but we can leverage everything else from our cloud ecosystem. Of course, last but not the least, NC SQL is kind of the native language in Snowflake. You can see that everything from data query to even provisioning our pipelines, our infrastructure of compute is leveraging on SQL, but it doesn't mean that it stays there. We have actually announced new capabilities as well. So we have the capability to execute Scala natively in Snowflake. So what this means is that you can actually bring your existing Spark workload into Snowflake as well. So instead of managing a few compute clusters, there's no need for you to do that anymore. You can actually leverage on Snowflake for all of that, right? So you can just leverage on one single elastic and flexible compute cluster to do that. All right, coming from the last few phases, right? So from a training and deployment point of view, so I think this is a part where it's really interesting, right? So we are actually partnering with the best of breed machine learning platforms out there, right? So you could be leveraging the likes of Sagemaker, Data Robo, H2O, Data Eco, and some of these other AI partners in the market. So what is really important here is that with our common set of drivers, it's definitely very, very easy for you to connect your machine learning ecosystem into Snowflake. All right. So what it really means is that we are actually not performing the machine learning training natively in Snowflake. So what we are doing is we're actually connecting to all these external platforms to execute, the bulk of the machine learning training process. But what is really interesting is coming in as we go into the architecture itself, we will then have the ability to deploy the trained model back into Snowflake, so that, from a training perspective, typically your compute power that you require for training is just maybe for that instance itself, you are iterating through, you have a 6 hours or 8 hours kind of compute requirements, and you're pretty much done with it. But then when you're deploying a machine learning model, you will run, maybe an hour or 30 minutes every single day, right? So it's a more long-term process, and you will then want to leverage on a more robust and elastic platform like Snowflake to do that for you. Of course, from a model management perspective, right? So it's definitely not an easy and simple affair. There's a lot of things to look after in terms of handling the models. So in this case, again, I would like to iterate, that's where we will partner with the best of breed solution. Is really giving you the freedom of choice to really decide, which are the partners or platforms that you would like to leverage on for your machine learning management. And of course, most common thing is that we have a lot of customers that will persist the prediction, the feature store, and all those things. We're scoring everything back into Snowflake, so that subsequently, we can leverage on, again, Snowsight to visualize some of this data, publish it out, and of course, from other analysis point of view, you can easily access all those data within Snowflake, right? So the key thing is consolidate the data, right? Leverage the capability of Snowflake to consolidate the data, provide that compute power to process the data, from a feature engineering perspective. Again, as I said, this probably take up 80% of your time and workload. So you would want to leverage on a single platform to simplify that entire flow. And as it comes to the training and deployment, that's where we leverage, of course, some of the key tools out there to provide, that capability. And it's going to be a very, very simplified way to do this. So how would it looks like from an architecture perspective? So let's start with this architecture from a traditional batch perspective. So you have Snowflake on the top. Again, as you're landing the data in Snowflake, or we are querying the data out from an existing data lake, for example, or getting additional open data sets coming in from the marketplace into Snowflake. As we are going to train our models, as I mentioned, model training is out of Snowflake. So that's where we will leverage on, the usual connectors. So your platform of choice will be connecting into Snowflake through the usual connectors, train the model, deploy the model, and in this case, the prediction runs outside of Snowflake. And then what we'll do is then we will then push the prediction back into the Snowflake data warehouse, for us to persist the prediction or the outcome, and then we will then, perform the rest of the analysis from here. Right. So this is a very typical way of a batch process, where again we push the data out for training and prediction, and then push the prediction back into Snowflake for long-term storage. All right, is scoring right back. So for the next deployment, this will be something different. So in this case, we are leveraging on, again, an external platform for training. And then after it's being deployed, the prediction model is deployed as a form of API. And in that case, we can actually leverage on external function. So as we are running the data sets on Snowflake, we can then invoke the external function pointing to the prediction through an API. So this is the most common method that we are using for SageMaker, or in integrating with SageMaker, where we would run the prediction of SageMaker through an API, mapped to an external function in Snowflake. Okay, so last but not the least, I think this is the most exciting part, where, let me just click through it. So we have, again, this capability as we push the data out for training, and we can actually deploy the model as a jar file, and this jar file can be then pushed back into Snowflake. So we actually have this capability called Snowpark. So it supports both running Scala and Java functions natively in Snowflake. So in this instance, I will deploy the model back into Snowflake so that we can perform our in-platform scoring. So in this case, the model has been built externally and we are deploying it back into Snowflake to execute the rest of the platform model scoring or prediction. All right. So I think Python is something that we will be announcing soon. So I think that is really, really exciting works coming up in the roadmap. So I'm so looking forward to that, right? So I think with Python, there'll be something out our sleeve that we'll be announcing. All right. So of course, from a partner ecosystem perspective, so it really depends on the spectrum, right? So I think the earlier session has talked about it as well. So if you like a low code kind of a platform, a auto ML platform, so of course we have the likes of our few partners over here, and some of them are actually listed on our Partner Connect as well. So it's basically our Partner Connect portal where you can easily trial Snowflake as well as say Dataiku or Data Robot. So it gets you a trial account on both platforms and it's already integrated, right? So you can right away, do your machine learning trials on this platform. But of course, again, being part of the developer community, there is always a notebook or a developer-based experience. So where you have, the likes of some of this platform as listed over here to run that through Snowflake. Of course, that will be leveraging through our Python connector. All right, so as we are going to transit slowly into the demo. So what I'll be going through in this next few slides is just to give you kind of a backstory in this demo. What am I going to talk about today, right? So this is actually a customer 360 use case. And this probably will be a reference architecture in terms of a 360 point of view deployment. So that's where we get, multiple types of data coming in. So we would have transaction sales data coming in as well as other user activity, click-throughs, impressions and stuff like that, coming through multiple services and leveraging on S3 as a data store. How do we then query the data through external tables, right? So let's say if we're not going to bring the data in, how do we then leverage on Snowflake as a query engine to query the data on S3? At the same time, we might have additional data that we would like to load into Snowflake and, clean it up using our stream and tasks through our pipelines, and then creating zero copy clones for our experimentation and feature engineering, and eventually training the model and push it for production, right? So this is a reference architecture. So in my demo, it will be something much more simpler, right? So we don't want to complicate so much from a demo perspective. So what we are going to do is that there is an existing data set that is already hosted on S3. So we have the likes of a store review, product review data set coming in. At the same time, we will have our sales order data, some web logs, and some social media data, right? So the last two data sets are what we call our semi-structured JSON formatted data. All right. So as we are pushing our data into Snowflake, there's a few things that we would like to do. We are looking at using just plain old SQL, but to perform a very complex and number crunching market basket analysis. So it's actually quite a simple query, but it's just that it's iterating through the table over and over again. So it's what I call a very time-consuming analysis, right? But then it's not really something very complicated, all right? And at the same time, we will be looking at clustering our customers, trying to identify segments within our customer base, And then hopefully through the additional data that we have, we could then perform, additional sentiment analysis through their reviews and tweets. And hopefully that will give us, a very targeted response to run our next marketing campaign. All right, so with that, I will switch over to my demo. As you can see, it's a bit lagging. I'm just thinking that my Zoom experience is slowing down a little. Okay, so you should be able to look at two screens. I think I have stopped my share. Did I stop my share? No, I did not. Okay. All right. Yep. So this is how I'm going to set it up. So I would be running the bulk of the demo through my Jupyter notebook. Then over on the left side of the screen, this is actually my Snowflake interface. So I will have the history tab up most of the time. So this is just to illustrate that this is actually a live demo. So I'll be refreshing this page, as and when, just to kind of demonstrate that this notebook is actually live, connecting back into my Snowflake account. All right, so as I mentioned earlier, so we have a couple of data set that's coming in, and largely this data set is all about a customer 360, and it's of a very simple e-commerce store selling, cookies and other CPG products, right? So we have, all kinds of food, snacks, and so on. But what are we trying to find out is who are the customers that has been buying cookies? I don't know about you, but during the COVID situation, I definitely stock up on snacks. But unlike some of the other people who are stocking up on instant noodles and toilet paper, but I'm stocking up on a lot of snacks. All right. So in this case, you would like to find out who is actually buying cookies, and more importantly, what are they buying beside cookies, right? So that is a very typical basket analysis. And in the case, we would like to look at the sentiments of them and trying to see, are they happy with our products? How can we retain them, right, if they're not happy, right? So being very, very proactive over here. All right, so this is how the rest of the demo will run. So I would have cells that will execute, a bunch of code. I will probably not be walking you through every line of them. It will take us the entire night to do that. So what I'll be doing is I'll be executing some of the cells, and I'll be just opening up and explaining the key parts of it. All right, and then I'll be demonstrating how some of these are executed at the back. All right, so of course, the first cell is really just to establish connectivity back into Snowflake. So you can see that there's actually a lot of SQL statement that's being firing. Basically, what we are doing is we are leveraging on our Snowflake Python connector, connecting into my demo account. And this is a new demo, so I'm actually creating all the database objects that I need for the rest of the demo. So you can see that I'm creating a database called retail demo, creating the schema to basically store all the other remaining database objects. I am creating an external stage over here. So in this case, I'm basically mapping to an existing S3 bucket. That's where all the data is. I am actually defining the file formats. So what is interesting is because I'm going to load the data from S3, right? But in this case, I need to tell Snowflake, I need to inform Snowflake, am I loading a CSV file? If I'm loading a CSV file, what is the format of the CSV file? Is it delimited by commas or tabs or pipeline? So that is something that we need to define. And when it's being defined, then we can actually load that in. So let me turn over to my Snowflake interface. So let's do a quick refresh. So as you can see, as I execute just one cell, it actually launched quite a fair bit of SQL queries out to my Snowflake account. As I mentioned, it's actually creating the database and schema, the formats and stage. So these are just some of the data objects that we'll be leveraging on later as we continue down our demo. All right. So this is very simple. It should be executed very, very, very quickly. So I'll move on to the next step. All right. So this is the part where we will kind of demonstrate how is it easy to scale And then if I'm working off an extra small warehouse, right? If I need it to be upsized to a bigger node, how easily for me to do that? Okay, so in this instance, I'll be creating a virtual warehouse, and then I'll be, first of all, leveraging from a data lake perspective, Snowflake as a data engine, a query engine, sorry, to query the data in S3. All right, so I've just a very simple SQL query, just trying to find all the orders that has cookies in the description, right? So you can see that I'm looking for the first 5 columns from an S3 bucket in this orders folder, right? Where, you know, column 3, which is the description, is like cookies, right? So what you will see here is that I have just launched this cell. So what it is that I'm going to create an extra small warehouse. So you can see that this, the third line, the SQL command that I'm executing is to create an extra small warehouse. So as the warehouse is turned on, you will be running queries of the S3. So if I were to refresh this page, it's actually completed, right? So you can see that I actually create a warehouse over here. Let me look at the name again. It's called platform_data engineering. You know, it's an extra small warehouse, and then I can actually launch a query against my S3 bucket. And then this is, yeah, so I think it's loading the data back. I should be seeing some results. All right, there we go. Yeah, so I'm just doing a very basic fresh pandas and then loading that into our data frame, right? So in this case, this is just the first few rows of our data frame. So we are looking at orders of, you know, kind of 50 pieces of candy cookies, right? So I'm not sure about all of you, but, you know, cookies can be very sweet. All right, so moving on to the next step over here. So I think the main thing that I would like you all to take note is that creating a warehouse is literally just within the seconds. I launch my query, and all in all, from end-to-end perspective, this query took me about 28 seconds, you know, to retrieve the data, query, filter it down, and then returning it into my data frame. So all of that took me about 28 seconds, right? So keep that in mind, right? So we are using Snowflake as a query engine into our S3. All right, so the next part here is that, let's say we are going to ingest the rest of the data. Of course, you know, this is coming to the late afternoon or evening of a Saturday. I don't want every one of you to be waiting for this. So what I'll do is I'll upsize, I'll change and scale my warehouse to a large. So let me just execute this as I explain it through. So what I'm doing is I'm going to change the size of the warehouse to a large, right? So literally from a single node extra small, I jump to small, medium, large, right? So 1, 2, 4, 8. I'm going from 1 to 8 nodes, right? In that few milliseconds. So let me just refresh this here. So you can see that now I'm copying some of my data into my, what's this, orders. So I'm loading the orders data into the orders table using a large warehouse. All right. So it's actually loading. Okay, so it's completed. So what is happening here is, as I mentioned, as we are designing our pipeline, you know, or our SQL script, right? So we have a simple process of data loading, and in certain situation, you know, data loading is actually a very simple job, right? So we can start off with a small warehouse and scale up as we are running a more complex analysis. However, in this case, I'm actually just scaling out so that I can ingest 200 million orders in this amount, 25 seconds. But then I actually scaled down to an extra small warehouse, and then I'm going to run a query against my orders table. So it's actually exactly the same. I'm selecting the first 5 columns where the description contains cookies, right? So in this case, the query finished in, wow, 2.2 seconds. Okay, so then the next thing is we are going to look at some of the semi-structured data that is actually stored over here. So right now, this is going to be a very interesting SQL query, but what I will do is that, let me just double check. I think it's all, yeah, my semi-structured data is actually loaded in. So what I want to do is I want to go back to my worksheet over here just to run this particular query. Okay, so in this case, this is actually the product reviews data. So you can see that from in this perspective, right? From a table perspective, there's only one column. So the column is actually raw JSON. So I'm just creating a column, and the data type is actually called variant. So it's our unique data type in Snowflake to allow us to store semi-structured data. So in this case, you can see that this is a JSON formatted data. The usual key value pair, and it's basically stored in a single column. Of course, I could then, be pushing this data out to the users, but then, they probably need to wrangle the data a little bit because they need to kind of navigate through the JSON notation to get to the location and the name. So in this case, we are not going to do that, but what we are going to do is to create a very simple view so that we can represent this information as columns, right? Then when we are loading that into a BI solution, it's much simpler for the users to, run their self-service analytics. All right. So in this case, this is stored as raw JSON in a single column. So moving back to my next cell as I'm executing it. So this is a very simple one. I am now, instead of querying it as a single column, I'm going to map into the individual column like this, right? So I can map through the raw JSON. As you can see, this is actually navigating through the JSON structure. And with that, I could then present the data as a tabular or column-based table structure. All right. As you can see, querying JSON data in Snowflake is very, very fast as well. All right. So this is the interesting part. So let me run this as I talk through it. So what we are doing is we're actually getting the previous query that we have ran. So if you remember, we ran the same query twice, looking for all the orders that has cookies. So first, we have actually ran it as Snowflake being the query engine. So instead of loading the data into Snowflake, right, I'm just leveraging on a data warehouse in Snowflake, processing the data that is existingly in S3 today. All right. So in this case, it's taking me about, just round up to 30 seconds. So it took me about 30 seconds to run that query. But at the same time, if I'm loading the data directly into Snowflake, right, so I could then run the exact same query. Yes, you can see that, the results, the performance is at least, right, 10 times faster, right? So you can look at this different design. So we have one where there is an existing data lake that is sitting outside of Snowflake. I think what is really challenging sometimes is that when we are implementing data lake, governance is always an issue, and it's very hard to implement the policies properly and correctly in such implementation, right? So there are many buckets to consider, and navigating the IAM policies is always not an easy affair. So what we are doing over here is we are just querying the data off S3, all right? So in the middle design, so that is where it's kind of an in-between. So that's where I could actually load all the data back into Snowflake. Sorry, I should be referring to the last one. So instead of, so I'll be loading the data into Snowflake, so that I will then run all my queries off Snowflake. And more importantly, in this case, I will be able to leverage off, the other capabilities like zero copy clone and time travel, right? So time travel is a very interesting capability. So if, let's say, I did something wrongly, I have updated the wrong data, I can easily roll back the data to that point where, I've done that wrong insert or wrong update. Okay, so I hope that you get to see the differences between using it as a query engine or loading it directly and running it natively in Snowflake. right? So easily you get 10 times faster. So if you have noticed that it takes time to load the data, but then if you're querying the data very, very frequently, of course, it definitely make more sense to load the data into Snowflake. All right, so let me ingest the rest of the data. So I'll just run this cell. So I think this is our customer data. All right, these are all completed. So again, we are going to transform some of the JSON data. So in situations like this, sometimes we would like to persist the semi-structured data as a table. So instead of just presenting a view of JSON as what I've done earlier, for even faster performance, then maybe I would like to then persist the data as a table. So that's what I'm going to do here. Just expand this. So in this case, I have that same query. And what I'm doing is I'm just going to pull out the values out from this JSON, but instead of presenting as a view, I'm just going to create a table based off this. And remember, right, so even though I'm executing this manually, with streams and tasks, you can actually automate a lot of all this in Snowflake already, right? So with this whole pipeline, we can track a source table, a staging table for changes. And then as the changes are coming in, then we can schedule the tasks accordingly to execute the rest of the pipeline. Okay, transform data is inserted into our web logs stage. So I'm going to do the same thing for my Twitter data as well. In this case, I'm not creating a table. Sorry, I didn't really see it properly. So I'm actually creating a view instead, right? So in one situation, I'm creating a view. In the other situation, I'm actually creating a table. All right. So in this case, we are going to make some sensing out from the data itself. We're going to perform some, simple sentiments analysis using machine learning. So in this case, as I mentioned, we will not have the libraries in Snowflake to perform that. So what we're actually going to do is we're going to import additional libraries to perform that particular analysis. So this is where it's going to run some analysis. So let me see, where is it here? Yeah, so you can look at so there's some functions that's being some methods that's being defined here to perform the sentiment analysis, right? So again, I'll not go into detail, but what I'm trying to highlight here is that we are selecting those columns that we need, loading back into our data frame, running the analysis, and once the analysis has been computed, we will then write the result back into Snowflake. All right. So let's take a look. So tweets has been processed. We have reviewed. We have processed the review as well. So all this has been updated, and we are writing it back into Snowflake. Right. So in this case, we can leverage on a few things, as I mentioned. This is just running off Python from my Jupyter notebook. In other situation, you could be leveraging on Sagemaker as well. So if there are some of these services exposed, we can then map an external function back into AWS to perform this particular analysis. Right. So the next part here is that, how do we then move this information into production? All right. So this is where, we have talked about the zero copy clone, right? So let's just open this up before I run it. So you can see that I'm just going to execute this command over here. So I'm shifting my web logs from the staging schema into the production schema. So let me just execute this particular cell. So this is about 3 gigs worth of information, 200 over million rows, and everything is just replicated within seconds, right? So you can literally just imagine, right? If you have 3 gig of data today, even if you have the fastest SSD, you want to copy and paste, perhaps it might be 3 seconds or even less, but then we are actually replicating an entire table. And this is done very, very quickly, right? So because this is going back and forth through Python, if I were to go back to my history page and just click on the SQL query over here, you can see that when I'm going to clone this table, it literally took me less than 1 second. Right. So remember, because making a clone is really a metadata operation. So we are just, basically creating a new database object called orders in the production schema. And this case is mapped to an existing cloud storage micro partitions. So I think we didn't really go much detail about that today, but just to keep everybody informed, as we are loading data into Snowflake, we are creating what we call micro partitions at the back that is storing into our cloud storage. And in those cases, they are immutable. So it actually allows us to reference back the same set of micro partitions through multiple clones. All right. So in this case, the clone took me less than a second, and that's done. So coming down to the next part here. So in this case, we are just preparing the different views so that our business users or our data analysts will be able to access the data. So again, we will never want to expose the JSON view directly to the users. So it's definitely more useful to structure it as a proper view with the right column so that they can have proper access to the data. All right. So the next part here, all right. So this is the interesting one. Market basket analysis, right? Quite a tongue twister over there. So again, we have 200 plus million line items, and the whole intention here is that we are trying to identify what are the common items that has been usually purchased alongside with a cookie, right? So this is again building towards a recommendation engine. Of course, there are many ways and other algorithms to achieve this, but in our situation, we just want to find, what are the other products that's commonly purchased together by iterating through the entire line items table, right? So in this case, I won't say this is a very big table, but just that there is so many items and we are iterating it through over and over again to find, a match, right? So I won't say exactly that it's a complex query, but it's a time-consuming query. So what I'll do is kick this off first while I'll explain. So in this instance, I'm going to create a brand new warehouse, right? So I actually started and create a new marketing_warehouse, large. So a large virtual warehouse is actually an 8-node compute cluster in Snowflake. So you can see this is the SQL command statement over here. Right, so we have literally iterated through 200 million orders. But then, as you are thinking about this, right, so I need to iterate through many times. So it took us about 11 seconds. And impressively, this result set actually created, a couple of billion rows. So what we can do is, let me click on history again. Let's refresh this. So you can see this is actually the very complex query. So it took us all in all about 10 seconds. I can actually click into the query itself. So we would have a query profiler. So this query profiler is really useful. It gives you the ability to then look at how long your query is running. It's kind of big. Let me just zoom out. So give you a quick ability to then kind of analyze and investigate, right? So whether is there any part of the query that can be optimized, right? So in this case, you can see that we are working with 200 over events as we are iterating through getting back to the result. So you can actually see along the way, the amount of data that we are working with, At this point in time, we have a couple of million rows and so on. All right. So all in all, this is about 2.8 gig worth of data that we are running through. Okay, so we have kind of identified some of the key products that has been commonly sold together with cookies. Now we are going to segment this this customer set. So based on what we have identified with all this additional information, we are just going to create our customer segmentation. So this time, because it's not going to be a very big workload, I have created a medium data science warehouse. So I don't know if any of you are keeping track. So how many warehouse have we actually created? Let's see, right? So we have one. So the latest one is actually our marketing warehouse. We have a platform data engineering, we have a marketing warehouse, and we have a platform data science warehouse. So all in all, we have used about 3 different warehouses, and then we have changed the size up and down along the way. So what does it mean, right? So while as flexible as it can be on Snowflake, I think the main point is that we can easily right size the workload and then create the warehouse or create the infrastructure that's required to run our computation. And in that situation, there is no resource contention. Imagine I'll be running the market basket analysis at the same time as the data scientist that's running their sentiment analysis, right? So we could be running all of this concurrently, but because I'm spinning up different warehouses and each warehouse will be dedicated throughout the entire duration of their workload, so we will not face resource contention. All right. So over here, we have identified roughly 4 customer segments, right? So I'll not deep dive into it. I'll just continue to move on. This going to be the last one over here. So we are leveraging on the Facebook Prophet to kind of forecast a time series event. So this is based on the number of web visits that we get from customers that have bought cookies. So we are going to forecast, in the coming few days to see whether we have an increased demand of cookies coming in. And of course, that will allow us to plan our campaign, maybe launch some new coupon codes to entice more customers coming in to buy their cookies. All right. So this is going to be a simple plot. So we are kind of using existing time series data based on the visits that we have from cookies buyers, and then forecasting the future periods, right? So we can see that, it seems to be an uptrend, so we should better be stocking up on cookies. Of course, last but not the least, all this information can be easily visualized on different platforms. So in this case, I'm not building any more additional things, but this is kind of an example of what we can do here. So with that, let me pivot back to my slides. Seems like it's acting up a little bit on me. All right, so what are the key takeaways? So let me get back to my presentation mode here. So what are key takeaways? So really is to look at Snowflake as the data cloud, right? So the one and only data cloud to consolidate all the data that you have from your sales data, your machine data, and everything else, consolidate back into a single platform. And you can see the support for structured and semi-structured data is natively built within the platform. And I'm so glad to announce that we have launched a public preview in supporting unstructured data. So I'm so much waiting for the support of processing the unstructured data in Snowflake. Right? So that will be amazing. All right. So of course, with third-party data sharing, we can easily onboard other open data sets, especially in this COVID situation. If you need to get those data sets, you have to kind of ETL the whole process from GitHub into your platform, but we can easily just with a few clicks, we can actually get the table right away in Snowflake. Of course, we have talk about this, as through my demo, what I've demonstrated is that we have load the data, we have run, a couple of processes, business logic, preparation, feature engineering, and the most important point is that I actually created 3 different warehouses. At any point in time, I could be running them concurrently, but I can't do that, right? So I'm just, a single person running through the notebook. But think of it this way, everyone would have their own warehouse to run their workloads, and it's delegated for each team so that it simplify, there's no resource contention, and more importantly, you don't need to worry about the ever shrinking ETL window, right? We can always upsize the warehouse to perform the workload as quickly as it can. Again, from an integration with the rest of the machine learning ecosystem, I kind of demonstrated, a few libraries here today. Of course, for those who are looking for a low or no code environment, a auto ML environment, you have the partners to look at. But at the same time, if you are sticking with good old Python, what I've demonstrated today will serve its purpose as well. So with that, I've come to the end of my presentation and my demo. So I'd like to thank everyone for the time today. So I think we have a few more minutes on the clock. So if there's any questions, feel free to pop your questions in the Q&A window. Probably with that, I'll hand this back over. Yeah.
Yes. Thanks, Jehan, for that long and long explanation. So yeah, we are open for Q&A at this moment. If you do have a question, any clarification, you can type your questions in the Q&A section. Okay, I get it. Okay, that's one question. Do you use the Hadoop ecosystem as the base technology?
Yeah, so that's a very, very good question. So I think all in all, the short answer is no. What our founders have really done is that they have actually built the entire data platform from scratch. I think as we mentioned, without any existing baggages, right? So we have built everything natively in the cloud. So you can see the way that we are leveraging on the compute, the instant resume and suspend is really something that is never seen before in other data platforms, right? So can safely say that it is something that we have built natively from scratch. Yeah, so we are not leveraging on any existing platform to do that.
Oh, I think that answered the question. Do we have any more questions? We encourage all of you to ask questions if you have. Yeah. Seems no questions. Okay. So, yeah, there's another. Yeah, sorry. Okay, how is Snowflake compression work?
Yeah. Yeah, so I think I answered a similar question earlier. So I think the main thing is to look at how Snowflake is being delivered, right? It's basically software as a service. So you will see that from the way I'm defining my entire process, there is literally no consideration around how do I encrypt my data, how do I compress my data, how do I partition, do I need to have indexes and things like that. So if you see through the entire process, although we did not dwell into the individual SQL statements, generally you see that a lot of all this existing optimizations, compression handling, file partitioning, and planning is literally all taken away. So in a sense, it's very good because it's going to make you so much agile in bringing the data into Snowflake, and you are really focusing on your use case at hand. So you can see that through my entire demo today, I am just really focusing on getting the data in as quickly as possible. So from an ELT approach, I just extract from an existing system, load it into Snowflake as quickly as I can, perform the rest of the transformation and data engineering in Snowflake, running my sentiment analysis, running my prediction. So that is really what you need to kind of focus at. So you don't really need to think about, oh, should I be looking for a 24 node cluster? How many memory do I need to maintain the disk space? Then all those things are really, really taken away. So we are really simplify, the use of a big data platform, right? So in traditional computing clusters, it's very, very hard to manage your compute clusters. But in our view, we are keeping it as simple as possible, right? So focus on the task at hand, getting the data in, getting the insights out. That's what we are here for.
All right. I hope there's no other questions. I think both of you answered some of the questions already, which was typed in the Q&A before. So yeah. Okay. So So let me thank both of our speakers from Snowflake, Hatvi and Jayhawk. Thank you so much for your time and effort in explaining and having a long session on Snowflake. As I said to the audience at the very beginning, so it's going to be a day full of details and knowledge. So I think both of you helped us in accomplishing this objective. So once again, on behalf of ADL, I thank both of you for your support and hope for your support even in our future events also.
Thank you, everyone.
Thank you.
So,
thanks for hosting.
For the attendees, if I just want to remind or just give a couple of notice for our next event. So we are in the middle of pre-hackathon stage. So the pre-hackathon will end on 19th, 11:49 p.m. So once it's ended, so within the 20th day, within the next day, we are planning to publish the results and announce the winning teams. And also we have organized another Q&A session on the 20th around 4 p.m. For the hackathon. So the selected teams from the pre-hackathon stage can participate there if you and get clarified on any questions that they have on the hackathon. So that's the next upcoming event of this ADL AI Summit. And I will thank all of the attendees here and the people who have watched us through all the social media platforms, the live streaming. Thank you very much. I think we have given you the necessary knowledge, and we have given you all the experience. So thank you for joining for today's session and bearing with us for the entire day, almost the entire day. So I wish all you best for the people who are going to participate in the pre-hackathon and the hackathon. So, and also for the others, thank you so much. And let me conclude the first event of the ADL AI Summit with the AI workshop from here. And I wish you all a good day.